Welcome to Ubuntu Summit 2510. Woohoo! Oh, wow. This is an event for the bold and ambitious. This is an event to celebrate open source. This is an event where we want people to get inspired by technology and open source technology in particular. We want people to create, to do wonderful things with open source. I'm Sebastian. I'm your host this morning. I'm also the head of our community team at Canonical. I also want to welcome those who are watching online on Discourse. You can expect online to see polls and Easter eggs. And watch out, the games are starting right now. So watch out for these Easter eggs. In the spirit of open source, the Ubuntu Summit is free for everybody to join online and offline in person. Anyone can join the conversation, and we'd love for you to ask questions on Discourse, discourse.ubuntu.com. And remember, your gateway for the summit, your multi-pass, is the Discourse. So go to ubuntudiscourse.com. Because one stream is not enough. We have another stream online, and it's artists who have specially created music for this event. Of course, it's with Creative Commons license. So if you want to have a break from the talks or during the coffee breaks, for those who are online, you can go to the second stream that you'll find on Discourse. Let's get started right away. We have a packed agenda today and tomorrow, and our first speakers today are no less than the founder and CEO of Canonical, Mr. Mark Shuttleworth. Please welcome Mr. Shuttleworth.
Thank you, Sebastian, and hello to everybody who's joining us online. And most of all, hello to so many wonderful people that have joined us today here in London. It's quite a privilege to look around the room and see some legends of open source, and I think perhaps some future legends of open source as well. I'm both excited to hear what you have to say and honored that you would come and be part of this forum. And that's really the humbling thing about everything that we do in open source. We are surrounded by giants, and while each of us has our part to play, each of us has our pride and our investment in the thing that we're trying to do, I think it's incredibly important to step back and just appreciate the way in which we work together to build a future that really couldn't exist any other way. Anytime I see something that we've wrestled with and grappled with and achieved, I'm constantly reminded of how much of that thing came from elsewhere because of open source. Right? We have this extraordinary interdependence. Even our rivalries are a source of interdependence. At a time in the world when technology is balkanizing and countries and geopolitical blocs are saying they want sovereignty and independence, in every single case, the strategy for independence depends on a shared thing, which is open source, right? And so this is an extraordinary counter to the prevailing narrative about technology, right? I absolutely believe it is open source, leaning on open source, that will enable people all over the world to build their better futures. Of course, our motivations are diverse, right? My favorite motivation for open source is rare but beautiful, and it is just joy, right? The joy of building something, getting it right, making it for other people, the love of that thing and the craftsmanship of that thing is a truly wonderful motivation, and a lot of meaningful open source is built on that. But we also see people engage in open source and contribute to open source out of commercial strategy. Sometimes we see that out of a desire to create something that wouldn't exist any other way. Sometimes we see it as sabotage, right? In the game of creative destruction and the commoditization of somebody else's business to create an advantage. These things are all true, but what they fuel is a rising tide for everybody that is deep and meaningful and extraordinary. Sometimes things are built in open source purely out of shared need, out of a desire to be part of something, to have a shared experience, a community. That's another really beautiful motivation for what happens around us every day. In all of that, the distribution is an unusual thing. And a distribution is an aggregator, right? A distribution exists to honor and represent and pass on the work of others, right? And there's a set of obligations, I believe, a distribution has, right, in that complicated landscape, right? And part of that is about finding the balance between the choices that we make for joy or for strategy and the choices that other people want to make, right? The things they want to use. And this is a complicated dance, but one that I take very, very seriously. I think distributions are in a privileged position, right? And I'm very mindful of the fact that for an individual creator, an individual innovator, an individual project, an individual upstream, the constraints on them are very different to the constraints on us. And that's why I think it's important that distributions essentially make their choices, but they also enable other people to make different choices, right? It's important essentially to enable people to explore territory that you yourself can't or won't explore. And that brings me to the other side of the coin, which is the distribution as innovator, right? Very fundamentally, we distribute. Very fundamentally, we essentially bring together work from other people and pass that to the world. But we also have an obligation to innovate. We also have an obligation to think deeply about the shared concerns, the problems that no single upstream can solve for themselves. An upstream can choose Java, but they can't necessarily choose the Java interpreter you're going to use, that they're going to have to, that their joy is going to be expressed on, right? And so there's a really important obligation on us to innovate in those areas of shared concern. Security, right? The Postgres community, which is an absolutely extraordinary community of diverse collection of organizations, really something unusual even in open source, right? Many companies collaborating and competing at the same time on a relatively egalitarian basis. But think about the trust they put in distributions to essentially say, well, you're going to enable people to use our work, right? And that community can't determine things like the security of your data, but we can have a significant impact on that, right? Operations. You know, to build the tool is one thing. To deploy the tool at scale, to deploy the tool in an environment that is dynamic, that is changing, to deploy software in heterogeneous environments at the cloud and at the edge, right? These are complicated concerns, and they represent really the cost of free software, right? Again, these are things that I think distributions really should think deeply about. Efficiency, right? Think about energy. Think about a CPU burning energy. We have an obligation, regardless again of the the prevailing narrative. We have an obligation to make sure that that energy is spent well. And software doesn't do anything without consuming energy. If we can make your software burn less energy by using the latest capabilities on the chips that you have just bought, then that is a beautiful thing that we can do for the Postgres community and for the people using Postgres and for the people making chips that can work more efficiently, right? Integration. The idea that nobody uses a piece of software in isolation. People use software together to get things done. And the responsibility that we have to think about that integration process and to make that simpler, cheaper, more reliable, less of a burden, right, in order to get more out of the generosity of the people who contributed that open source in the beginning. Now, when we were born, we already had many, many Linux distributions, and very good ones. We had Linux distributions that defined themselves as commercial. They were businesses. And we had distributions that defined themselves as for the love of it, or for the interest of it, or for the benefit of others. And we chose a more difficult path to be both a commercial distribution, but one that deeply valued and thought about social impact. The world didn't need another proprietary Linux, but potentially there was an opportunity to create something that had as a deep commitment the upliftment and the outreach to people who would be excluded by something that was purely commercial. For me, it is a very deep part of what we do, right? It amplifies what I would call the fundamental generosity of anybody who makes an open source contribution, right? Anybody who makes an open source contribution, no matter what their motivations, is doing something profoundly generous, right? Giving away their insights, giving away the benefit of their intellectual wrestling with a hard problem. And that is a beautiful thing. We choose to amplify that, right? By making sure that it can land in the hands of people who could never participate in the top tier of the economic race that is the software and technology industry, but who personally can benefit deeply from that open source. In that way, I really believe we unleash innovation in a way that a purely commercial story can't unleash innovation. How many entrepreneurs, how many innovators, how many scientists and doctors have ideas but don't have access to the tooling or the markets to essentially get those ideas to market? For me, it is a deep privilege and obligation to build a bridge between the wealthiest parts of the world and industry and the poorest parts of the world and future industries. Sometimes we call it our Robin Hood problem, although I'm not so sure that I want to be characterized as stealing from the world's wealthiest organizations, so much as figuring out how to offer value and then how to turn that value into something that essentially can light a spark of goodness anywhere in the world. In this way, we pay it forward, right? Many of us here in the room are where we are because somebody else made some open source. And in this way, we can be part of essentially paying that forward to the next generation of people who will do wonderful things with open source. Now, as I look around the room, I'm reminded of how complex the ecosystems are in which we live and breathe. And I want to start really at the foundation of it in the silicon world. Now, I confess, I don't know how to make CPUs. I'm told that it's a little bit like making software only harder. and what I can understand about it is that the economics of making silicon are brutal, absolutely brutal. And very few people really trouble themselves with trying to balance the truth about technology and the truth about economics. They're both difficult, a bit too much to hold in your head for most people. But I really try to think about, well, economics and technology. And I think in the silicon world, economics are brutal. The investments that are required long before a return can be generated, the uncertainty around those investments, the vision required on a 5-year type timeline to essentially say, that is what we're going to build, that's what we're going to deliver in 5 years' time. That is what we think the world will want to, how the world will want to make its electrons dance. I find that extraordinary. The spectrum of silicon, right? We tend to narrow our focus to a hero product, a hero narrative, whether we're drawn to margins or performance or something else. But in this room, we are surrounded by silicon. We're surrounded by silicon, doing all sorts of things for us. And the future is even more immersion of compute in the worlds around us. And I really want to salute and celebrate silicon companies that are able to bring this intense intellectual focus to that game across such a vast spectrum of compute. Of course, silicon needs software. That investment, that bet, that vision of the future will only be realized if software takes advantage of it. And so it's a profound obligation, I think, that we have to join with silicon companies in figuring out when their 5-year bet, when it's time to ship their 5-year bet on the future of silicon, that the software is there, ready to go, in the best form that we possibly can make it to see what's going to happen in the market, right? To bring that to reality. So in a very real sense, the measure of something like Ubuntu is the extent to which it embraces and reaches out and collaborates and partners with the people who are making the silicon that the world is going to run on in 5 years' time, in 10 years' time, in 20 years' time. And I'm delighted to see, looking around the room here, people who have partnered with us to essentially take those bets on the future together. And my firm commitment is that we will always be a neutral platform for your bets on the future of silicon and software together. If I come one step up from silicon, we see the extraordinary world of clouds. Now, I think it's easy to underestimate the unbelievable impact that cloud computing, public cloud computing, has had on the pace of innovation. It is as if we lifted enterprise compute out of the mud, right, and into a cleaner place where we could more objectively, more rigorously understand what we were doing, how we were doing it, right? And that's an extraordinary thing. I'm not of the view that all compute is going to end up in one giant cloud, right? So I deeply believe in the importance of public cloud computing, its centrality to the future, its forward motion as an efficient way to harness silicon at scale for centralized computation. But I think there's another benefit that we've all got from cloud computing, which is to rethink computing fundamentally and bring that to other domains, right? Domains that the cloud can't serve, right? I see people adopting cloud-native practices, all sorts of places around the compute spectrum that have nothing to do with the cloud, right? And that's a really profound, I think, acceleration of innovation in the world today. It is, of course, a transformation, again, of economics. This balance of economics and technology that is so interesting. And a call to every organization to focus on its core value, right? To a sort of a statement that common infrastructure, if it's not open source, which is a digital commons, should essentially be standardized and contested and competitive, and to a certain extent driven by people for whom it truly is core and meaningful. Our goal, again, is to enable people to get the most out of the clouds that they choose. There are reasons to choose this cloud over that cloud, right? People make these choices after complex analysis, and clouds invest in differentiation, right, which is risk, much as the silicon companies do, right? It is going along with their differentiation, going along with their unique risk-taking values that essentially enables us to be the best possible partner to them. I'm struck by how often those partnerships go together, how often we'll find ourselves in a room with a cloud and a silicon vendor, right? Having to figure out how to express what both of them want to put into the market, right? And how to make that feel natural and easy for anybody building on open source. From there, I want to go to ISV partnerships. It's a fairly easy thing to turn into controversy, but I value and we value both commercial and open software. I think software has changed lives meaningfully in the 20th and 21st century, right? And it simply would not have done that if it was limited only to open source software or only to commercial software, right? For me, this is not ideological. And so I think the way I think about it is that the digital commons lifts the tide for everybody. Again, there are shared concerns. No matter who you are in the software industry, if you're an open source community, if you're a creator, if you're a scientist, or if you're a business, there are all of these shared concerns, all of these shared interdependencies, things over which you have little control, right? As much as you can control your piece, it will live in a complex ecosystem. And our goal is to make that complex ecosystem as simple, as trustworthy, as reliable, and as efficient as possible. And then I want to come to our community partnerships. This is where I think we get into joy, and we get into shared experience, and we get into culture. There are so many different reasons why people join a community, right? Sometimes it is simply for the community, right? Because the people are great. Sometimes it's for the puzzle. Sometimes it's for the mission. Sometimes it's to get away from the rest of your family, I think, right? But that continues to be a deeply important part of the open source story and the open source experience. This is why we have so many commercially unsuccessful flavors of Ubuntu, right? It's because commerce is only one dimension of what we should think about and what we should do. It is, again, our firm commitment that a creator who has an idea, something that is important to them and a community, is able to leverage Ubuntu so that they don't have to worry about all of the other things that are necessary if they want to be reliable and trustworthy for other people, but not necessary for them to express their vision or to express their innovation or their idea. This is a very long way for me to talk about Ubuntu itself. I think most people know that there is an African philosophy that says the measure of a person is the impact they have had on the health and well-being and happiness of the people around them. It says that you can't think of yourself as successful if the people around you haven't also been successful, haven't benefited from that success. And I feel that very, very keenly when I look around the room and think about these partnerships, right? Our success must feed the success of others, right? We are, because they are, the measure of what we are is the measure of the impact that we've had all around this room and all around our shared ecosystem. That really is why we chose to call it Ubuntu. So on that note, let me briefly talk about my hope for this summit. Now, in life is rebirth, and this is something of a rebirth. When we started, our summit was our single event where everything happened. We brought everyone from Canonical together with everyone in the community, and it was a little crazy. It was very unconference, but it was kind of beautiful. And as we've grown, and as open source itself has grown, there've become more events that essentially speak clearly to specific topics, right? Open source has become a very big, very rich, very complicated place. And so we thought it would be interesting to take the opportunity to rethink how we balance the different aspects of what we do. You know, on the one hand, for all of us, it is important and meaningful to essentially create a place where we can meet folks who are just at the the start of their journey with open source and whose motivations are entirely unclear, right? And whose prospects are entirely unclear. At the other end of that spectrum, right, we thought we now have the opportunity to pull together something really punchy, something really celebratory of the very, very best work that's happening in Ubuntu, at Canonical, in the wider open source ecosystem, and amongst our partners, right? And so we struggled with the question of how to do all of that in an event, how to build an event, or how to combine events in a way that would essentially allow us to do all of that. And in the end, the idea that we're pursuing under Sebastian's leadership is that we can't do it all in one event. But what we can do is we can essentially start with a series of grassroots events, Ubuntu Summits that are open to everybody, that enable people who have an idea that is completely untested or a desire to get their first steps in open source. If we could run those events on a less formal basis, closer to people, North America and South America, North Africa, South Africa, Eastern Europe, Western Europe, Northern Asia, Southern Asia, all the way down under, right? We could create a set of events that are grassroots accessible. They will be messier. They will be less predictable. They will have moments of pure joy and surprise and delight, and moments of not so much joy and and delight, right? But they will create an opportunity and a door that anybody can walk through. And the opportunity for us then is to say, out of all of that, what is the very best? What is the stuff that is sheer delight? What is the stuff that we really want to broadcast to the world? And then to bring that to this environment so that we can celebrate it together and we can really show people stuff that they have never thought to inquire about, never thought to explore, never thought could be possible, but which is a joy to behold. So I hope that is what we are launching here today. Now, I haven't talked about Ubuntu. And the reason for that is because there's someone better placed to talk about Ubuntu, to talk about what's exciting in our latest release, why that was the set of things that we chose to focus on, and how that sets us up for the immediate future. So I'm going to hand you over to John Seeger, VP of Ubuntu Engineering. John.
Good morning, everyone. It's an absolute pleasure to be here, and it's really great to see so many faces of people we've been working with in a professional capacity over the past 9 months, but also personally, there are some people in this room who probably don't realize the impact that they have had on my own journey in Linux. Some of the podcasting fellas in this room certainly have been the soundtrack to my professional life for some time now, particularly during the earlier years of my career where I spent far too much time in a car. So earlier this year, I published an article entitled Engineering Ubuntu for the Next 20 Years, and the title of this was inspired by a very famous security researcher called Haroon Meer, who gave a talk at Black Hat, I think in 2015, entitled What Got Us Here Won't Get Us There. And this was something of a recognition of the success that we have enjoyed with Ubuntu and the kind of reach that we have achieved, but also a recognition that if we were going to enjoy the same levels of success in the future, and continue to kind of achieve what Mark is trying to do with Ubuntu, that some things might need to change. And I anchored that around 4 pillars, things that I wanted to focus on. And I'm not going to go into huge detail about those today. If you search for Engineering Ubuntu for the next 20 years, you'll see the entire thing. But I wanted to highlight today some of the kind of, I guess, highlights of how that's gone over the last 9 months and give you an idea of the sorts of things I'd like to focus on over the next few months. So firstly, the questing quokka. It's a little bit of a shame that this one wasn't an R, so we couldn't use rusty as the adjective. But I'm really delighted with how this showed up. In particular, the release team. I was here 2 weeks ago during our release sprint, and I find it difficult to articulate the difference in professionalism and polish and efficiency that I saw compared to 6 months ago. All that is to say is the work that we have been doing behind the scenes on trying to refine our process and really understand what it is that we need to do in order to push a release more frequently was really apparent to me. And some of you will have seen that we did the monthly releases this cycle, and that was really from the age-old philosophy of if it hurts, do it more, which I think you'll hear a little bit more about later on. So I was really pleased to see how that showed up in the end. This, which turned out to be as much about oxidizing as it did polarizing in some cases, but I'm delighted to be sponsoring this work. And this isn't necessarily all about us. I think this is as much about the projects that we are championing and including in Ubuntu by default as it is about Ubuntu. There is something very interesting to me about the Rust community, and it's nothing to do with the language. It is rather to do with the group of people it has attracted and the way they like to think about software and think about resilience in software. And I choose the word resilience carefully as the kind of intersection of security and reliability and efficiency and quality. The individuals that I have worked with as part of those upstream projects and their broader communities have been an absolute delight. And while I am sure that there will be a couple of rough edges over the coming months, I'm absolutely certain from the experience I've had so far that we will fix those expediently and it will all be smooth sailing for the LTS. We certainly caught some attention with this. And this is, if I think about the communication pillar of the Engineering Ubuntu post, one of the commitments I made, or one of the, I suppose, mandates that I made, was that we would do more talking externally. And this has made a really, really big difference. So you will have seen, hopefully, that every week on our discourse, there is a post from a different member of our engineering, kind of internal engineering organization. And while this started out as something that I asked the leads of those teams to do, I'm delighted to see that various other people inside Canonical and outside of Canonical in our community have picked up on this and started talking more about what they do in a more long-form format. And it's really nice to see people getting excited about Ubuntu again, particularly as we head towards our next LTS. This was some of the articles. If you haven't seen it, there is a blog tag on the discourse, so if you are interested in following the work of the Desktop Foundation, Server, Debcrafters, and general Ubuntu engineering org, take a look at the blog tag on the discourse, and you should see something fresh at least once a week. It's more like twice a week at this point. And we've also put a huge amount of effort into our documentation story, which I suppose over 20 years, that's a long time and things have become a little bit fragmented. And one of the things that I would really like to improve in Ubuntu is the story we tell to a potential contributor, a new contributor, a first-time contributor. And to me, we had slipped a little bit there. There was a lot of knowledge that was in people's heads. Some of it was written down, some of it wasn't. It was often dispersed. And so with a little bit of help from Daniele, who's in the audience, and his team, we have gone on a mammoth effort to essentially bring all of that into one place under something called the Ubuntu Project Docs, which is all about, it's not about how to use Ubuntu, it's not about what makes Ubuntu work, it's about how we build Ubuntu. How can you as a new contributor get involved? What do the processes mean? What does MIR mean? What does SRU mean? Who are the people responsible for those? And if you're a developer, how can you get started? And to be clear, this is just the beginning of this effort, and we have a lot more work to do, but I'm really impressed to see how much the team managed to get done just in the space of 6 months. And this will essentially be the successor to things like the Ubuntu Wiki, the Canonical Wiki for people who are internally, some of the content that was on the old Ubuntu forums, and the hope is to put that somewhere that is centralized and easy to contribute to and easy to search and understand. So what's next? Well, probably a little bit less crazy for the next 6 months because we have an LTS to deliver. Certainly some stabilization of the work we've done with some of the Rust utilities, but there's also some new challenges that we're going to take on too. It's not just about polish at this point. So we have been having discussions about exactly what Mark said. How can we make the best use of different processors and different generations of silicon in Ubuntu? We should probably have a bit of a think about how we want to enable users of AI, developers of AI to use Ubuntu. So we've done some thinking about that. We've also been thinking about how to kind of increase the ease of operations for the enterprise and the home user with things like our TPM-backed full disk encryption, which will land in general availability in 2604 for the desktop, and you'll see the beginnings of that for the server too. That's just a really kind of sneak peek. If you've got any particular questions, I'll be here for the next few days where I will answer most, probably not all of your questions about what we're planning, but needless to say, I'm very excited to see what the team can do with the next LTS. Thank you very much.
Thank you, John. Thank you, Mark. As you've mentioned, you're around, and Mark is around as well if you have any questions live. And for those who are watching this remotely, please don't hesitate to ask questions. On Discourse, we have a fantastic team of volunteer moderators who are helping us make sure it's a safe space for everybody. We're running a little bit behind schedule, so I'm going to be very brief, and I'm going to do something a little bit special now. I'm going to try to invoke the live conference gods. Are they with us today? We'll see this in just a few seconds because Mark was mentioning the community. And as I said, this event is live. We have actually a few extended events going on at the same time. So I'd like to welcome the community members, a subset of that community. We have Mauro here. You're cheating. You're just here. But we have a bunch of people. We have... and I'm sorry, I don't know how to pronounce your name, right? Mwewe. Sorry, he's in Namibia. We have, thank you for being here. You can wave, Mwehe, just to show that you're indeed live. Yes, thank you. We have people in, so this is an extended event happening right now in Namibia. We have, I believe, I'm not sure, people in Taipei. The Qualcomm office is also hosting an extended event. And everyone else, you can also wave because you are the UbuCon organizers this year. We've managed together, thanks to you, to organize a bunch of events across different continents. This is part of the revival of the Ubuntu community this year. So thank you so much for being here, for all the work that you've done. And I look forward to the collaboration that we have together in the coming months and year. Just a small note on this. We've managed, together with the community, grow from 20 local communities earlier this year to about 30. We had 7 UbuCon events in all the different continents, except I think Antarctica. Mark did not want to sponsor, I guess, an event over there. I'm joking, of course. Although, all right. And I'd like to set a challenge. Especially for those who are watching this live, by tomorrow evening, check out if there's a local community near you. And if not, why don't you create one? What we've tried to do together with the community this year is to lower the bar, to make it super easy for you to meet with fellow enthusiasts, fellow developers, fellow software engineers. So reach out to us on Discourse or email community@canonical.com by tomorrow evening, and let's see how many more people can express the interest in joining or creating local communities. That's the challenge. So email us, community@canonical.com, or just express your interest on Discourse, and we'll see how we tally the numbers tomorrow evening. A bit of a challenge, but we'll see about that. Now, I think that's all I had for you right now. Let's carry on with the show, and we have an exciting talk right now. And I see people who are roughly the same generation as me, so you probably remember famous video game from about 32 years ago for the first installment, and I'm talking about Doom. But how about playing Doom in space? This is the talk we're going to have now with Olafur, who's hailing from Iceland but coming from Norway, if I'm not mistaken. Other way around. All right. Thank you. So please welcome Olafur to the stage for our talk on Doom in space.
There we go. Can you hear me? Wonderful. Okay. It's going to be a quite of a different energy now. So my name is Olafur, and I'm a professional keyboard typer. Who else is? Anybody else? Yeah, we go, everybody. So to start with, I am no Doom expert, and also I do not work for or represent the European Space Agency, which is also quite a way to start the talk, okay? Some of you might know me for making silly videos on the internet. Some of you might also know me for making silly conference talks. Speaking of Rust, I love this talk. It took about a year of research to do, but it's not about Rust. So I think you'll enjoy it if you want to watch it. But today, I have one job, and one job only. I need to explain to you why this screenshot is really cool. Ready? Yeah, ready? There we go. Okay, let me just boot this up. Okay. Installing, and there we go, and Doom! There we go. So, Doom is a first-person shooter game released in 1993 and made by id Software. It's a game that at one point was installed on more machines than Windows. Yes, yes. Good clap from the audience. It was so much excitement about the game, release of the game that the developers were not able to connect to the FTP server to upload the shareware version of the game because all of the people who were waiting for them to upload the shareware version of the game. So, talking about the deployment and delivery, right? So, you're on Phobos, one of the moons of Mars. Come on now. There we go. It's the home of a teleportation experiment that went wrong. Yada, 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 monsters from hell. That's the story of the game. Good. Come on now. Are you not a friend of mine? There we go. So this is GitHub. In 1997, it's software open source Doom, and to put it mildly, the community went wild. I'm not a friend with this clicker here. The other one good? There we go. Here's an excerpt from the README file. Some project ideas. Port it to your favorite operating system. Quite a simple idea, and people did. This is a list of Doom ports, the wiki page for that. It's about 74,000 characters long. And to put that in perspective, it's the same article length as the Ubuntu Wikipedia article length. So you should step up your game, or the Doom ports will beat you. So yeah, people ported it to all sorts of crazy things. Here's it on a smartphone. Here's it on Sonic. Yeah, it actually doesn't play on the screen, but it actually does play the game itself. But now it has turned into more of a challenge. Can it run Doom, right? There's a Reddit, it runs Doom. Here's someone running it on a streaming deck. There's a homepage, Doom running on VLC, Doom in pure SQL, which is lovely. So, if you have ideas. So, you might ask, like, but why? Why is it so easily portable? It's relatively straightforward C with a few external dependencies that could be swapped out easily, right? So here's an example of some code. It's not that this function is interesting in itself. This is checking if a monster is close enough to punch you in the face. But it is a good example of what most of the source code looks like. It's like this. It's very unsurprising. In 2020, for those C++ heads in the audience, Jason Turner made a short YouTube video where he was playing with the idea of porting Doom to C++. And for those, that is not 11 minutes, that is 11 hours. He did not fully complete the project. It's out there if you want to play with it. Then in 2022, Patricia Oz had an idea of maybe Doom could be an interesting educational tool. So she continued where Jason left off and made a talk about all sorts of Doom problems. There's actually was a bug in the Doom allocator that he found, which was very interesting. This is where I was dragged into the picture because she knew of Doom, but she hadn't played Doom. So when refactoring Doom, the question became, it's a whole video game. So how can I make sure that whatever I refactored or changed to C++ is still okay? That's quite a lot, right? So Doom has an interesting feature where it allows you to record your play session. These are called demo files, and this is 1993. It's not like you could upload the thing to YouTube, right? That doesn't work. So how do you record a play session? Well, so instead of saving a video, Doom saves every single input that you just did, every button press, every mouse movement, etc. This can then be replayed by anybody else that owns a copy of the game. But how? But what about randomness, right? Doom has a table of totally random numbers, which is then used by every single entity in the game. It's a single-threaded game, so everything runs in very specific order, which makes the game deterministic, which is very good. So going back to Patricia's question, how can I make sure whatever I change is still okay? Well, when you record a demo file, it can also write to an output file, which is like, I could write to a file how you did, how many kills, how many items, how many secrets. So this is how you did in that level. So you can use that data as a form of regression testing or approval testing. You collect a large set of strange and anomalous demo files, save them in a folder, run them with beautiful bash. Don't look at this is beautiful bash. And which gives you Doom on GitHub Actions. So here it's running, of course, on Ubuntu, and then all green. So whatever you changed is still okay, right? Wonderful. And since we're just checking the output against output, we don't need to actually play the game. We need to render graphics. It's all a state machine, right? So we can modify the game, run it as fast as we can, skip the drawing, and we can run multiple demo files, and this takes only a couple of milliseconds. So in that example, I had like 20, 30 demo files. It didn't even show up on the GitHub, like no seconds, so it was always 0 seconds, which was great. I gave a talk about this, Doom on GitHub Actions, and other interesting things. And after I did that talk, and that was released on the internet, I got this message on Instagram. Hey man, I'm an engineer at the European Space Agency, and I've been meaning to run Doom on the OPSAT spacecraft. Maybe you'd be interested in partnering. My question was, wow, those spammers are really good now. Really targeting special niche interests now. But no, this is Social Press, not a scammer. Actually, very, very interesting guy. Spacecraft operations engineer at the European Space Agency, now a system engineer at Canonical Space. And if you want in-orbit machine learning, he's your guy. So, what is this? OPSAT. A flying laboratory, ESA's OPSAT, is the first of its kind with the sole purpose of testing and validating new techniques in mission control and on-board satellite systems. Interesting. OPSAT is devoted to demonstrating drastically improved mission control capabilities that will arise when satellites can fly more powerful on-board computers. The satellite is only 30 centimeters high, but it contains an experimental computer 10 times more powerful than any current ESA spacecraft. It's about this size, if you've been traveling. So, not very big. The satellite has this idea of has never flown, will never fly, which is kind of a hurdle for a lot of innovation in this area. So the point was to break the curse. So because you've spent all these millions of dollars, you're not very receptive to, kind of experimentations. But the whole point of the project was to be experimental, was to do experimentations. So OPSAT was your flying laboratory to take down the barriers of spacecraft operations, to accept experimental ideas from the public. Good. So current satellites run a lot of specialized hardware, and for a good reason, because, space, a lot of radiation, a lot of unknowns. But here, they wanted to run as much off-the-shelf hardware as they could. To quote ESA, the platform consists of an Altera Cyclone 5 and an ARM dual-core Cortex-A9 M-core. So this was very off-the-shelf. There were some controlling units that were more like spacey, but the actual unit was off-the-shelf. Here we go. A part of the satellite where they performed the experiments ran Ubuntu 18.4. You might be thinking, 18.4? Well, it was the LTS version of the OS when we actually launched the system, we launched the mission. It's quite hard to do an upgrade in space. So when you make an LTS, this is what it means, right? So think about that, right? So this was a cool opportunity to get Doom to run on the satellite, but how on earth do I do that? Wait for laughter. No? Okay. No. So they had a Docker image that mirrored most of what they had running on the satellite itself. So the problem turned from how can I run Doom on a satellite versus how can I run Doom on a Docker, which is not as exciting, but hey, it's going to be running in space. So to start with, just mimic Doom on GitHub Actions, because that's how we got it to work initially. We picked Chocolate Doom 2.3 because of the libraries that were available in 18.4. That was the last one that could actually build Chocolate Doom. So again, I can also not apt-get install in space. It's kind of hard. So we would build the game and test on a test environment on Earth that mimics the satellite setup. And then we would pre-record a few demo files that the game would run. Good. We could check the output of the demo files in space versus the output of the demo files we got on Earth. So again, it's like the Doom on GitHub Actions. Do a diff if everything is okay. Because here's the thing. This is neat and a fun little project, but the satellite is being used for, actual science experiments, right? So the amount of time we got on the mission wasn't as much, right? So this kind of changes how we do decisions. We have to pick the tools, pick the path to follow, where we would know this is going to work, right? This is going to maximize our success. So that's, if you're thinking like, why did they do it this way? This is mostly why, right? So as an example, this is the diff of just getting Chocolate Doom to run. It's 31 files that changed, 370 lines, 130 deleted lines. That's it. Again, relatively simple C, not a lot of things you have to change, right? Like examples of things was like, oh, turn off the video driver because there's no screen. I can't. It's kind of hard with maybe not a controller, keyboard, mouse. There we go. Kind of hard to see the satellite. We ran the game as fast as we can, so there's no like we didn't run at a 60 FPS. It just ran as fast as it could, and then some script files to run it and build it and do all sorts of fun things. We also created scripts to set up the project itself, and then when it runs, qapla', any there we go, a couple of laughs. And then one fateful afternoon, just after Christmas, there we go. Ladies and gentlemen, we have obviously run Doom on Upsat. So this is super exciting. Yes. So for those who remember my wonderful bash script, it's an okay. There's no diff in the demos. So all the demos run the same as we expect them. Great, wonderful. We got a like from John Carmack, which was kind of fun. Yes, but I mean, this is cool, right? But getting an okay on a log line, come on, no. So technically, we ran Doom in space, but it has to be cooler than that, right? It's Doom in space. Can't end on an okay, right? So here's a little twist, though. We actually did have another experiment in mind, but it didn't work, which is the thing with experiments. Sometimes you have an idea, like, hey, maybe we can do this, but it doesn't work. Cosmic rays. In 2003, a Belgian voting error was detected because a candidate got 4,096 extra votes, which was deemed impossible. Possibly a bit flip that would be causing the error. Okay, and in 2013, a Super Mario player called Dora Teabag was playing the level when he went from this position to that position in one frame. There was a bounty on it, there was an idea, there was a thought that might have been a cosmic ray that flipped a bit on his console. It was later found out that his actual cartridge was not fully set in. So, but for a long time, like for a year or two, people were like, no, that's a cosmic ray incident. So yeah, can space radiation affect satellites? Yes, they can. That's why they have all this shielding and all these extra fun bits. So the initial experiment was, outside of just running Doom, was, can we detect bit flips on a satellite using Doom? Okay, so as I mentioned earlier, we can detect changes in the system by rerunning demo files and checking if the game ran correctly. So what we did was, what if we change the RNG table? We make it take way more space. We make it all 0, and make the character movements also depend on the random number generator table. Because it's all zeros, so we have this, and it's like way bigger. Here I have it as 65K. We actually tried like way huger RNG tables. What we would then do is every movement from the character would pull values from the random number table, which meant that if only one bit would flip in any way, the character would sway away, would move in another location, and then the game wouldn't work as correctly. We re-recorded the new demos, we did all the things, even took the mouse movements, so to get as many values as we could. I had one demo where I was just spinning around in a circle, just to use as many values as I could. So we made new demos with this change, so if any bit would flip in the table, we should notice it, right? So here's a big green line. I love this big green line, because this is about 8 gigabytes, which was the partition that we had on where Doom was installed. This picture is 1800 pixels wide, which means 4.44 megabytes per pixel. Some of you might be seeing where I'm going with this. Doom is 8 megabytes, which means that, so who has really good glasses? Doom takes that space on the disk. So this is why it didn't work. We were trying to detect a single event upset on a space that size on the hard drive. So we would have needed make the RNG table take way more space. But then it also have to travel through the whole table to then find the single event upset. So could the code achieve it? Yes, we would, like in simulations where we would mess with the memory. Yeah, we could detect it. But in space, no, it didn't work. But this was the actual plan for the project. So what do we do then? We have a project, it ran, we failed the first experiment, we need a second experiment. So what can we do? The satellite didn't have much time as well. It was launched in 2019. That's by 18.4. So this was the state of the perigee of the satellite when we actually ran it in space. So as you can see, something is happening. Something's going on. So the satellite didn't have much time left. Then George had a brilliant idea. The satellite has a camera. Ooh. What if we use the photos from the satellite to replace the sky in the game? So the idea was we would take a screenshot like this, we would run around the game, we would find a screenshot where we were looking at a lot of sky, and then we would insert Earth here, right? Find a good photo that the satellite would take. And what we wanted to do was when the satellite would take the photo, it would run Doom immediately afterwards, use the photo it just took. So it is the view of what the satellite is looking at. There's one slight problem. So this is a photo that OPSAT took. It's high resolution, it's great, it's beautiful color. And because the satellite has no graphics rendering hardware, or even graphics drivers, that had nothing like that, we had to draw the game in software mode. So what do you mean software mode? Well, Doom has a predefined palette of colors it can use. So everything in the game is drawn using this set of colors, these 256 colors. Come on now. There we go. So it cannot, if you're running in software mode, it cannot use any other colors than this. There are probably cool, hacky ways to do the thing, but again, we had to use methods we knew would work, right? So, you're trying to draw all of these beautiful colors with those colors. So that's probably going to work, right? I don't know, we try it out. So, we can try on Earth, try out some demos. So we experiment a lot with the different photos and different file formats to see if we can get a photo that looks great in game. Well, first you can do is just a gradient. Let's see what happens when you use a gradient in the game. Oh, no, that's not good. Well, the next thing, that's one of the famous ones, like a TV test thing. It's also like skewed and off. The colors are, not great. You see the purple there, and then it's just blue. Because Doom does not have a lot of purple colors. Well, thankfully, there's not a lot of purple in Earth, so that's maybe helpful. What about this like little demo photo from NASA? Oh, that's not acceptable, right? That's not good enough. So, how do we fix this? So here's an example. Look at this little gray patch here. That is this bit of the screen. And if you notice as well, the photo is flipped. That's a thing that Doom does as well. It flips the photo, which is also not very helpful. So the game has data stored in a file called doom.wad. And we're using the shareware version as well. There are tools called deotext that allow you to extract the thing. And here is sky1.bmp. And you can just swap out the file and then repack it. And now you have your doomearth.wad. So doing the swapping isn't the issue. Like you run the script that does this, that's not a problem. So yeah, this isn't good enough. The satellite is going to take gorgeous photos of Earth, so the photos should look great in game as well. So George has another suggestion. Another project he had been working on was related to taking photos using the satellite, because as you can imagine, the conditions in space aren't always great. So the work was to help with denoising, because sometimes photos look, off. The idea was to use machine learning techniques to denoise the photos. So the idea was to use k-means clustering to reduce the amount of colors of the image to 256, which then the game could then use. That's done like this. You take every pixel, you normalize it, you put it to an array. Come on now. And you call dkm k-means Lloyd on the pixels, and you get 256 pixels back. You can also do prediction on the nearest values to get the centroid, and you can denormalize on the colors. So for the nerdy ones. So here are two pictures. One is 30,000 colors, the other is 256. So can you? Oh, that's not me. That's the algorithm. So, but thank you. So who can detect which is which? Any suggestions? Yeah, that one. Okay, that one. Yeah. So this one is 37,000 colors. The other has 256 colors. Cool, right? So, yes, let's try it. Let's use that new great picture. So this is the old picture. So how does it look in game? Oh. No. Okay, it's better, right? It's an improvement, but it's still not good enough. The reason is the original problem is still here. The set of available colors is still not good enough. As we told, like the purple isn't there. And the little nuances in the grays and the blues, like Doom has like, I don't know, 10, 15 colors of blue. So that's not good enough. So yeah, we're using this little set. So the idea I had was, can we just change the color palette? Is that too much of a... Nobody's going to notice, right? Just play with it a little bit, right? Because the format isn't that tricky. It's just little hex values of each color. So, and also if you mess with it, you can get some fun outputs as well. So here's the game plan. Take a photo with the satellite. Come on. Resize the photo so it fits the sky texture. Resample the photo to 256 colors. Do magic. Replace the photo and the palette in the game. Play those demo files. Take screenshot at beautiful locations where we're looking at we have a lot of space. I mean, not very great when you're looking like indoors and there's nothing to look at. So we would pick some locations to take a screenshot on. And that would be it, right? So what is this magic, right? So we need to figure out what color, so we have a color in the original image, what color you are closest to in the Doom palette, right? And we save all of the ones that say that they're pretty far away from an original color. If you're pretty close to a blue one, you're good, you're fine. But if you're like, I'm like this purple, like you're going to be far away from everything else. That's not good enough. So we would save all of those, and then we would average those colors, right? So they're in a cluster. Like we have 5 colors that all say that they are closest to this blue here. So they are one family. We would average those colors out and replace the color in the palette with that average value. And this is done for every pixel in the photo. And then we also do it per run, because where we are looking at in the sky is also different. So if we're looking at some skies or clouds, the color palette is one way. If it's like some land, it's more green, etc. So the example is we have 3 greens here. They all say that this green over there is their closest one. We would average that one and replace that one with the color. So here's an example of one color palette. So this is original, and this is the changed one, right? Original, changed. So it's not that bad. It's like a slight shift. Some of them are pretty different, but yeah, it's fine. It's fine. It's fine. So we go from this to this. Improvement. Good. Sadly, it's still flipped, but whatever. That's fixed in the actual outputs. So on the 24th of March, 2024, we got this screenshot. What I would have to do was I would sit and watch an FTP server and hit refresh when someone would say, like, we have new photos, and try to find out, like, okay. Because it would take a bunch of runs and a bunch of photos. So the thing was, this is a photo. It's beautiful. We have some, maybe some glaciers, some mountains, some little rivers flowing. Some photos would look like this. Because the thing also was, the minutes that we had running the satellite wasn't like, okay, here's Iceland, and here's a beautiful view of Iceland. We would just get whatever. So sometimes we would also get this, which is, blankness of space. Sometimes get this. This is also another beautiful one. Another thing I learned is that it doesn't tile, so the Earth doesn't tile very well. So Doom expects, the textures to loop around, but even though the Earth is circle, it doesn't loop around that way. So that has to happen. You might also notice, if you look at the bottom, it's kind of green. If I go back, kind of less green. If I go back one more, a little bit blue now. So here you can see the actual palette changing with each image. Go back forwards here. So it is subtle. It's like very, very limited, but yeah. So another issue is that the satellite needs to point towards the Earth to take photos, because that's where the Earth is. Yes. And once it gets closer and closer to the Earth, pointing towards the Earth isn't exactly very healthy. So that's an example of like nadir pointing that the satellite would do. So you could say that playing Doom was aiding in the inevitable doom of the satellite itself. Yes. So Then on the 22nd of May 2024, sadly, it tumbled. RIP. So I live in Norway. One of the final passes it did, it went over Oslo. So I tracked it, but apparently it's June, and even at 21:13, it's still bright out. So yeah, you can't see it, but it was there in my heart. It was there as I flew over. I don't remember exactly where it tumbled. I think it was like outside of South America, but yeah, it was there in our hearts. There it went. So as I mentioned, the point of the OPSAT missions was to be a laboratory. And the second reason for running Doom on a satellite was this, the thing I'm doing right now. Because now you know about OPSAT. Because there's another satellite. Ooh. So OPSAT Volt is launching in, in 2026. So if you have ideas, if you're researchers, people online, hello online people, you can go to this website, OPSAT ESA int Volt. It hasn't launched yet. So if you have ideas for experiments, it is a different satellite, so I would research what are the capabilities. I think the point that optical and quantum communications. So if that's a thing that interests you, then do that. Tell them I sent you. I don't get paid for this. No. I would like to thank the people from ESA, everybody at the mission control team. Thank you very much. Because without them, no. I was just at my computer in Norway. I was not doing anything interesting. So yeah, Doom in space. Thank you very much.
Thank you, Olafur. Do we have any questions in the room?
Any thoughts, angry comments?
Of course we have. Daniela, yes. Just hang on because we have questions on the discourse. So just to make sure we're very inclusive of people who are watching online. We have hundreds of people on the stream. Got two questions, actually. One question here. If it runs in space, Olafur, it can run anywhere, right? Who do we talk to if we want Doom competitions between all our smart devices at home? Dishwashers, fridges, etc.
Who should we talk to? We should talk to whoever asked the question, because you can do this. You should do this.
You should do this. All right. Anyway, I think that was the funny question. I have a more serious question, especially with a new satellite coming next year. If you could port another game in space, which one would you want to try next?
Well, Doom 2.
Doom 2. Daniela, you had a question.
You were looking for evidence of bit flips in the big data file. Mm-hmm. How would you distinguish between a bit flip that occurred there and a bit flip that occurred in, for example, running code, turning an instruction into garbage and then causing a program to crash?
That's a great question. It's you could ask the bit flip, how are you? How are you doing? But no, there is no answer to that, because what you'd have to do is run it on multiple different hardwares to eliminate out the hardware itself, run it on even different flavors of everything. So it's not the hardware, not the even the code itself that would be running it or causing it. It would be then you'd be yes, it was space. It was a bit flip there.
And did you see any unexplained crashes and things of any software?
No, it ran beautifully on Ubuntu.
Thank you very much.
There we go. I think that's the only crowd I can do this in, right? Yeah.
Next question, So I'm following Daniel's question. I was wondering, on the hardware, was there any...
Where are you? There you are. Hi.
On the hardware, on the memory, was there any ECC memory, meaning that the memory was able to recover from bit flips? Because then it's much more difficult to really effectively have bit flips.
Yeah, there is... for the hardware itself, there are papers that were released by ESA about OPSAT, because they had other issues as well. They had because there were actually two machines in there, and one of them failed. And one of them failed, they were able to recover, and then later failed again, and then they lost the whole machine. So I would actually look up the paper about their recovery process from the OPSAT. So, because they go into very extreme detail about, it was even technical jargon that even I have no idea. So if you want really nerdy detail, look at the paper they did for that.
Yeah, okay, thanks.
We had another question, I think, around here. As we pass the mic, I have one more question online. The question is, did we have any hardware-specific changes required in Doom because of running it in space, maybe some opcode that doesn't run great?
No, because it was actually running Ubuntu 18.4. Doom compiles in 18.4. There's nothing. It was an ARM chip, so there was some question of like, does it compile with ARM? No, it compiled fine with ARM. So that was the least amount of any problem. Was just like it ran. I think it was like one script thing that was kind of weird. Of like, we had to like link some of the libraries, but like it wasn't in the path. So instead of in the path, we just moved them to another folder. That was kind of it. So no, that was kind of the least of our problems. Anything else was like the actual issue. So yeah. Yep.
Thank you. All right, one more question here.
Do you know what version of Ubuntu they're going to use for the new SAT mission?
No, I don't know. So yeah.
All right, any last question? Just checking live.
Cool.
All right, thank you very much, Ola, for
Thank you.
again. For the So we are back on time. We're going to have a short break. For those online, the stream continues, and we'll be back at 11:10 UK time. So please enjoy. There's some wonderful snacks, actually pretty nice looking. I was hovering over there. So let's be back at 11:10. Thank you very much.
Stepped through the revolving door, came out the other side, a new man. Sat down on the cold concrete, waiting for me. I left you hanging. I took your trust and crushed it in my hand, made you a small man. You want it all that I am. Don't think that I can. Oh, you make me a great thing, but I can't look at you and you love me and I hate me, 'cause all I do is hurt you. Turned up the radio, I left you a note, asking you to leave me. You used a spare key, drove round to beg me, and I let you back in. I took your trust, crushed it in my hand, made you a small man. Oh, you want it all that I am. Don't think that I can. Oh, you make me a great thing, but I can't look at you and you love me and I hate me. and every magical animal. I got the power of the Zodiac. Like a dog, like a sheep, like a tiger. I'm always to the finish. No matter what kind of race I'm in. I got the power of the Zodiac. Every planet in my stack. One day I know I'll give it back. But for now, I'm in control. Every man, woman, and child is an animal deep inside. It's how we survive, it's how we're alive. We're a magical animal. What if I want to stay after you walk away? That leaves me with nothing. Did you bury the time and all that went by? I'll keep all of that if you don't mind. I feel cool, I feel nice. I found a jacket that I like, and it's just in my size. I could swim, I could swoon, because the radio is playing all my favorite tunes. You see, I'm not somebody just like everybody, but I'm on top of the world. What a life, what a time, what a girl. She does the best things well. She dances by the window and she sings like a bell. Can't you tell that she's so good to me? You see, I got somebody, not just anybody, and I'm on top of the world. What a life, what a time, what a girl. I feel sweet, I feel smooth. I put the record on the table and the needle to the groove. I feel good, I feel grand. You know that I'm in love and I'm in a band. She does the best things well. She's been laughing at my jokes and pulling me out of my shell. Can't you tell? She's been good for me. Yeah, you see, I got somebody, not just anybody, and I'm on top of the world. What a life, what a time, what a girl. What a life, what a time, what a girl. What a life, what a time, what a girl.
That's what the song is about. It's called Pouring Rain.
I'm walking alone in the pouring rain. No one to talk to, no one to call my name. I'm wasting away and my heart is heavy. I feel like crumbling. I feel my life slip slowly by. say, hey, how long is it gonna rain for? Tomorrow's probably gonna bring sunshine. The rain is cold and I need to find my home. But where is home? It seems I've taken the wrong road. The lights ahead are dim and sure ain't growing brighter. But I've gone this far and I know that this ain't right. When the rain turns into an ocean, I'm not sure that I will float. Drowning in my own sorrow. No one's around to see me die. But I say, hey, hey, how long's it gonna rain for? Tomorrow's probably gonna bring sunshine. Keep on walking, keep on keeping on, keep on thinking about that bed I'm gonna sleep on. Through the rain, through the darkness, through the sadness, through the pain. But one thought remains true. The thought of you.
Well, I'm never gonna be a figure skater, and I'm never gonna be a saint. Never gonna show the haters who I am or who I ain't. I used to think that I could heal the whole world with a song. I guess sometimes everybody gets it wrong. But when the darkness descends, I call up my good friends. They come down to the river bend, crack me up until the light gets in. Well, I ain't the only person who gets lonely. But when I'm feeling lonely, it sure seems that way. Try not to think about the things that I've done wrong. Gets harder at the dimming of the day. So when the darkness descends, I call up my good friends. They come down to the river bend, crack me up until the light gets in. Well, on those days when hope feels like a needle in the hay, you're losing all your faith in humankind. And everyone around you swears that there's no brighter day. You know everything is darkness to the blind. And when the darkness descends, call up all your good friends. Bring them down to the river bend. We'll crack up until the light gets in. When the darkness descends, call up all your good friends. Bring them down to the river bend. We'll crack up until the light gets in.
I never wanted to say. I never wanted to say. I never wanted to say goodbye. I never wanted to say goodbye. As much is true, that's on you to lose. And on the leg in Apple Land, amused. Oh, don't you be, don't you be, don't you be, don't you be, oh no, alone. Ah, don't you be, don't you be, don't you be, don't you be, oh no, alone. You gotta take it in stride. You gotta take it and try. Get it, take it and go. Oh, you will never really know. As much is true, that's on you to lose. It's tooth, nail, map, and amuse. Now is it too late? Is it too late? Is it too late? Is it too late? Is it too late for you? Now is it too late? Is it too late? Is it too late? Is it too late? Is it too late for me?
All right, we're going to get started again. Please have a seat. Please have a seat. It's 11:10 a.m. in London. And for those watching the stream on YouTube, remember you can ask questions and participate in our interactive activities. So for this, you just need to go and register for the event at ubuntu.com/summit. So if you're watching this on YouTube, just go to ubuntu.com/summit and you can then register and ask questions and also play with our different interactive activities. And we have one of these interactive activities starting right now, which is asking a question that you'll see popping up at the top of discourse. And it is the following: do you have opinions on the most innovative open source projects? We want your opinion, so go to ubuntu.com/summit and you can ask and answer the different questions and activities. And we're going to get started with someone who's naughty. Naughty. Aspiring game developer, right, to make a transition with Doom in Space earlier on. You're also a maker. You're also a community builder. It seems you're also apparently a Linux user. Well, how surprising. And a podcast presenter. Please welcome Martin for our latest on Nix packages. Please welcome Martin.
Can you hear me? There we go. Hello, I'm Martin Wimpress. I'm the creator of Ubuntu Mate, and I'm a co-presenter of the Linux Matters podcast. But today I'm here to talk to you about Naughty Linux. Naughty Linux is one of those interesting ideas that isn't fully formed yet, a bit of an experiment, a skunkworks project that's edging closer and closer to a project each day. And it combines Ubuntu Server with Nix and the massive, always current library of software that Nix packages exposes to the Nix community. So, show of hands, who's heard of Nix, knows something about what Nix is? Okay, right, okay, this is good. I'm going to touch on the fundamentals, but not a great deal. So what we're going to cover today is this hybrid architecture, how we bring Ubuntu and Nix, the meeting of those two worlds, and then how do I hide the complexity of Nix behind a single TOML file, so a gateway into the Nix world without having to learn Nix, and all going well, and if I can get through the slides quickly enough, a demo. So naughty is a play on the word naught, meaning zero, and a hat tip to my friend Elko Dolstra, who's the creator of Nix and is Dutch. And in the Germanic languages, Nix means nothing or zero, and Elko once said to me, from nothing, everything is possible. So here we go. Right then, so why am I doing this? When I started experimenting with Nix, it was on Ubuntu, and actually that's a great way to learn Nix without the full commitment to Nix OS. And I also wanted to make a pathway that was easier for others. Now, my friend Alan has also seen the desktop shells I've been creating using Nix OS. And he made it very clear he wanted to have some of that, but he did not want to install Nix OS. So it's all Alan's fault, as per usual. And then there were two exciting projects that emerged in the Nix ecosystem. One is called System Manager, which kind of gives Nix OS-like primitives to not Nix OS operating systems. And the other is Nix System Graphics, and that's what makes this whole project possible. And then finally, Maru finally wore me down. He's been asking me to do a Nix talk at the summit for 4 years now. Every year he says, Martin, when are you going to do your talk about Nix? Well, Maru, your persistence paid off. Here it is. So, Nix is three things, ostensibly. It's a functional programming language, it's a package manager, and it's a configuration management tool. It lets you declare exactly what software you want, and Nix makes that reproducible. And then Nix OS is the complete operating system that's built with and for the Nix ecosystem, and it's extremely powerful, but it has a huge learning curve. So the idea here is to bring Ubuntu into the Nix world and reduce some of that complexity. And you sort of have to ask the question, well, why would you want to do that? And the answer is Nix packages. The Nix packages is the archive of software, like the Ubuntu archive, that is available to the Nix ecosystem. It is vast, and it is always up to the minute. So I know what you're thinking. You're thinking, how fast, how fresh? Well, for that, we'll look at a graph. Here we go. This is repoology. So this is all the Linux distros, and then there's Nix Unstable, which will become the stable release in a few weeks. Nix releases are offset by 1 month from Ubuntu, so we just had Ubuntu 25.10. We're going to have Nix 25.11 in a couple of weeks, and that's where we are. And then, for reference, there's the AUR. You hear the Arch users talking about all the software they have available. Oh, boo-hoo. And then I think that arrow's approximately where 25.10 is. So why don't we have both? Why don't we bring it all together? So Nix, the tool, when it was first designed 20 years ago, was designed to run on any Linux operating system, and it does still do that today. Works on Ubuntu, all the distros, and Mac OS. So let's bring it together. Let's take the Ubuntu LTS release, which prioritizes stability and offer excellent hardware compatibility, and then let's satisfy the hunger of Linux desktop enthusiasts who want the latest stuff. Let's fuse those two things together. So that's the sort of idea here. Right, let's look at how the architecture works. I say architecture. It's kind of stuck together with blue tack and bits of string, but here we go. Right, so I defined a system boundary. So we wanted to draw a clear line between what Ubuntu handles and what's the responsibility of Nix. We could basically say Ubuntu is responsible for everything below the desktop layer. And this diagram, if you will, is kind of accurate. So you can see there at the top, that's everything that Ubuntu is responsible for. Kind of everything that you need before the user logs in. And then everything above that all communicates ostensibly over dbus and sockets. So the Nix stuff in the user layer talks down to all of that enablement that Ubuntu is responsible for. So when it comes to Nix, we're going to look at the terminal environment, and then we're going to look at the desktop shells, and we've got a clean separation of responsibilities between the two. So next up is the terminal. I was writing a book called Terminal Velocity. And it was Terminal Velocity, the A to Z of modern Unix. And I gave up writing that. And Naughty has become kind of the vehicle to demonstrate this. So on the Linux Matters podcast, occasionally I do these segments, the A to Z of modern Unix. Introduce a new interesting tool that replaces something we've been using for decades and is visually better and usability is better. So what we've done is use Nix to define the whole user environment as code. We've replaced the console with KMSCon, which is a Unicode-aware, zoomable, scrollable, graphics-accelerated console. So the text experience is GPU-accelerated. And then we've used all of these modern Unix tools, and they're all configured by Nix and integrated and consistent and cohesive. And then all of the features and all of the bling is turned up to 11. So it is a remarkably pretty terminal experience. And that all worked very well. I've been working on my own configuration for a while, so I just ported it over. And we'll get to sort of what that means. But it means things like BAT, EZA, rep, grep, FDs, Oxide, Starship, all that stuff is all there present and pre-configured. This is what I anticipated to be the hard problem, which is, how do you get containerized applications to access the host GPU? And that's because this is very similar to what we have to do with things like Snap and Flatpak and the way that they have to access GPUs from their container environments. And the traditional solutions that are available in the Nix ecosystem are brittle and don't work reliably. They're a bit of a faff to work around, but the Nix System Graphics project solves this rather elegantly. It integrates with System Manager that kind of gives us some Nix primitives in the Ubuntu space, and it exposes the OpenGL Vulkan and Mesa drivers in a way that Nix OS does. So now all of the packages from Nix packages that use those graphics drivers can find their runtime in the place that they're expecting to find it. And what that should mean is everything should work seamlessly. And remarkably, it does. And I thought this was going to be the blocker, but this was a day one solved issue. Until I found the actual hard problem. And that's that Ubuntu has a hardened kernel. And this was an unexpected challenge, and it threw me for a bit of a loop. And so Ubuntu's hardened kernel has AppArmor policy to restrict SUID, binaries, and sandboxing tools. And those Nix packages that use SUID permissions and things like bubble wrap simply don't work. So what that meant in practice is anything that was a browser just was blocked. So no Firefox, no Chromium, no Chrome, none of that. That also means Electron applications don't work. So now there's no Visual Studio Code, and there's no Git Kraken, and there's no Slack or Discord. So you can't do any serious work, and you can't communicate with anyone. And then it also means that the Spotify doesn't work, and Steam doesn't work, so you can't have any fun either. So I thought the project's a bit doomed at this point. You can't really do very much with it at all. So then I did a bit of learning about AppArmor. I looked at Ubuntu's AppArmor policies that they ship by default in order to make that software work on Ubuntu. And I was able to create 2 AppArmor policies that enable all of this stuff to work from Nix packages on Ubuntu. And it was at that moment I realized this had legs and it was viable. And I messaged Maru and I said, you know that Nix talk I've been saying I'll give you? I think I might have something for you this year. So we got that problem solved, and then that takes us on to how do we do the desktop. So I've taken a decision. In recent years, I've only really been interested in these modern contemporary Wayland compositors. So Naughty Linux is not setting out to reproduce GNOME or KDE or any of the other popular desktop environments. It's about me creating curated desktop shells built from contemporary Wayland compositors and the ecosystem of tools and components that exist in that space, such as Waybar for panels and SwayNZ for notifications and Foozle and Rofi for launches and menus, and the list goes on. So I'm tightly integrating those to create one cohesive experience and then some glue code of my own to tighten up the integration so they integrate nicely and act as one whole. And then in terms of logging into the session, we're using GreetD, which is an authentication agent for launching Wayland sessions, and then regreet on top, which is a GTK4 graphical greeter. So it looks and works like you'd expect, but it's not using any of the GDM or SSDM stuff that you're familiar with from the traditional desktops. So this is all about composition over large environments. And once I got that working, I was like, well, how are we going to present it? So there's only one answer for that, and it's Capuchin. If you're not familiar with Capuchin, it is a project that is a soothing pastel theme in 4 flavors. Latte, they're all coffee themed. So latte is the light theme. In fact, it's blisteringly bright white. It'll burn the back of your retinas. And then there's frappe, macchiato, and mocha. Mocha is my favorite. It's the darkest of the 4. And then you get 4 accent themes. But this project is hundreds of implementations of this consistent theme for everything you can imagine. Every shell, every terminal application, every graphical application, just everything you can think of. Browsers, the whole kit and caboodle. So, Capuchin's the only option. It comes in 4 flavors. But the whole system, from power on, the bootloader, Plymouth, boot, splash screens, kernel, VT console, terminal prompt, desktop compositors, panels, notifications, applications, even websites. I'm working on a thing where you can add an extension to the browser, and popular websites will also share the same thing. So one cohesive visual experience from power on to completion. A representation of what you can do with the cutting edge of all of the modern stuff that's available if you've got access to it, and now we have, because Nix Packages is giving us all of that. So, how do we install this thing? Well, that's an interesting one. Naughty Linux is not a distribution. There are no ISO images, and there will never be any ISO images. We don't need another distribution in the world, I don't think. There's hundreds of them out there. Most distributions are what Naughty Linux is, basically a collection of configuration and preferences and wallpapers. So let's be honest about what we are. We are a configuration. So this is how we currently install it. If you look at the website, GitHub, I made it public first thing this morning. The instructions in the GitHub are a lie. They're an aspiration that I wrote a couple of months ago of how I thought it would be installed. I'll get to that later this week. How you actually do it is what's on screen right now. You install the Ubuntu server, go through Ubiquity, choose your options, choose the minimal install, recommend that, fewest things possible. Do your disk encryption, enable SSH, tell it to fetch your public keys from Launchpad or GitHub, reboot, you're done. And then on your other machine, so you can do that in a VM, or you can do it on a spare computer if you've got one. And then on your existing machine, you clone the Naughty Linux repository, and then you run the bootstrap script. And Nix vernacular is you then infect the remote host. So you run the bootstrap, tell it where the remote host is, it sends the configuration over as a payload over SSH, runs the configuration, reboot, shiny new Naughty Linux. And then how do we do the no Nix knowledge? So you don't want you poking around in the Nix stuff because Nix stuff is hard. So we've got a single TOML file. This is almost an exact reproduction of the entirety of it as it exists now. It will grow over time. But you edit this TOML file, and then you run just switch, a single command. And this is where the power of just comes in. So just is a modern alternative to make, and just is the thing that we use to bridge the two worlds. So just is our interface to Nix and the Ubuntu world. We only use just to apply our configuration changes, and it knows what to do in the Ubuntu domain and how to exercise Nix and do that as a cohesive whole. So we make one change here, we run just switch. Maybe we want Google Chrome for work, and the changes happen. And all of the complexity of Nix is hidden away. This conditionally drives a rather large Nix configuration behind the scenes. And then I've created a little helper called Naughty. And Naughty is your gateway to the power of Nix, at least two of its superpowers, but made simple to use. So we have Naughty Run. The beauty of Nix is that massive library of software, you can run any of those packages at any time without ever having to install them. So if I say Naughty Run Inkscape, Inkscape will execute. It's not installed anywhere. It will run for however long I need to use it. When I close it, it's gone. It's as if it was never there. It's never in the path. It's never appeared anywhere on the system. And then an extension of that is Naughty Shell, where you can, in the shell, is bring packages into the current terminal you're in, and they only exist in the context of that terminal whilst it's alive. So if you want to experiment with, say, an MCP server, you could Naughty Shell UVX and NPMX, and you've got everything you need to experiment with an MCP server, and as soon as you close that terminal, it's all gone. It was never there. So these are under the hood using Nix itself, but in a simple way. I'm running short of time, so I'll skip over spawn and help, but help's nifty. I'm pleased with that. So what have I learned? I'll gloss over this quite quickly. The system graphic stuff has worked extremely well. I learned a load about desktop portals and dbus activation that I really should have known before, and I didn't. Capuchin is great. GTK and Qt are in perfect theming harmony, and I'm quite happy with the helper. System manager is essential, but its management of arbitrary files in /etc is unpredictable, not very Nix-like, so I might have to implement something of my own there. Not another distro, it's a good thing, but we're super niche because of it. Nix switching, You're actually rebuilding a whole configuration each time you build one. It's like getting a fresh install. So each time you activate a new Nix configuration, it's like it's brand new. You just unwrapped it out of its hermetic sealing. I have to do impure stuff in Nix, but you don't need to worry about that. We're going to pretend I didn't say it. So where Nix? Finish the installer, add a more convenient way to do updates and upgrades, more desktop apps that are pre-configured. Oops. Choice of IDEs, all the big stuff that people have opinions about, adding mouse support to KMSCon and things, and NVIDIA support. It can be done. I haven't done it yet. So with that, a demo of sorts. This is going to be tricky, isn't it? Right, let's do this. Thank you. I just need to be able to see which screen I'm on. Oh, there I am. There we go. That's my mouse cursor. There's a little bit of latency there. That's a bit confusing. Let's do this. Why did that leave that behind? There we go. Which screen am I on? Right, well, let's do that. So, you've actually been looking at it the whole time. And that was Firefox. That's obviously using those AppArm profiles I talked about in order to actually run. So this is the desktop shell. And what you're looking at here is a theme that I made, a wallpaper that I made. And then if we hit the super key, you'll get something familiar. You get a bunch of menus. And if I want to run, I don't know, files, I can start typing and I can filter down my list of stuff. So that's all familiar. You'll see here, I've currently got the coffee cup on, which is suppressing the screensaver and all the rest of it. I can see notifications here. So that's where the notifications appear. And this is also like the control center for bringing up the tooling for configuring, you know, Bluetooth and network and all the rest of it. Behind the scenes, there's no Gnome settings daemon. There's no Gnome underpinnings behind any of this. There's no desktop underpinning any of this. It's all discrete applications that are purpose-built for the tools that they manipulate. And then across the top here, we've got some indicators. You won't be able to see the effect of this, but if I highlight there, let's see what happens. I'm dimming my own screen, but you can see the on-screen display here where it shows you the screen brightness that I'm adjusting on my laptop. Similarly, I'm looking at one thing. If I click on these, I can see some status information behind them. So if you want to know what the bandwidth is you're using as you're downloading stuff, you just click on these and just expose the information. You can see my tail scale here. So this is a little tail scale integration I've done. CPU activity here, you can see I've got my power profile on slow mode to save a bit of battery. And then if we open up a terminal, here we go. So there's a terminal, and there we go. So this is an example of theme. So this is Starship, all themed using Capuchin. This is made by me. The theme is all Capuchin. If we, what directory are we in? Oh, I've gone too far. But the terminal, in all of the terminals and the console, is true color throughout. So this is an example of the config file, but again, it's all Capuchin themed. And what else can I show? Oh, yeah, I know. I said about naughty, the helper script. Let's do this. So before I do that, let's do this, which, Steam. There is no Steam installed. I don't know if you can see that at the bottom of the screen. Let's, I'll tell you what, let's do this. Then use this one. There we go. So, no Steam installed. So we'll do naughty run Steam. So that's going to reach out to Nix packages. It's going to go and grab Steam from Nix packages, and then it's going to execute it, he says, hopefully. Clearly time for a drink of water. There we go. It's going to do something now. Oh, I've run out of water. Wouldn't it be good if this works? Okay, come on. It's going for it. It's taking longer than usual. It's a little bit worrying. Oh, there we go. That's looking hopeful. So here's Steam down here. So what I'll do is I'll run my key combination to full screen that. Let's see if I can get in my library. So at this point, AppArm is doing its thing, right? Because this didn't work before. And here's one of my favorite games that, unfortunately, I used to be really good at, but now my daughter handfully beats me at every time. And if we hit play, this is really going to test the integrated graphics on this laptop, isn't it? Did it register that click? Come on, please. There we go. Gosh, it's taking a long time. Hopefully, go on. There we go. Steam works. And that's kind of the benchmark for, does it work? Thanks very much. I think there might be time for a few questions, possibly.
We do have a few questions online. Martin, does playing around with Nix tools and apps require fresh install only, or can we use the Nix apps along with our regular daily use of Ubuntu?
Yes, you can. You can install Nix on top of regular Ubuntu just fine. Nix is isolated from the rest. It doesn't share the file system hierarchy that Ubuntu does. I used to work for Determinate Systems. They make a Nix installer. It is the best Nix installer, and you can run that on Ubuntu. You can get Nix, and you can do all of these things without having to do what I just described here of building your own system.
Next question here, thank you. Does it use any kind of display server? And if it does, which one and why is it better than Wayland?
It's using Wayland.
Okay.
Yeah.
That's what you said at the beginning.
Yeah. So it's using some of the different Wayland compositors, and the ones that I'm looking at implementing next are Niri and Miracle, and Miracle's from the Mir team, or members of the Mir team at Canonical.
Got one more question here just popping up. As someone who's running a somewhat similar setup, codename Nixbuntu, I'm curious how, if you've ever encountered and maybe solved the problem with locking and locking the screen using Nix packages sway lock.
I found that bug yesterday, and I have disabled the screen locking on this system because I turned it on, locked the screen, and then I couldn't unlock this unlock the computer. So you're in good company. I've got an idea about how to fix that. So find the project online, come and talk to me. Let's see if we can figure that one out together. But I think I've got a path forward on that.
Excellent. Any question here from the audience? Oh, we have a couple. Go ahead, Ken.
Yeah. So you mentioned installing this on top of Ubuntu Server, but can you just do this on Ubuntu Desktop and disable GDM?
You can do all of that. I wanted to create something that was kind of its own thing. I actually had a requirement to use Ubuntu because I had some compliance software that I needed to run, which only ran on Ubuntu, but I didn't want to give up all of my investment in Nix and being able to bring my Nix configuration, which is my productive superpower. So Ubuntu Server, I can still install compliance things in the Ubuntu world, or things like, Docker even, or Tailscale, things that are at the system level. But then I keep all of this user separation for all of the things that make me productive. But yeah, you can totally run it on desktop.
Cool.
Oliver, you had a question. Go ahead.
How much lighter or heavier is it on resources than, say, Gnome or KDE?
A lot. I think this whole system runs in like 300 meg, so.
Wow.
Yeah. It's just Wayland compositor, basically, and then each application as you launch it, so it's very, very minimal.
Yeah, you were describing that you are launching applications and afterwards they're completely gone. If you don't have fast internet and don't want to download everything again and again and again and again, what do you do?
Well, good news, Nix aggressively caches everything. So when I go out and grab Steam there, although it took longer today, it was running off cached versions of the packages it's pulled down before. But just because it's pulled them into what's called the Nix store doesn't mean they're exposed to you in your path for your regular running of stuff, so it won't collide with other things. So it just caches. And you can garbage collect and stuff.
Any more questions? Otherwise, we're just on time. Perfect. Thank you very much. Martin, thank you. Thank you for playing with the demigods. Thankfully, they were with us today. So we're going to have another talk. Someone who's been coding since the age of 10. He's a bit older now. He's a bit older. And what's interesting is that, as I mentioned earlier today, I was trying to get people to start new local communities. We already get emails. I had an email just a few minutes ago from someone in Australia saying they want to start an Ubuntu community. So I love to see this excitement online, and also here trying to solve issues and bugs identified just yesterday. So as I said, our next speaker started coding since the age of 10. He's here next to me. He's an expert in computer graphics engineering. Please give a warm welcome to Antonio.
Thank you. So, for the past 30 years, the GPU has been the engine of digital innovation, accelerating science, rendering world, rendering video games, and pretty much redefining what we can do in computing. But what does it mean to create a new GPU from scratch, chip by chip, architecture by architecture? And most importantly, why would we do that, right? What does it mean for you, for you, for you? What does it mean for you as a community of supporters of open source or whatever you do? And the question is legitimate. GPU market right now is a billionaire market in the hands of a handful of companies. So it's a big challenge, right? But I'll talk about this in a moment. How do we approach this kind of challenge and why it's not really a challenge. But let me talk a little bit about who we are. So we promote lowering the barrier to entering a new generation of computing through GPU, especially accessing unprecedented quality in computer graphics and in scientific simulation. As you know, if you want the top in this area, you need to pay big dollars, and that's a very old, it's a very old type of problem, right? And we are member of several open source initiatives, as you can see here, and proudly we are corporate sponsors of the Blender Foundation because we believe in giving back after using so much of the open source. So this is the spirit of open source, right? When you don't have much, you can get, and it helps you grow. It helps you put you where you want to be, put you on the road. But then, after a while, if you can, it's good to give. It's just normal to give back, just moral. So, what is this? We talked about challenges, and I decided to start with talk with a fun story. So. Some of you, or probably all of you, will be familiar with the story of Columbus egg. And so as to recap, so when Columbus came back from crossing the ocean, he faced his detractors once again. Those who told him, it's impossible, you cannot do that, right? You're going to die, the earth finishes, whatever the reason was. And they probably weren't happy that he actually came back with something. And they said, well, anybody could have done that. He just went straight and back, right? Anybody could have done that. So he challenged them. He said, picking up chicken egg and said, make him stand on the table. And they tried to balance, and they couldn't, and they failed. And then they said again, it's impossible. You can't do it. You can't make an egg stand on the table, right? So Columbus, according to legend, takes the egg, gives it a little tap. The egg, slightly crushed, stands on the table. And what do they say? They say, you cheated. Anybody could have done that. So he said, well, yes, anybody could have done that after you see how it's done. So it's obvious what the story wants to tell, but for me it has a deeper meaning. And the takeaway from the story can actually be broken down more significantly. What does make a person say something is impossible? Because I think many of you are probably were in that situation sooner or later. I've been in that situation several times. Someone tells you, your colleague, your boss, an expert, it tells you, you can't do this, and then you do it. So why did they do that? Because there is a difference. in approaching challenges in general. The pragmatic person is not unintelligent. Your boss is not unintelligent. Your colleague is not. They're just trapped. They're trapped because they are focusing on the how do I do that, right? Right now, with the tools I have, with the status quo, with what I believe, how do I do that? So they start from there, trying to figure out how to get to the goal, right? So as you run a mental catalog of the things you know, the things you believe, the things that you can see, you can't find a way, and then you will say, it's impossible, or at least it's really hard, we missed something important, right? But the innovator thinks differently. It reverses the process. It focuses on the, what is that we're trying to do here? Right? What is it really that we're trying to do? Break it down. The egg is supposed to stand on the table. Did we ever say the shell of the egg should stay intact? So once you drop that, assume constraint, the space of solutions explodes, right? And of course, the solution is most likely to be unorthodox. It's something that wasn't expected, that people weren't thinking about, because they are trapped in that thinking of, how do I do, the normal way. But it doesn't matter, because once you solve your customer needs and wants, they're not going to judge the way you did it. They're just going to give you the money and say, give it to me. That's great, right? So how does this apply to us? So this is the Zur GPU, our baby. This is the entry level, one chiplet. How do we approach the challenge, and what was the Columbus egg for us? It's very, very simple. Once again, we started from the what is needed, right? And to understand what is needed, we spoke to many, many people. We spoke to people from all walks of life. Gamers, game producers, scientists, institutions, even governments, all sizes. And we asked them, are you happy with the current GPUs? What do you think is missing in current GPUs? If you had the ability, what would you change? What would you want to have? What do you need? Okay, and we saw patterns, because despite being people coming from everywhere doing different things, science or games or whatever, the answers had patterns. So we took those patterns and we understood, okay, let's package this thing, these needs and wants, let's package them into product. And this is what we're looking at today. At the core of the GPU is a RISC-V RVA23 processor, which is going to run Ubuntu out of the box. I mean, 2510, 2604 LTS run out of the box on RISC-V. With RVV vector extensions, this is our answer to the closed architectures, the closed systems, the closed ecosystem of software and compilers. This is completely open, because that means you can run your open source software in there, as long as tool chains allow that for that, which they do for most things. You can take OpenCV and compile it right there, running on the GPU directly. The second thing is this. This is the one I love the most. This entry-level board, which is actually quite cheap, comes with 32 gigabytes of LPDDR5 memory, but it has those SODIMM slots. Because the other thing that everyone said was why, we need more memory on our GPUs. And right now, the pricing bundle of GPU is kind of like the cloud pricing model. If you can't buy more memory unless you buy also more capability. And then the price scales very quickly. $6,000, $8,000, $10,000, $20,000. But it doesn't have to be that way. So on this board, you can expand your memory up to 160 gigabytes. That's the entry level. We have a dual slot version with 2 chiplets, where you get either 64 or 128 gigabytes base, and you can expand it to 320 or 384 maximum. And then we have the data center version for chiplets, which expands up to 2.3 terabytes of memory. And we'll see in a moment what that means. This is not just answering to what users want. This is also innovating, because we are taking GPU to the next level. when you have this kind of characteristics, the question is not just what can you do the way you do it much better, but also what new things we can unlock. So this is pretty much part of this talk today. But let's continue a little bit. 400 gigabit Ethernet on board on every model. Our founder, that we're saying, background is hyperscaling. So you can imagine what you can do with that, especially in data center nodes. But there also are users who specifically, yes, especially in the scientific community, they wanted something like this for tackling latency in processing large amounts of jobs. And I think we can just mention the power consumption of this board is 120 watts. And the power consumption of the dual slot is slightly below 250 watts. So that's the other thing that we really wanted to achieve. We're very happy with that. So let me talk you through a cross-section of things that we do, because obviously you can imagine creating a GPU from scratch is a huge undertaking, and it taps into pretty much anywhere, anything that you can consider computing. So I just took a selection, and I created a bit of a story for you to share with you. Let's start with hardware development, because this was the interesting one for me as well, because I'm coming from software, and I didn't know much about hardware before getting into these kind of things. So the interesting part with hardware development is that I wish I could tell you that there was a little army of small monkeys doing prototyping or people drawing on glasses like in movies, but it doesn't happen that way. Creating hardware is actually programming. You program hardware, right? You program hardware through hardware description language, usually either VHDL or Verilog. We use Verilog. And you literally describe the architecture. You literally describe the functionalities. And it's a little bit different from how you will say, I program C++, I program C, but it's still programming. And that means two important things, two important consequences. The first consequence is that the methodology in developing hardware, it becomes pretty much very similar to software methodology. You have repositories, you have peer reviews, okay? You have reusable modules, and that is a great help. It's a great optimization from management point of view, okay? Because it's not like the different department, people doing completely different things. It's very similar. And in this example here, for example, this is an architecture. We dive into the architecture. We see individual component. All of this is described through software. And then the software goes down the road, and we'll see a little bit more details soon. It becomes a layout, and then it becomes a wafer. That becomes the actual chip. Okay? So this is an important thing I wanted to stress on. How do we test it, though? Because if you write C++, you compile it, and then you compile it targeting a specific fixed architecture, like x86, and then you can run it, instructions by instructions. But how do you run a software that describes the hardware architecture and functionality? So for that, we use FPGAs, Field Programmable Gate Array. This is a special board. Some of you probably know what I'm talking about. These boards reconfigure themselves. Once you flash them with the software, they reconfigure themselves, and they become the hardware that you're trying to simulate. They literally become their hardware. The limitation is there, of course. The scale is different. They are much, much slower. But nonetheless, they are the hardware. So you can write the register into the registers. You can write into the memory, map the memory, and they behave exactly like the final hardware. And you can test. You can see what's happening. Do they work as expected or not? You can fix bugs, go back to the software, flash it again, and it's a process. So again, very important to understand, once you write this type of software, you don't have to do anything else to create the actual chip, okay? The software is flashed into the FPGAs, so you can test it, you can do your development cycles, but the same software goes straight to the factory and becomes the chip. The problem is that this part here costs millions of dollars. So you cannot do it, like every 5 minutes or every week you can't say, hey, we are ready for a new, we want to try this one you want. So you really have to get it right. And that's quite important for this talk. You need to get to this point and be really confident you got it, okay? Of course, contracts with factories include pre-tape outs, so you can do small iterative tests before getting to the big one. But once you do it, that's it, you lock it in. There is no click here to download a new upgrade like we do in software. That doesn't happen, so you have to get it right. So let's now talk about software development because it was the core of this talk. We saw the hardware part. That was, I thought it was necessary to understand what we building on and to explain what we're going to talk next. So when we talk about software, the very first layer is obviously the driver software, okay? Because once you have the hardware is mute. It doesn't do anything for you. It's just sitting there, right? So and how do you control it from high-level software if you want the hardware to do something like specific? You need a driver that takes a high-level instruction and then converts it into writing into registers, mapping memory, and fetching results and coordinating this. On the kernel side of things, we can have multiple softwares on the process space doing this at the same time. So driver development is one of the things we do. At the moment, of course, the driver sits on top of the FPGA. Okay, and there's one important thing to say about the driver. I think I'll say that in a moment. And then we have end-user software. Now, this is really the most important part because why do we do this? You could say, okay, you guys are creating a new GPU. So once everything is working, once you have unit tests, everything is done, why don't you just give it to someone else that will write the software like everybody does? Well, if you look at other companies such as NVIDIA, AMD, Intel, they also are very much involved in software. There's a reason for that, especially for us, because we are creating something completely new that can potentially change the way we use GPUs. And to be fair, term GPU is a bit restrictive. I know in broader terms, people talk about GPUs, but this one here is essentially like a supercomputer in your computer. So, but we call it GPU because it has ROPs, TMUs, it can run your desktop. So we still call it GPU. But so because of all this, we really want to test every edge of what we're doing. And we cannot do that by using just simple unit tests, because once you have high-level software, you have real users trying all kinds of things, right? Combinations of things. And unit tests don't do that. You really want to see where you can, how much you can push it. But most importantly as well, the people who are writing this software, which are really clever people, thank God, much more clever than I am, they can actually see through certain synergies of the hardware that we prototyped so far, and they can come up and say things like, hey, there's a situation here where if you do this with the current hardware, you're going to trash the cache all the time. So we really should add this little thing to the hardware if possible, and we can avoid that. We can make it actually faster. And then this information is, of course, is defined into tickets, given to the hardware team thinks about it, and then comes back with a solution, explain, and there's a little bit of loop. So this is the R&D loop, right? And the R&D loop happens because we have this software, which is like our gym, our sandbox, the common place where we discuss improvements on both sides of the coin. So in talking about this, let me introduce the part I specifically follow myself, and it's the Lightning ASIC. So this GPU comes with at the moment, comes with two ASICs, which are domain-specific accelerators, okay? One of them is for ray tracing, and the other one is for advanced scientific application, floating point 64 bits, i.e. triple standard. The way we accelerate ray tracing is quite different from the way RT cores do at the moment. Not too different, of course, at least in the intent, but it does come as a complete package capable of receiving an arbitrary 3D geometry, and it will automatically compute all the acceleration structures and will be ready for firing queries or arrays. So for those who are not familiar with ray tracing is a technique for rendering, very different from raster. It's the next level of raster, where you can shoot a bunch of arrays into the scene, one per pixel, or multiple per pixels, and then you can understand, so what lighting does for you, it will tell you, hey, you hit a geometry here. Your array has hit something. So you can decide to simulate a certain material and say the array is supposed to bounce somewhere else and feed it back into the system. So what this allows you to do is to carry information about the light, which initially covers the entire visible spectrum, like white light. And as it hits materials, it can ask the material, hey, what kind of frequency are you absorbing? And the material will say, yeah, I'm absorbing blues and greens. And so you're left with the red one. This is why the cube looks red, right? And then it continues its journey. So if it hits something else, the process repeats. And then if it hits a source of light, it will transfer all the energy back into the light path, and it will contribute to your pixel. That's the basic functionality of a naive ray tracer. The next level of ray tracing is path tracing. So we are developing a solution called a glow stick. It's an advanced path tracer. I don't know if you can see my shoes, but that's what's there. So path tracing is used for absolute photorealism in many, many fields. In this case, well, product presentation, product marketing. The same 3D assets are used for product design itself. Okay, they go all the way to factories. How is it different for a trace? It's not very much different. The mechanism is the same, but it allows to solve the complete rendering equation, which is a very complicated thing to do. And it's very, very demanding from a computing point of view, because you need to shoot thousands of rays per pixel, actually billions of rays in total, many billions, depending on resolution. And historically, it has been used in VFX and motion pictures, offline only, in huge render farms. And what we're trying to do with this new generation of GPU is to make path tracing available as near real-time or real-time technology, which has implications for video game development and many other things. So the benefits of path tracing, like this one you could argue, you can do this with raster graphics. Yes, you're right, in this particular case. So I actually created a short video, not great, quite exaggerated, but you can see the simulated lens of the camera, so it creates a field of view effect. You can see reflections and refractions at the same time, reflections and field of view, all kind of things together. So when you put it into context, it creates something that looks real. So I don't need to tell you that. Like if you watch movies and special effects, you can see the difference where reality blurs into the special effects. That's what path tracing does. But like I said, it's a very expensive technique. And this is what we're doing with the Lightning chiplet. So, of course, in other areas, uncompromised, unbiased, Monte Carlo-based algorithms contribute to realism in architecture, especially architectural design. And the overall benefit that this GPU is adding is the incredible speed and incredible amount of memory. So we hope that also others who are, they've been working for many years on solutions like this one, the rendering engines, can finally find a way to drop advanced algorithms to load and unload, for example, continuously, but they can just use all the memory to have it all there and leverage the speed to do much cooler workflows. So this is the reason why path tracing is very expensive. Like I said, once a light ray hits the geometry, it will bounce somewhere, okay? So if you have a specular reflection, it can only bounce in a specific direction. But if you have a more diffuse reflection, it can bounce in many different directions. And which one do you pick? You pick one at random, theoretically. But you really need to hit the same pixel so many times to explore all possible different combinations. So you're solving the integral as you go. And finally, reach a decent solution that minimizes the variance between the pixels next to each other, right? And this is why it's so expensive. This is why it cannot be done real time. So when you see video games talking about we have added path tracing also with RT cores and everything, it's actually a bag of tricks, and it's kind of like a half path tracing. Unreal Engine has a beautiful implementation of, but you only use half ray per pixel, and everything else is quite clever caching and algorithms that deal with pseudo global illumination, whereas this is actually full global illumination. So here's the open source stack that we currently use in Glowstick. Most of it is coming from Academy Software Foundation, which you probably saw last year, presenting on this very stage. We have OpenUSD, which is the standard for transmission of 3D geometries and scenes, and how materials are used by objects. OpenUSD has been developed by Pixar. And then we have Open Shading Language. Open Shading Language from Sony ImageWorks. It's actually a programming language for shaders, for physical shaders, because these are not shaders as you will have in, I don't know how many you're familiar, but it's not the same type of shader you will have in OpenGL or Vulkan, where you actually, it's like a small program defining the effect, right? These are more, it's just closer to the causal part of the story, right? So there's the physical background implemented, which is telling you how the material will react to light under certain conditions. So it's still kind of phenomenological, but it's more oriented toward path tracing and physical simulations. And then we have Material X. Material X stands in the middle. Material X tells you how a physical material should be implemented. So it gives a bunch of hints for something like Open Shading Language to create an implementation. And so the purpose of Material X is to say, okay, here's what the material should behave like. So if you want to compile it down to OpenGL or Vulkan or Open Shading Language or anything else, you should have some kind of degree of consistency. So these are actually, if you read between the lines, the features of all these open source softwares are actually addressing many issues in the VFX and motion picture situation, right? And you will say, well, but some of these companies might actually compete against each other in real life. So how is it possible they work together in these open source projects? Well, most of the answer is in the first talk, but let's just say that a lot of this technology is pre-competitive. So they're not helping each other to compete against each other by creating a solid foundation of open source stacks. They're actually taking advantage of each other because the competitions happen afterwards in the quality of the movies they release and the quality of the things they do. And with that, the tools themselves don't really have a direct weight because most of the importance is in the artist. And finally, one other element used from the open source community is Intel Denoiser. This is interesting. It's you call it open image noise. It is an open technology, but it's not open source. You cannot get the source code, but you can still get it and use it as open, with the same philosophy open source. So open image noise is machine-based learning, and how is it used? It's used once you get to the point where variance is really, really small, but it's not perfect yet. You still have a little bit of noise. I don't know if you can see some of the dots. It will quickly instantly turn it into something beautiful. All the noise, the remaining noise is gone, and the image can be used commercially. So let's talk about the testing methodology a little bit, because as you can imagine, between hardware code that goes into the FPGA and creates an architecture and actual billions of transistors, right? They're not hatched in the wafer yet, but they still are in the FPGA. And then you have the driver on top of it. Okay, and then you have all this software and all this third-party software which we take and we need to compile again. This is quite an immense amount of code to maintain and make sure that it keeps doing what it's supposed to do. And the biggest issue we had, is actually subtool regressions. So regressions in general are the biggest problem, right? It's not making a bug. If you make a bug, you realize immediately you can fix it. But regressions happens because of such interdisciplinary and so big and so vast. So let's start from the hardware prototype. How do we test the hardware of the prototype? That's the easy one, because we are using unit test, and the way we talk to the hardware is via DMA. So this is actually pretty important, because it means that we can actually run the driver and talk into the FPGA from inside a Docker container. And that Docker is modified on Ubuntu without any modification whatsoever. You run it out of the box in the container and talk to the hardware. This is quite important for automation purposes, I will say in a moment. Unit tests, clearly, they are small programs targeting specific areas of the hardware. So whether it's like writing to a register and making sure you're getting the correct answer, or mapping the memory, making sure it doesn't get corrupted. And these tests are basically Boolean in nature, they're either successful or not successful. And typically, when you want to run a regression test on the hardware, you need to run them all. And if any of them fails, you have a problem. And you need to go there and fix it, obviously. So that's the easy part. Functional test is a different story. This is where the fun begins, because, like I said, we use Glowstick, we use the high-end software as our R&D sandbox, right? And also for testing that everything works as expected in the hardware prototype, right? And we're using user workflow, so we allow people to do things that are unthinkable. Like, obviously, you give something to a user and say, do something with it, and the first thing it does is the one thing that you didn't think about, or it wasn't supposed to, of course. So functional tests are meant to capture everything that can possibly go wrong in terms of the visual output doesn't match the expectation, or something goes really wrong, like literally crashes, or perhaps there is a regression in terms of how long time did it take to do something. It was much faster last week. What did we do? And now it's half time slower, or perhaps it's twice as fast. That's good. So how do we do that? We need to capture that using functional tests. Functional tests, as you can imagine, are really humongous in size. We add them all the time as we find edge cases, corner cases, or we add new features. We need to add functional tests as well. They, like unit tests, they also target specific functionalities, but they are more complex than that, because in a unit test, you literally code, right, the interaction with the other side. But in a functional test, in a program like this, you need to create an actual geometry that recreates a situation, right? If it doesn't have any textures, it means you're not probably testing textures, right? So if you want to test textures, you have textures in there. If you test in certain cases, like there's a complexity, like rays bouncing in and out, or whatever, you have to have different geometries accurately modeled one by one. And once you do that, the general idea for us is it would be great to avoid developers to block the machine for like a day and a night or a couple of days in running all these tests, because there are so many and they're so heavy. Every test entails a rendering, right? So it's very complicated. So the ideal situation would be when the developer creates a pull request, GitHub actually builds the branch and then runs the tests, and then we can actually see, does it work, or was there a regression? And if it does work, we want this section here to unlock GitHub automatically, right? So that's a complete automation of the CI/CD pipeline. So before we do that, we need to formalize the test. We need some kind of formalism. So what we do, we use JSON, because JSON is flexible enough. As we add new features, as we add new requirements, perhaps new KPIs, we can just add them to the JSON file. We don't need to recompile anything, right? And most of the scripts to run a test are actually in Python. So it doesn't require much energy from our point of view. And some of the information we write in the test, for example, like a truth situation, it tells you, okay, if you run this test, this is what you're supposed to say. So if you get like a rainbow-looking age of statue, you're probably doing something wrong. And the other situation of the truth is KPIs, for example. If you run something like this in those conditions, you're supposed to get at least this amount of rays per second being processed. So if that doesn't match, or something is regressed, or perhaps got worse. And tests can be also grouped into test sets. So we can actually have different type of tests agglomerated together to test specific areas, like macro areas, like, for example, textures in general, lights in general, or geometries in general. And we can run them individually in case we need. And the tests are actually living in a database. The database becomes like the central, of course, it's the central place where all the tests are living. So that it's one place where we can query, we can maintain, and we don't have an issue in things diverging and having different things on different machines. It's just one place. Where does the database live? It lives in the cloud, of course. So the database itself can grow gracefully accordingly to the process itself, the program itself, and the features growing, whether it's in the hardware, new hardware features, or software features. So, as I mentioned before, we want to pull all this together and create a large-scale testing automation, because we have multiple engineers working on multiple features. So we have a certain amount of developer branches going on at all given time. And each one of these developer branches carries a high risk of regression every time it gets merged back into the stable branch. So how do we make sure that this never happens in an automated manner? So in other words, the second part of the answer is how do we produce a large amount of renderings? How do we produce the renderings and the KPIs in really large scale? So for that, we create a render farm. A render farm, just like the ones used for making movies by rendering many, many frames, we use it, instead of rendering many, many consecutive frames of a movie, we use it to render all the different tests at the same time. Render farm is pretty simple, logically speaking. We have a client request. In this case, it will be coming from GitHub, or rather our pipeline. We have a submission, so it receives a job request, and the job request carries the information of what kind of test do we need to run, so it can go into the database and fetch it. And then the job is sent to an object called a deadline. Deadline, some of you might have heard something like this last year. It's actually a queue manager and resource manager, which decides where to send jobs in available computing resources in a large network. And then data can be coming from EFS or S3 on AWS. And then we have a results lambda, which is processing the results of the test and packages for further use down the road. So the central element that you saw in the middle, deadline, is like a command control center on the client side. But it really is a queue manager. And the way it works in AWS is we can use it to create resources that we need them, because that's an important thing. At this point in time, we cannot have hundreds or thousands of computers in the house on-prem just to run tests. That would be ridiculous. But when we need to run a large amount of tests, we can have a cloud solution that scales automatically, just spikes in that moment. And then you have dozens or hundreds of computers working together, producing all the reporting for our developers. And that is more financially feasible because the workers are actually spot instances. And the way spot instances work in AWS is like a secondary market where an instance on demand costs, like, for example, $2, $3, but the spot instance is basically unused computing power sitting there idle. And the calculus AWS does is, hey, instead of sitting there idle, I'm going to give it to you for 3 cents an hour, better than nothing, which is actually quite good because we actually do pay this amount of money because we use many of them. The only snag is if the resource is reclaimed because someone else is ready to pay those $3, we need to let it go. But that's fine because we can be resilient enough to just jump on the next one. So this can never fail. Deadline is quite good because it allows full customization, so we use Python. We don't have to, it's completely software agnostic, right? It doesn't care what you use for rendering and what you use for whatever happens after the rendering. So we do customize it ourselves. And here's the bigger picture, like the complete, like pulling everything together. So we start from GitHub. A developer creates a pull request. The pull request triggers a pipeline. What the pipeline does, it takes the branch. So the branch says, hey, I want to be merged into the stable branch. So this branch is taken by the pipeline. The pipeline compiles it. And then it creates a Docker image. It creates a container. But at the same time, a request is sent to the render farm system that we saw before. The job gets submitted. So the test definitions are pulled from the central database. Okay, now we have the test itself also tells us where to go and get the resources needed for running the test, like the geometry resources, everything that is needed, so the assets. So once it gets here, Deadline receives this package containing the test descriptions, and it says, okay, so for this test, do I have available computers? Yes, okay, so this computer, this worker is going to take this test, or perhaps they're all busy, so let me create another couple of workers and distribute the test there. So this actually is like a harpsichord, like it gets bigger and it shrinks accordingly. So each computer executes a test at a time. What happens after the test is ready, there's another Lambda, which takes the result of the test and creates a reporting for that. So it compares the image to the expected image. It compares the KPIs to the expected KPIs. And through the criteria described in the test, it decides whether the test has failed or not. The report is created anyway, but there's also this blue or red outcome, the test that tells me it has failed or has it worked. So if all the tests are successful, the Lambda itself will unlock the pull request. So that specific criteria will be unlocked. And essentially what we're saying is that from the test point of view, you're good to go. Are there any other criteria? Yes, probably there's a peer review criteria that needs to be satisfied as well. So once that one is satisfied as well, you're good to merge the pull request. Does this guarantee no regressions, no problems? Probably not. But it does mitigate a lot. Because you see the problem here, if this isn't done, the risk is 4 or 5 pull requests are merged into the stable branch. Everything works because they've been tested. The features, everything has been tested, but 2 weeks later, someone tries a feature that is far away, in terms of code, far away from what has been worked on, and it has regressed. And everybody says, hey, I haven't touched that in months. And okay, what did we touch in the last weeks? This, and that. Okay, good luck finding the problem. So this actually helps with that a lot. It gets rid of that, for sure, 100%. So that is our large-scale automation system. And this is an example of the reporting. So we have visual comparison, we have KPIs. In this case, it's quite a successful reporting. And this is an example of reporting coming right on the telephone of the developer. So it's pretty ubiquitous. Basically, it can be, you can't have your lunch break, you'll be bugged by the system. Like this didn't work. Go back to work. But yeah, that is actually pretty cool. So in case there is a problem, in case the whole machine didn't succeed, clearly you need to go back and look at your code and see what could possibly have happened and fix it. Otherwise, you won't be able to do the merge. And that concludes my introduction, which was pretty wild because we went from describing chips and how to make them all the way to software of different kinds and how to test them. But and like I said, it's a bit of a cross-section of the things we do. So if you have any particular questions about also regarding other areas that we didn't discuss here, you're welcome to try. It's highly interdisciplinary work. I am a software specialist, so be merciful, but we can try to answer your questions.
Thank you, Antonio. You did cover a wide range of areas, so we do have many questions online. If you have any questions here, just hold your horses until I go through a bunch of questions, see if you have the answer. First question here, I think, was from Kunal online. How do your hardware offerings adapt to the needs outside of traditional graphical applications?
Oh, that's a great question. So like I mentioned, the Zeus GPU is not exactly a GPU. We can call it a GPU, but it's way beyond that. So one of the ASICs on the GPU is dedicated to scientific simulations. And when I say ASIC, make no mistake, it's actually a high-level set of APIs and functionalities in the hardware itself. I think I can mention FFT, for example. We have a really, really fast FFT, among other even higher-level functionalities for specific types of simulations. So with the RISC-V at the heart, how do you approach that? Well, you can actually deploy your own open source software on it, if they answer the question.
Next question. How do you account for memory leak issues that traditional GPUs suffer from? Memory leak issues, how do you deal with that? How do you account for it?
Don't do them. Program better. No, actually, okay, so what I can say about the memory is because I think this is I know where it's coming from. So, as you can imagine, when I say you have a amount of memory on the board, as it is, like 32 gigabytes, 64, 128, and then I say you can expand it to 160, 384, 320. Those memories aren't exactly running at the same clock speed, right? The SODIMM DDR5 is a bit slower. So what we can do is actually choose the mode at startup. We can actually say, okay, you can use the onboard memory as a fast cache, and then we can address the remaining as its own space. Or you can actually address the whole chunk in its own space, its own range, which is more like a consumer type of work. But if you're in enterprise and simulation type of work, you will probably choose the second option. So that should help a little bit, but for a better explanation, I would defer it to someone who knows better than me.
Sounds good, thank you. One more question online, then we have Daniele. Did the rise of AI, that everyone's been talking to a lot the past 2-3 years, play into the development of recent hardware in any way?
This is, well, it's a fantastic question. Of course it did, and that's the whole point. So what you see packaged on the Zeus GPU is actually quite the opposite. Okay, so all the people we've been talking to are people who still have a need to retain control of what's happening on the GPU, how the way they work. Like, imagine people making movies, right? So I know there are some people who want them to believe they can argue all day with a rock they were tricked into thinking to make a movie exactly like they have in mind, but it doesn't quite work that way yet, and probably not for the foreseeable future. So we focused on that type, on that type of features, right? The rest of existing GPUs, quite obviously, is going in a certain direction. They are great GPUs. There is no no shame in denying these are great innovators, they do fantastic things, but they're also pushing a certain paradigm shift. And the way this has been done, it's been done quite aggressively, right? So the people we have been talking to are kind of left, they feel like they've been left behind a little bit. And that's what we're trying to cover with our GPU. It doesn't mean that we can't do any of that. We can also do that. It's just simply not the focus of the user-centric driven design at this point in time.
Perfect. Daniela, you had a question. I do. Just waiting for the mic. It's coming in a second.
Thank you for such an interesting talk. I was really intrigued by your description of the programming language used to create the chips themselves. And could you say a bit more about it? Is it a description language like HTML or CSS, or is it a programming language like Python where you have branches and loops and techniques like that?
Yes, it's a bit of both, right, I guess, because you're describing an architecture, but you're also describing actually functionality. So how do you model functionality? So understand that once this language is sent downstream, it's going to be used to hatch billions of transistors that reproduce this functionality. So you, of course, as any other programmer, that's an intent, right? You use this software to transmit an intent that is in your mind, what this chip is supposed to do in this particular module. Is supposed to take two values from this register and this register, add them together, and put the result in this other register. So this is quite classic programming, as you will do with any other program. But beyond that, there is also all the other part which I can't answer for because that's not my specialty. But that's generally speaking, that's what you do. You actually reason like a developer. It's just that you are not a trained developer. You're a trained electronics expert. You know how chips work. You know how transistors work, and that's what's in the back of your mind as you try to transmit the intent to the machine via this language, right? So all I'm saying is that the methodology is actually very similar because you're writing software, but it's not writing software the way you will understand writing software that executes instruction sequentially after instruction on a fixed architecture. It's just it.
All right, thank you. Any more questions? Yes. Shams over there.
Yeah, thanks for the talk. I'm curious about glow stick and for the online path tracing. I imagine you're not exploring all of the potential paths if you're doing it online. So I guess my question is, how much of the improvements are purely algorithmic versus, is the idea to use statistical methods instead? You also mentioned clever caching and memory management. So yeah, how much of the algorithm or allowing you to do online path tracing is due to software improvements versus hardware?
Yeah, okay, I understand. So GlowStick is a full-on Monte Carlo-based path tracing, unbiased, at least tries to be. As you probably know, when I explain the basic of path tracing, that theoretically you can take an array, and when you decide what goes next, it's a random choice, right? That's the theory. But in practice, for this kind of level, like really high professional level, you don't do that. You actually decide, you systematically choose which direction is better, right? Because if it was completely random, then you would just need to shoot rays everywhere and will never see the end of it, right? So you have path guiding, you have variance reducing algorithms, you have a lot of collateral algorithms that makes the very, very simple path tracing algorithms acceptable. So that is still in GlowStick. It doesn't go away. But what makes it really, really fast, clearly, that will be the hardware. So you will question. The question that you will have after saying that is, how do you know? Because you're using FPGA, and you're simulating a hardware at a speed, like the pace of the FPGA is like a slug. So how do you do that? So the way we do that, we measure every single thing that happens on the FPGA, every single cycle, every time we write to the register, every time we write to the memory, get the result. We measure all the cycles, and now we know exactly, once we project those values on the final tape out, because we know it's going to be exactly the same, now we can tell you the performance gain, which is pretty fantastic. So I will say both, right? Thanks to the hardware, we go much, much faster, but the software, that doesn't mean the software can be lazy and not try to use state-of-the-art algorithms like everyone else does.
All right. We have one last question, but very, very quick at the back. Handheld 3 again.
Any word on the pricing or availability of the Zeus board, or any rollout or timeline in relation to that?
Yes, that's a great question, because I'm very proud to say, after we talked to everyone about, we discussed their needs and their wants and the way we can address them, their question is not, what about this, what about that? The question is, when can I get it? So that's very promising, right? So we're probably going to roll out the first release boards in 2027. Possibly early 2027, but 2027 is the date.
All right. Thank you very much, Antonio.
You're welcome. Thank you. Thank you.
All right. So we're going to be back soon. For those who are online, the stream continues. As I mentioned earlier, we have the Creative Commons music specially created for you for this event. We'll be back in this room with a new host for this afternoon. He's at the back. It's going to be Mohammed. He's going to present himself afterwards. That way you don't have to bear with me and my face all day long. We try to switch things up. So this afternoon will be Mohammed. We'll be back sharp here in London at 2 p.m. That's 3 p.m. for those who are in Central Europe, 9 p.m. in Singapore, 9 a.m. in New York, where we're starting the next series of talks. So enjoy the lunch here in London. And for those who are live online, be back in an hour and 25 minutes, roughly. Thank you very much.
Like a fool. I know it hurts you when I seem to be changing my mind. But sometimes, babe, you gotta be cruel to be kind. You gotta turn it off and turn it on again. You gotta keep control. Turn it off and turn it on again. Baby, that's the way I roll. You're not the only one with problems. There's always something going down. There's always gotta be somebody like me. Keep this world spinning round. I can fix a computer and I can fix a girl. And when they ask me how to fix this crazy world, I'll say, turn it off, turn it on again. You gotta keep control. Turn it off, turn it on again. Baby, that's the way I roll. Turn it on again. You gotta keep control. Turn it off, turn it on again. Baby, that's the way I roll.
drowning in the drink. Cool company. Baby, pick your poison. Baby, pick your poison. Soft sound in an empty home. Synthetics on bone. Baby, pick your poison. Baby, pick your poison. I heard she was dragged down the loop. No driver, just an empty coupe. Oh, baby, pick your poison. Baby, pick your poison. Got the big boys knocking at the plexi. That's why you don't lose that valley money, no. Baby, pick your poison. Baby, pick your poison. Baby, pick your poison. Baby, pick your poison. Somewhere in my mind, I've made a kind of heaven for me, where all of my world was made green and worthy. I know your monkey brain wants blood now, but ain't no one eating the cash cow. Baby, pick your poison. Baby, pick your poison. I sip my green point in the morning, medicine for my mind. Baby, pick your poison. Baby, pick your poison. Baby, pick your poison. Baby, pick your poison. Somewhere in my mind, I made a kind of heaven for me, where all of my world was made green, baby. Somewhere my life was saved. Rain down mercy on me, and bathed in the light I see. Yeah, baby, what you see?
we get started, let me pop my collar. Baby, let me freshen up for that pop the dollar. Ice cream, soup base, proud of product. You can't hate on the juice, man, pride the product. Ooh, when I get serious, let's booth the spot. We can put it on rocks till we off the top. Get a litty off shot till we off the drop. With the clouds, my G, I got caution hots. Oh, baby. Yeah. It's nice like this that made me. Yeah. My thoughts, they don't betray me. Yeah, you made me. These moments drive me crazy. Ask me how I got head up in the clouds. I ain't never coming down. Yeah. My head up in the clouds. My feet won't touch the ground. Forecast, hate away, sun in the Netherlands, sun that can forecast. Let me be your weatherman, let me be your weatherman here at the scene. Head in the clouds, I can easily dream, easily beam, up, you know what I mean. I bet a whole city of angels couldn't fly with these wings. I can string you along in these chords, I can sing. I can bring you to a string class before you can drink with me. Oh, baby. It's nights like this that made me. You know these nights, my thoughts, they don't betray me. Yeah, you made me. These moments drive me crazy. Yeah, okay. Ask me how I got head up in the clouds. I ain't never coming down. Yeah. My head up in the clouds. My feet won't touch the ground. Yeah. My head up in the clouds. I ain't never coming down. Yeah. My head up in the clouds. My feet won't touch the ground. Yeah. Let's call up the neighborhood kids like we used to be. Taking the love and the sun, all the energy. Never give up on your heart and the harmony. Oh, it could be a dream, baby, it's you and me. Let's call up the neighborhood kids like we used to be. Taking the love and the sun, all the energy. Never give up on your heart and the harmony. Oh, it could be a dream, baby, it's my head up in the clouds. I ain't never coming down. Yeah. My head up in the clouds. My feet won't touch the ground. Yeah. My head up in the clouds. I ain't never coming down. I'ma be up in the clouds. My head up in the clouds. My feet won't touch the ground.
Seems like I'm damned if I do and I'm damned if I don't. Got a family at home, but this music is all I know. I know. See, I'm a man, I got pride, I got pain, I can't hide. And I thought I had time, please tell me, where did it go? Where did it go? Where did it go?
Well, hello to 42. Revolutions on the planet. Still trying to come to grips with some shit that I took for granted. Hell, that ain't no easy fix, cause well, I ain't no mechanic. I accepted certain risks, but still this ain't the way I planned it. So now I'm pushing 95 down 95 in the Yukon. Shed so many tears, damn time be flying, where my youth gone? Pay so many dues, I feel I'm due, I guess in due time. The flowers don't compete, they just bloom, but then they do shine. I murder every beat they introduce, this is true crime. Say the violin, they buying in like a Groupon. Winston-Salem, born and bred like a crouton. So
You know off the bat I stand pat like Matt Judon. Until I'm supine in a casket up in Brussels, looking dapper with a suit on. I got people left to prove wrong, but all I do is do right and kill everything. I love my fam, and my fam said you better sing.
I'm damned if I do, and I'm damned if I don't. Got a family at home, but this music is all I know. I know. See, I'm a man, I got pride, I got pain, I can't hide. And I thought I had time, please tell me, where did it go? Where did it go? Where did it go?
She was staring in the mirror, I peeked on the low. I kissed the shoulder, I could tell she wanted some more. Hold it down for it, and while I'm on the road, while I'm living my dreams, baby, put other shit on hold. Centerfold beauty, ghetto old booty, got me on go. I try to leave, she pulling me in, rings don't go. Band for the bills, band for the kids, band for your finger, invitation in the mail. Y'all should come see us, response. Steve will play sock posse, Nabule partners thought you would go astray. I'm locked in, holding, taking. The vibes is Valentine's Day, even when it ain't. I hit the pavement, scraping for a dinner plate. When they hate, that's just debate. I fill the space with greatness when I'm on the tape. My latest was a throwaway, banger with the handle tape. Cause all I do is beat breaks and smoke heavily and try to get a bag for the fam. They my everything.
I'm damned if I do, and I'm damned if I don't. Got a family at home, but this music is all I know. I know. See, I'm a man, I got pride, I got pain, I can't hide. And I thought I had time, please tell me, where did it go? 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 Where did it go?
He said, baby, what's the big deal? Feel what you wanna feel. Say what you wanna say. You're gonna die one day. For example, I could kiss you just because I want to. What's the difference if you turn away? I'm gonna die one day. Why do you waste your time thinking about your reputation? Trying to meet an expectation, wondering what they're gonna say. When everyone you ever known said it for a headstone. I don't wanna give the end away, but we're gonna die one day. Your body is an animal, doesn't ask for much. A little music and a soft touch. Why don't you let it out to play? Your heart is in a bird cage, singing in your chest. You wanna shut it up or give it a rest. You're gonna die one day. Why do we waste our time? Think about an obligation, running from a confrontation, wondering what we ought to say. When everyone we ever known said for a headstone. I don't wanna give the end away, but we're gonna die one day. We're gonna die one day. We're gonna die one day. So baby, what's the big deal? If you wanna be free, say what you wanna feel. Spend the night with me. I'm gonna take you up in my arms. And if we must go down, we'll go singing to the smoke alarms. We'll dance into the ground.
I know when it happens,
blank to run you through. Oh, mercy, Lord have mercy, Lord have mercy on us all. Go look that young one in the eye. There is in defeat you recognize. Oh, mercy, Lord have mercy, Lord have mercy on us all. 'Cause you can't break me, 'cause you can't break me. Oh, mercy, Lord have mercy, Lord have mercy on us all. When your light broken in the ring, and we're waiting for the next act to begin. Oh, mercy, Lord have mercy, Lord have mercy on us all. 'Cause you can't break me, 'cause you can't break me. Oh, mercy, Lord have mercy, Lord have mercy on us all. Cause you can't break. Wounded, the creature tilts for you. Wheels his bloody flank to run you through. Oh, mercy, Lord have mercy, Lord have mercy on us all.
What's the probably mid-80s. Crackhead, zombie apocalypse, Hades. B-boys dancing on the streets to brick beats. Violent gang members just trying to make peace. Corrupt police, but what really has changed? People still robbing other people on the train. You ain't get taken for a phone or a chain. The more things change, the more they stay the same. Still some game one day at a time. I guess it's always gonna be hard rocks and crimes. So when the day breaks, I'm gonna rise and shine. With my eyes on the sky, let them go for mine. My eagle eyes spot graffiti on a freight train. Wild style East Coast heavyweight names. Memories, train yards, and great escapes. Spray paint left behind when they gave chase. Heightened senses, jumping fences to escape. Getting sentenced for offenses. Worst case scenarios left behind. They say you gotta keep moving, never press rewind. And now it's time to give thanks that we're still alive. Some younger than us did not survive. Read a rest in peace in the Hall of Fame. Old pictures unfaded on the wall and frames. Matter of time until it's all in flames and everything's just ash and it's all in vain. Because this is just a temporary state of being. So we got to enjoy every day that we're seeing to be free.
by my graveyard stone, and all my thoughts turn into arts. Could have been, should have been, whether I'm free or not. All my sadness vanished, it's madness, it's banished and never coming back. My face to the floor, heart racing no more. These lungs I adore have rocked to the core. In my last weekend swallow, my heart becomes hollow as the lands in my mind become fallow. All the dark and dreary nights I stand alone in terror and fright, crying out
Hello. Hello, everyone. We're starting in a minute. Can I please ask you to sit down and even better to come in front? Hello. Welcome back, everyone. We're currently live for the second half of the day, and we have some very exciting things coming up. So welcome to everyone who's online. Welcome to everyone who's in the London office. I'm Mohammed. I will be your host for the second half of the day. And I know if you watched the first half of the Ubuntu Summit, probably heard Martin saying that it took Mauro almost 4 years to get him here. It took me 4 minutes, right? That's because, well done, Mauro. That's because I work in marketing, right? And in marketing, we don't get a lot of opportunities to support open source directly like this. And when you have a chance like this one, with Ubuntu Summit, with all of you amazing people contributing to open source around the world, you just have to take this chance. So I'm glad to be here. And like for all of you, I think you will be seeing a lot of amazing things the next few hours. We didn't talk about AI yet. Who's here excited about AI? Anyone? No? Yes? Okay. All right. Before I start with the second half, I have a very exciting challenge for you. So we noticed something in the beginning today. Someone was trying to put a cup on top of this podium. And because the podium, of course, is inclined, it was really impossible to do that. As any open source community in the world, we decided we need to solve this challenge. So we put something on this course, a very basic design. You can design the next cup holder for this podium. We'll print it in 3D, and I will show it to all of you end of day 1 or day 2, depending on the designs. So feel free to make it as personal as you can. Don't put your face, of course, but you can put a mascot, for example. You can put your favorite release, whatever. We will print it here, and we will make sure that you all see it. All right, few housekeeping. Still, you know the drill by now. We want you to post your questions on the Ubuntu discourse or on the live chat. Keep an eye for Easter eggs. Some very interesting stuff are coming up. And there will also be some fun challenges, some polls, so keep engaged. And if you need a breather, the second stream on Ubuntu Discourse is running with music from FOSS artists, and this will be with us the full day. Now, let's get ready to get back into it. All right, starting the second half is a topic around robotics. I want to invite and ask you all to welcome with me Raffaello Bongi, who will be talking to us about building smart robots with NVIDIA's open platforms. So, welcome.
Hi. Thank you for everybody here or online. It's morning, I think, in US, really late night in Asia. But welcome for this afternoon. Here, I think, please stay a bit awake. I know it's after lunch. I try to make more easy this talk. We speak about robots with NVIDIA and all we can build a robot and what is behind in a really top-level view. No coding right now. And hope, yes, works. Okay. Well, I'm technical marketing and community support for NVIDIA. I just forget my role. And let's speak about what something important for us is NVIDIA Omniverse. NVIDIA Omniverse is a platform for robotics, and not only for robotics, where there are many partners are working, example, with us. We're supporting open, the open source and open company. example, we are supporting OpenUSD. When you design a robot, you won't import models, like import a model for robotics, like from your CAD. In this case, you need you have an external CAD you want to import on your system. I imagine when I speak with you, a digital twin. You are working in a warehouse, you are designing a warehouse. I'm a big company or a small company. I have just many products to sell, and I want a robot. Maybe a humanoid robots, because the robots are slowly coming. Humanoid robots, even in our life. And I want to use the power of the open source on my projects, example. And I can work with NVIDIA Omniverse, also with third parts products, open parts, for design my application. I was speaking about digital twin. Maybe, I don't know for everybody know what is a digital twin. A digital twin is an easy way to think a replicate world from a real world in a simulation world. Like I want to have a fully replica of my warehouse. I'm speaking about warehouse because I want to make a robot here in this office. I can't reshape the building like in 1 minute. There are other colleagues are working. What I do, I replicate in simulation. This is my digital twin. I make a replica, I design, I test my robot, test whatever. When it's done, whatever I made in simulation, I cover and put in a real, in an office or in a warehouse. How it's worked in this world with NVIDIA? What we designed it. Working with NVIDIA Xim is an open source system and software for robotics. You can work with the synthetic data generation and system in the loop or hardware in the loop. You can bring the data, like I was saying, from 3D assets, teleoperated data, or real-world data, and I import in simulation. I can test what I want for my robot. Can be a wheeled robot or humanoid robot. I'm really picky about humanoid robots because after we will see other software related for humanoids. When I simulate my environment, generate my synthetic data, example, I want to train a network, I can use directly the data coming from real data and from simulation, and I can build my new model to control my robot. After I can test or in simulation, mixing with the hardware, and after, when it's done, I can use whatever, what I made, my AI, my controller also, on a manipulator or a humanoid. There are many things are happening, and the world requires more power, even not a real robot, even, example, if I'm working in simulation. And there are many ways. There are the simulation part, where I work with NVIDIA Omniverse, I was saying, I'm testing, and Cosmos on a RTX. After I want to train my model, and I use an NVIDIA DGX or GX. And also, I want to deploy what I'm doing on the real robot. Example, with NVIDIA Jetson Tor, that support and work with Ubuntu. Or the GX Orin, there is a really different type of hardware for different type of robot I want to use. From a wheeled robot, for a really massive utilization of power and AI, example with Jetson Tor. And like I was saying, we have a really big ecosystem related for Omniverse and for the physical AI. Company in an open source environment, world, humanoid makers, robots and sensor makers. All together in this ecosystem can make bigger Omniverse. You can make design and testing with real software, real hardware, what is required for my robotics application. And let me back about humanoid robots. The humanoid robots, to be honest, I speak about what I noticed in the last, in particular year. I was surprised at how many humanoid companies are rising and making robots. And I remember I was studying, I have a PhD in robotics and control theory. I remember making a robot was like difficult. Making a humanoid robot is like a dream. Now it's become cheaper. It's like, well, I can make a robot. I can directly buy in a shop. Honestly, found in a shop. And I'm surprised. This is what this means. We need more AI. We need open source, more support for these humanoid robots, and for the startup are working and making humanoid robots. We made Isaac Root. Okay. And and Isaac Root is an open source platform with models related for humanoid robots. What is important? There are many things we noticed in the beginning. We have some data coming from web data, example YouTube, Reddit, whatever, and are real data. We want there is also synthetic data. Yes, okay, the button works. I want to also generate other data to drive my humanoid robot, because some application of the robot, the humanoid, are never tested. Like I want to open a bottle. Well, now yes, it's really tested. But there are other things that maybe a humanoid robot we don't have a lot of data. In this case, I can work in simulation to generate this missing data to train my network and work with Isaac Root. And also, I can work in teleoperation. There are some videos that are not running, but I can show the meaning of this video. In this case, I can also work in teleoperation. I can drive manually the robot and record whatever I'm doing in teleoperation and use this data to train a model. What I can do now? I have my input, a sensor input from the robot, prompt coming, data coming from the simulation or from the teleoperation, and I use Isaac Root, such an open humanoid robotics platform, to generate the action I want for the robot. And all these things are running on a JSON Tor. We are closing this loop starting from a massive data center, like a simulation, a massive model. Step by step, I also close this loop. Okay, is in a robot. Using a JSON Tor example to work on the robot. And there are many things. There are foundation models, example on Isaac Root. I also can train with Isaac Sim, like we have seen previously, and Isaac Lab for a multi-robot simulation. And, well, like I say, there is the Tor Robotics computer, a board JSON, defined for humanoids. Like we have seen in our general introduction, for Isaac Root, there is the simulation area where I can simulate on the open platform all I want the robot do, stuff, example, pick an object in a bowl or doing other interaction with humans. I train with the synthetic generation pipelines and Isaac Sim and Isaac Lab, and finally deploy on Isaac Root directly on JSON Tor. Yes. There are many steps inside Groot. I can use on Isaac Lab Groot teleoperation. I can teleoperate the robot. I can mimic what I made, example in simulation or in teleoperation in particular, what the robot I'm doing driving on the real robot. And I can generate the model and generate the videos with Cosmos as well, the 3D part, and testing and train my model. There are really different steps, all open for the robotics and humanoid robot application. Here there is another video that I will tell what I was showing. Starting from a teleoperational stuff, that was the first part of the video. You manually drive on Isaac Root the robot, you grabbing the things, you training a network, and on the second part, you can the robot is moving and is able to pick the object and moving autonomously. The final part, but not at least not the really important, is making all this software running on the real robot. And we have the JSON Tor recently released support on the Ubuntu 24.04 Ubuntu 24.04, extremely performance with a Blackwell GPU. Many more cores. There are many more GPU, GPIO to drive, example, all motors and controller on the robot, and is specifically designed more for humanoid robots. And same story for Jetson. There are many partners are working with us, camera makers, open source company as well, software companies, hardware designer, and make the ecosystem bigger. You can work easy and define your robot, your application with different type of other software on Jetson. That's all. I hope everyone are awake.
Okay. I don't think you can tell a boring story about a robot, so that's always amazing. All right, who has questions for Raffaello? Let's get someone. Yes, here, please. Thank you, Daniel.
Thank you. That was fascinating. You spoke about the leap forward from not being able to imagine doing work with a humanoid robot to literally seeing them in the shops. Yeah. And what has been the main driver of that advance? Is it just in computing power, or is it in other things as well?
I think there are many things are coming. Sorry, okay. There are many things are happening together in this period, in these years. It's rising the AI. Now you can use the AI everywhere. Also, the price of the robots is decreasing. Now you can buy a humanoid robot less than years ago. There is more power coming, example, for the Jetson Toro. Now you can build a massive robot with a lot of power. You can use all information coming from the camera to build a real-time AI. This is an example. But you have many things that are happening now to build a humanoid robot. Something that you can see a cheaper price. Because I remember when I was a student, a university student, I was say previously, making just robot was really expensive. Now, okay, I can do it. And if I can do, there is a lot of AI. I can bring my AI with Groot, training my network, directly testing. I can close this loop more quickly. I can make more tests. I can speak with the marketing. I can find finally a goal for my marketing application. Personal point of view. This is, I think, what is happening now. Okay.
Yeah, there's one question in the back.
From the way I understand it, the Omniverse is kind of a bit like Unreal Engine, and how you have lots of things in this marketplace that are compatible with the engine and people can contribute and put them out there. So my question to you is, what's the process of getting resources into the Omniverse look like for some external contributor?
The most important things when you're making, example, your software on Omniverse, you can test and you can give to your partner, your customers, an application where you can bring other stuff and combining and make your demo more quickly. Example, you have I'm a robot designer. You're a producer of a part of the software. If I well understood your question.
No, more like if I have a piece of hardware, if I have a robot.
Okay.
How do it sounds like there's pre-built models that come with the Omniverse, right? So what does the process of getting those kinds of things into the Omniverse look like? Simulation environments, different models.
In simulation, you can design your hardware. You can design example with such an example. I work on a simulation. I can make my USD file, open a USD file, where I design my robot or my hardware. I can import internally on Omniverse on Isaac Sim. I can also make my software or use a third-party software, example, a specific camera sensor, camera hardware, that is implemented on Isaac Sim. I'm combining all these things and I can test in simulation. And after, when it's done, I can bring back what I simulated to my hardware.
Cool.
Okay.
So we are speaking about partners, companies. How about students who want to get started learning robotics? What do you tell them? Where do they start with the resources that they can afford?
Well, now there are many ways to do. I remember when I was starting, finding these kind of things was difficult. Now, with an example, with Isaac Sim is open source. I can directly download and start to work directly with that. There are many courses. The NVIDIA example providing the DLI courses to learn how it works the software, or I can combine different type of software. I work with ROS. I want to use ROS on Isaac Sim, or I want to make my Python script to drive my robot. There are many courses, example, we provide, but also you can find online to make your robot for such a student. And also I can build my robot with different type of education programs for robotics, starting with Ori Nano Super, or bigger, if Jetson Tor maybe is not for a student, but it's more for companies. But well, there is also Jetson Tor or in Nano. I can start to programming with, again, with open source. Example for me, I was using over 10 years ago, wow, I feel old, ROS. And I was using ROS with was Ubuntu, was Melodic, I think, Ubuntu 18 or 16, was a really old LTS. And I was working with that. Now it's much better because even if I'm a student right now, I can ask ChatGPT which is the best combination to start to work, and there are many solutions to resolve and learn what I want for robotics. Welcome.
Any other questions?
What is the main big bonus to using Isaac Sim over something like Gazebo or a more openly used simulator?
Well, there is no first point. There are no competition between Gazebo or other Isaac Sim or other simulators. It's just the best way to simulate what I want to do. And this is, I think, is important when I design my simulation. Also, there are many ways now to interact with the simulators. Isaac Sim is more for photorealistic view, for simulations, like I want to generate, build an AI, I want to train a lot of a model. In this case, I want much more similar, an environment that is more photorealistic. There you have a really good power coming from, performance coming from Isaac Sim, but I can switch with another simulator, easy. Example, if you work with ROS, you can build your connector, you test whatever you want, switch, use Isaac Sim, but it's really depends what you're starting to design. I think right now, where the robotics is moving, you want more AI on your robot, instead of only drive or testing the physics, personal point of view. But what I notice, in particular, there are many robots right now on the market that are working really well, extremely cheap, but I want more AI, more interaction with humans. In this case, we want more photorealistic view, more performance. I want to train a proper network.
Thank you.
And just to close the loop, I'm a control engineer, that for me, making really an hardware, closing the loop in the strongest way, and the AI, I always feeling, okay, it's not the best, but now I think, yes, it's the right way working in AI. Okay.
Thank you. We have time for one more question. All good? Any? Okay. Can I have the mic?
If I can go back to the question of humanoid
Okay.
robots, I can see why people are interested in humanoid robots. But do you think there's genuine value in them, or is it simply a kind of human emotional desire to see that kind of thing? You know, for example, nobody ever thought of making a self-driving car by having a humanoid robot driving it.
Well, it's more a philosophical question, I think, than a real engineering practice. But, well, there are different points. It's more philosophical, because what happens if a robot substitutes a work of a human? This is a philosophical. More government issues, like what I do. Example for automotive. The cars, technically, the engineering behind to make an autonomous car is mostly done personal point of view, but I see what I see in car moving not in the street, the performance are really high. The problem is more government. What happens with the law if something happens, if a car hurts a person, or I can automatically change, there are no service or facilities for this autonomous car, is more general point of view. There are many things, again, for me, that humanoids become important stuff for support people, starting from healthcare, example, people with disabilities. Just a first example, I think a humanoid robot can be helpful, personal point of view, but also supporting to the supermarket a few things, or other things that some jobs, but this is really personal, because depends. It's more a philosophical point of view, because what is a really work that is a good substitution compared to humanoid robots? This is, I think, will be the market, will drive this point, more than a philosophical point of view. But yeah, I think there are many ways, by the way, for a humanoid.
Thank you. This is like the best way to end this section. So a big round of applause, please.
Oh. Thank you. And thank you online.
A quick reminder for everyone watching us online, you can still put your questions live on Discourse or on the live chat. Before we start the next session, I wanted to ask you, who here has the Ubuntu, the Ultimate Ubuntu Handbook at home? Anyone? Only one? Come on. Okay. All right. Okay. So I have some good news for everyone watching us online or here. We have a special discount code for everyone. So if you go to Discourse, you can get 25% discount on buying the book. And this is only for the Ubuntu Summit attendees. So quick reminder on that. All right. For our next discussion, for our next topic, we heard John in the morning talking a bit about Rust. And today we have Mark to deep dive a bit more into that. He will talk about sudo rs and beyond. So round of applause, please. Thank you.
Yeah, so I would like to start this talk. So I actually wanted to start this talk by asking who here has heard about Rust, but because John mentioned Rust this morning, I cannot do that. But I would like to see a show of hands. Who knows what Rust is actually about? That's quite a lot of hands. Who here in the audience has maybe actually written or seen some actual Rust code? It's about the same number of hands. That's interesting. That means that Rust still has a lot of growth potential. Then the final question. So who here thinks that solving a lot of software vulnerabilities in existing C and C++ code bases is simply a matter of rewriting it in Rust? Oh my God, there's one hand. This is maybe going to be a tough crowd for me then. But no, not really. So I would also not put my hand up if someone would ask a question like that. That's not because I don't think rewriting software in Rust is a bad idea. But basically, if you do it, you have to treat it as a new software project that you're starting. And what I want to make this presentation about, for the most part, is basically sharing some experiences of what you have to contend with if you do that. So let's start with some context here. So what is sudo rs? You've guessed it, it's sudo, but we implemented it in Rust. This project was started early 2023 by the Proximo project, which is a project run by the Internet Security Research Group. And they are big about memory safety. They don't develop much software themselves, so they hire two companies. One is Tweede Golf from the Netherlands, and that's how you pronounce it. And Ferris Systems from Berlin. So we got together a nice team of international software developers, 5 people in total, and we started building that. Later, a new open source software foundation was founded, called the Trifecta Tech Foundation in 2024, and that's now the new home of sudo rs, and they're taking care of this. Now you might ask, so I was told to smash that clicker button, and now I know what is meant by that. So why did the Proximo project start, the sudo-rs project? So one of the most well-known software projects is called Rust TLS, or Rustls, which is a TLS implementation written in, you guessed it, Rust. So some of the criteria that they use for selecting software projects that are good to rewrite in Rust are basically that it has to be something that's used everywhere. It has to be something that lives on a security boundary, performs a critical function on that boundary. So basically, I think if you're mediating a security boundary, that's already critical. And also, there are no current implementations that are written in modern memory-safe programming languages. That's basically their whole thing. They care big about memory safety. So that's the why. But of course, I didn't conceive of doing sudo-rs. So maybe the better question is, for me, why not? I mean, I'm someone, I like modern programming languages. I have a background in academia. I like open source software. I've been using it for 25 years or more. I like contributing to the wider world. And then if someone sends you a message saying, hey, how would you like, as part of your day job, to work on something that can have a huge impact? You can write it in a nice modern programming language. I mean, why not? So that's the honest answer here for me personally. And also, if you think about it, so let's step away from the motivations for the Proximo project to start this. What are some of the motivations that I can think of why rewriting sudo is a good idea, why I can stand behind that? And one is, of course, there exist some alternatives for sudo-rs, or for sudo, but you cannot easily switch to them as a user, because many shell scripts, many other programs, they depend on sudo to mediate that privilege boundary. So yeah, so it's nice that, for example, systemd made run 0, and it has some real advantages, but it's not easy to switch to that, and then the impact is lessened. So if you can make something that's very compatible, that's good. And yes, memory safety is important. So we spoke to Todd Miller, and he estimated that, so Todd Miller is the maintainer of original sudo, and he said that basically 30%, he estimates, of serious vulnerabilities in sudo are caused by memory safety issues. That's actually, by the way, a very low number. It's more typically numbers you will hear quoted are that 70% is caused by memory safety, and that only says something about that sudo is a well-maintained software project. My main motivation, however, for why I would like to write sudo in Rust and why I liked working on it is that there's a lot of business logic in sudo going on. And if you're using Rust, you have a modern language that has a very expressive type system, and it's much easier to express the logic in a way that's maintainable and readable. So if you look at sudo-rs, and I also see that when I look at the number of external contributions that we've had, people find it easier to make modifications in our code compared to this C code base that has to use a lot of like old school C techniques to make the code work. I wrote a blog about this in 2023, re-implementing sudo in Rust when you want more than just a sandwich. And that's because a lot of people think of sudo as just this XKCD command where it's like, make me a sandwich, and that's what sudo does. But when you start implementing sudo, you also need to learn what sudo does, and then you discover that sudo does a lot more than you think. It has a lot of logic in there that's preventing attacks and keeping users safe. For example, it basically starts a whole new terminal to isolate the process it starts. You probably never realize that because it's so well implemented. So we started hacking away in our little team and doing all these things. And oh, there's also this part in sudo. We need to implement that as well. And at some point we encountered this feature, and that's if you mistype your password, you can tell sudo to send an email to the system administrator. So we implemented that as well. And I don't know who of you has ever checked their inbox if they've had messages from sudo saying, hey, there was a user on your system and they appear to mistype their password. I see no one. Okay. The problem is also, how does sudo do this? Well, it interfaces with sendmail, which of course is a software project with a rich and colorful history as well. To interface with sendmail, you can do that in Rust. It's not even that much code. but you have to take a dependency on something that's called a crate, and that has all the dependencies, so you pull in hundreds of dependencies, and those dependencies don't know they're going to be used to mitigate a critical security boundary. So we started scratching our heads, and I was like, should we really be doing this? And we had one engineer on our team, and he was always very adamant that no, we cannot do this. Also, there's something called Zawinski's law. Who is familiar with Zawinski's law? So that basically, correct me if I'm wrong, but it says that every software program will evolve until you can read your email with it. Now, you cannot at the moment read your email with sudo, but you can write your email with sudo. And anyway, I mean, just use your syslog. Sudo also sends things to the system log, and as an administrator, you can do that. So that made us think, well, you really have to smash that button. Yes, so we're not simply rewriting sudo anymore, because there's just too much of sudo. So a rewrite is a good point for a rethink. And that's like, this is of course software engineering jargon, like you think about the requirements. So what are the requirements of sudo? And you can learn what they are by looking at sudo. What does sudo do, and how do people use sudo? And then you start thinking, well, we're going to make software that can be used for that. So we're not going to be blindly copying every little feature that is currently in sudo. And also we don't need to do that, because after a few months we discovered that there's not anything inherently super broken or wrong with original sudo. It's still a maintained program. It still exists. We can be an alternative implementation. It's not like NVI doesn't exist in our repositories anymore since we have gotten Vim, for example. There are still cases where I use an alternative VI implementation. And yes, I am one of those weird people that use VI. Not weird. Good. I have supporters in the audience. Yeah. Also, if you do like a blind, dumb, pure rewrite, then what would be the point? So in June this year, a massive vulnerability, massive serious vulnerability was discovered in sudo related to the change root function, which is not memory safety related. So if we had implemented that, then there would have been a chance that we would have also been vulnerable to that. But we didn't. Anyway, of course, if you're going to rethink your sudo, that also means that, so what exactly does it mean to be a drop-in replacement? So we got together as a team in Berlin in an office on a nice May. We just had the press release out that, hey, we're building a new sudo, so the entire internet was dumping on us. And we sat down in a room and started thinking, what features are we going to do and what features are we not going to do? And we used the two most powerful tools in the arsenal of a software engineer, which is a whiteboard and colored post-it notes. And also because we are an international team, so we had columns ja, maybe, and nein. And you could write a feature on a post-it note and then you could attach it there. And I started taking photos. And of course, this is the first photo. And there are some features on here that are now implemented, actually, but they are in the nein column. So but every time we were not happy with the arrangement we made. We started moving these post-it notes around, and you could make more photos, and we started discussing, and this lasted an hour and a half. We really got nowhere until someone noticed that we were always making the same kind of arguments to argue for or against a feature. And then we had the bright idea we should write those down. This is the very first iteration of that. Sorry for the people online that I hit the microphone. So this was written in the corner of the whiteboard in our best handwriting. I see some people trying to read this, but you don't need to, because this is the modern iteration. And there are basically 5 rules. So the first rule is, and it's maybe not that controversial, but it is, I think, the thing that we're going to have the most discussions about going forward. And that's that we care more about security than functionality. So yes, there might be some features in sudo that are really nice and they make your life easier. But if they don't help security, we are less likely to be in favor of that. And I'll have an example of that. And I hope I don't get lynched when I show it. And then there's, I mean, this is of course a no-brainer. Everybody knows the KISS principle. every solution should be as simple as possible. So complexity is the enemy of good software design, and especially in sudo, where if you make even one tiny mistake, things go wrong really, really fast. And then the other one is, and this is maybe a little bit more tricky to think about, so features solve problems. We don't just add features because we want to have features. So every time you ask us, could you add this? We're going to ask you, how does this, what problem that you currently have is solved by having this feature? And also that problem needs to be something that more people can experience. So it's not just you. And also the problem has to be reasonable. And my favorite example here, so you can tell that we are big fans of XKCD, is heating your spacebar. I see people know this one. That's not a reasonable feature to include. I've called this, this is just pure me, I've started calling these our Berlin criteria. And I'm forgetting actually one. That's the fifth one that we didn't put on the whiteboard. And that was because the internet was dumping on us, because they were looking at our GitHub repo and they were seeing hundreds and hundreds of dependencies. And they were saying, that's too much for a setuid program. And also I heard already some Linux packages complaining that this is hard to package. And we agreed with those comments, and we listened to those comments, and then we put sudo on a diet, and we actually currently brought it down to, I think, 3 direct dependencies, and they're all maintained by the Rust project. So I think sudo is a very lean project, and we want to keep it that way. Now, I'm a history nerd, as well as a computer nerd, so I think everything that you associate with Berlin just adds gravitas to things. So I've started calling this our Berlin criteria. So if you see me mention Berlin criteria on GitHub, this is what I mean. These are our rules. They're also mentioned in our contributors guide. And I think that adds a nice amount of weight to it. So this is the one that I vetoed. And that's that original sudo has an option to insult the users if you mistype your password. So not only does your sysadministrator get an email, but you also get an insult to your face. And I was like, this doesn't need to be in sudo, because it fills the list I just showed. At the same time, a lot of people asked us about this, and then I started coming up with, well, you can make PAM do this, and luckily someone has written a PAM module that allows users to be insulted, and that actually is the final nail in the coffin for this feature, because you can have this functionality with sudo rs. This is sudo rs, and it's insulting me because I mistyped my password. Also, my GDM login screen now insults me because when I mistype my password. So if you like that kind of humor, that's fine, but making you laugh is not a job of sudo rs, sadly. We're serious. The other one is this. So this maybe expects that the audience knows a bit about how you configure sudoers. So basically, if you put this in your sudoers file, the intent here is that I want to give all users that are a member of the clean group the permission to remove temporary files that might be owned by root. Right? So it's in the group of which machines, what commands, and then which files am I allowed to eradicate. Does anybody see a problem with this? That is a sysadministrator or a sudo user. I see someone laughing, so you know something is coming. So this is, okay, let me reveal. So if you put this in your sudoers configuration, you've actually allowed users to do this. So it's a bit low on the screen, but basically it's, I will read it for the people in the back. It says rm-rf/-no preserve root space .tmp. So we're going to remove your entire file system and also maybe .tmp. And the reason for this is that wildcards in original sudo are interpreted textually. So a white space matches that wildcard as well. As a team, we couldn't see any conceivable way that you can use this in a way that's not going to be a massive foot gun for users. So we just removed this. Sometimes in my mind, I'm still thinking like maybe we can make a slightly more restrictive version of this. But then again, but no one has requested this feature, so maybe people don't care that much about this. For comparison, original sudo also addressed this problem, I think, a few years ago, and they added regular expressions, like if you want to be able to do this, to be more secure. Now, I don't know how you feel about regular expressions and especially reading them, but for me, they are a write-only solution to things. So we are also not a big fan of doing that, and also adding regular expressions would mean we have to add another dependency. So we're not going to do that, most likely. Also, there's another workaround for this. So suppose you really want to allow users only to execute certain commands with certain arguments, you can write a shell script for that and then give people the permission to execute that shell script. So this is not going to be in sudo. That said, the Berlin criteria is not just that we're building this proverbial wall around sudo. That's not the intent. The intent is also that people know if they want to add a feature, what the chances are of getting them accepted. And actually, and I think John mentioned this this morning, the biggest benefit of using Rust for sudo for our team has not necessarily been the memory safety issue, although that's nice, but you get it for free. The biggest benefit is that, well, first of all, we have a smaller code base, and that's easier for external users to look into, but also, suppose we have data somewhere that we've allocated in the heap, and maybe we're looking, well, that doesn't need to be in the heap, it can be on the stack. So we're going to change the way it's allocated, and we're going to make some reference changes here and there. If you do that in C, I would be worried with like, is this refactor correct? And especially if it's been written by someone that's I don't know, it's anonymous, they have a nickname on GitHub, do I trust them? But with Rust, this is very easy, because if it compiles and it type checks, the borrow checker has got my back. I know that if they change something here, it cannot typically cause any spooky action over there. So it's also much easier for us to review contributions and be convinced that this code is safe. An example of this is that the password timeout feature has been implemented by an external contributor, and also sudo can ring a bell if it asks you for your password. This has also been contributed by an external user. So these are two modifications in a very crucial section of sudo, which is handles your passwords. And we've just let other people write that for us. One particular contributor that we are very fond of is, I already mentioned, his name is Todd Miller. So Todd Miller is the maintainer of original sudo, which is now called sudo.ws in the new Ubuntu. And of course, well, he has actually contributed to our code base. He has fixed the bug for us. But of course, large parts of sudo is based on, sudo RS is based on his sudo. For example, all of the signal handling and terminal things, there's a lot of wisdom in his code base, and why would we not look at that? And if we think it's good, why wouldn't we like take that? So sudo RS is a derived work of sudo. Also, he has served as a technical advisor to our team. So we have questions, we ask them, and the nicest part is because he has written a sudo, and we have written a sudo, the questions can be typically very brief, like, hey, how did you solve this? And he's like, yeah, you do it like that. And also, we found bugs in his sudo, because we've written a test framework where we compared versions, and then he was typically very quick in fixing those bugs in original sudo. So original sudo became a better sudo because of our project. Why I want to also mention this is that I know there are some personalities in the open source world that can be rather spiky. And I could imagine if you've been maintaining something for 30 years, all by yourself, and like these young people come along with their newfangled, fancy, flashy programming language, and they're like, we're going to do a better job than you. Then maybe you could be a little bit maybe irritated by that, but not Todd Miller. He has been nothing but helpful and gracious to us. We have massive respect for that, and I also think this is what open source should be about. I was also struck by Mark Shuttleworth's comment this morning, where he said that most people, like you may be somewhere where you are right now because of some work someone else did. For me, that's clearly the case. I'm standing here because of work that Todd Miller did. And I think that should be an example to many, many software projects. But also, the fact that sudo for these many years has been maintained by one single person is of course also a kind of a danger. So I'm guessing this is also, again, a well-known XKCD, and I think I don't need to explain what I mean with this picture. Somewhere here in London there might be a bus with your name on it. And so if we've gone through all this trouble to rewrite a sudo in Rust, and then we just don't maintain it properly, or we have a single maintainer situation, we have improved things maybe a little bit, but not that much. And that's where I get to the beyond section of this talk. So how do we solve this problem of making sure that the software utilities is well maintained? And that is the Trifecta Tech Foundation. So sudo-rs has been moved to this foundation, and also with the intent of making sure that it's always a team of engineers that's working on sudo-rs. So and that means trying to fund maintenance as well. And the Trifecta Tech Foundation is mostly interested in making sure that the building blocks of the internet are safe and well maintained. So this is a mission that's quite similar to the Posimo project, but it has a particular scope. So sudo-rs is not the only project that the Trifecta Tech Foundation is running. Other work that we do is data compression. So one of my colleagues is busy writing a zlib library written in Rust, which actually has a C interface. So the intent there is that you have a C program and you click in the Rust version of zlib instead of the original one, and you get the benefits of having more memory safety in that part of your code. And also, compared to the OG zlib, a performance boost. And the other one is time synchronization. And I have a slide about that as well, and I will finish with that. Or actually, I will finish with a little bit more than that. So that's also something that's very foundational to the internet, because like I can look at my watch and can see that it's time that I start wrapping up this talk. But how does my phone know what time it is? It's because it gets the time from a server somewhere. And that protocol is not secure. So it's very easy to mount attacks to this protocol. I mean, there are some mitigations, but if someone really wants to change your clock, it's very doable. There exists a protocol for that, the Network Time Security Protocol, which I believe the Questing Quokka Ubuntu release also tries to address by having Crony by default now, and they supply NTS servers. I see someone nodding in the audience. So that's also something where we are much in line with what Canonical is doing. And that's also something that the Trifecta Tech Foundation is pushing heavily. So we want to have more people use secure time instead of the old-fashioned NTP protocol. So to wrap up, I started maybe this talk by I hope, maybe like putting Rust in its context. And that's also because I want to make people know that I'm not a blind believer in Rust. Rust is an excellent tool for particular jobs, and I really like it. And people that are programmers but had their hands down at the beginning of this talk when I asked if they had written Rust code, try it sometime. It's not that scary. I could hold another talk for 30 minutes about how nice it is to learn Rust. What is sudo-rs? So what I want you to remember is it's more memory safe and it has a reduced feature set. Because you now have a second sudo implementation, you actually got more freedom. You're no longer limited to this one implementation. There's now two, and you can pick the one you like the best. You can contribute by going to our GitHub page, and also I hope I've spiked your interest a little bit in the Trifecta Tech Foundation. If you Google that, or go to our website, which most of the people are not able to read properly, you can find more information. And then from this stage, I also would like to thank all of the contributors, if they're watching, that have helped us so far, and also the companies that have helped us by sponsoring or actually contributing in kind. And of course, I want to thank you all for listening to me.
Thank you so much for the session. Any questions? Can we have a mic here, please?
You have mentioned that you have been trying to cut down the number of dependencies that you are using. When I look at other Rust projects, my impression is you are just trading memory safety against supply chain safety?
Okay, I can make that into a question. Let me share my thoughts. So when I started using Rust, I also was surprised by the carefreeness that you do cargo install, and it's like 600 dependencies and also they run build RS programs just in your terminal. That was scary for me because I wasn't used to that. I think web developers are more used to that. I do think that there's a growing awareness, and I'm also pushing awareness for that. I think this is also a trade-off that it's easy to add these dependencies, and this has helped the ecosystem to grow, but it has this downside. That said, of course, if you look at the dependency chain for, say, a C program in Ubuntu, you will also find that a lot of C programs, they also have hundreds and hundreds of dependencies, and if it's a C dependency, of course, all of that code is memory unsafe. And so with Rust, it's not. But it is something that we need to be worried about. So thanks for raising this topic.
Yeah.
Hi. Thank you for the talk. It's super interesting. I wanted to ask you about the maintainership situation. So looking at the commits from the last 12 months, like 90% of them is written by you and your other colleague. And then you get the occasional, the typical long tail of contributors, right, that contribute maybe 1 time or 2 times, things like that. Do you have any plans to try to train other people or make it easier to contribute and nurture like a community of maintainers, apart from the foundation, right? But
yeah,
a bit more concrete.
So I mean, I have some thoughts about this. I don't want to share too much in public here, because if I say like, hey, if you're a contributor and you've contributed often and we like your contributions, then maybe we're going to invite you to join the team. But I think that would be the road to take. Also, I'm also trying to keep, of course, as a lead of this project, to keep everybody that has been involved in the project. I'd like to keep them involved in the project by making sure they occasionally review commits. And also, if you look at the commit history, you will see that it's me and Björn for the last 6 months. But that also means that it's still a team effort. So it's much like 2 is still more than 1, and it's definitely at the moment also still more than 2. But this is something that you need this foundation for, to get this governance. You need to get that in order to avoid this problem.
We have one question online to ask you about that. So, what has been learned from this project that could apply to others, in your opinion?
That you should use Rust if you start a new software project for systems engineering. Rust is a really good vehicle for that.
Right. Thank you so much for your time today, and yeah. Right, before we move to our next session, just a couple of reminders, quick ones. First, the design challenge is going on. So anyone who has some design capabilities and want to design our next cup holder, we're waiting for you. It's on this course. You can design it. We will 3D print it. We'll put it here on this podium. So I see a lot of design people here, so I'm telling you, go and play with it a bit. Okay, and a second reminder, if anyone is looking to buy the Ultimate Ubuntu Handbook, we still have discounts on this course, so you have 25% discount. So you can go to this course today, get the discount, and buy your book. We will have a few things happening in the next few sessions. One of them is Easter eggs. So for anyone watching us online, there will be some Easter eggs around this course, and also we'll be talking about them here. So everything is happening there, so don't miss it out. So we do a lot of amazing things around open source, but I still feel we have a problem with naming. I don't know why. But with that, I want to introduce my next speaker, talking about bringing Lynx to desktop and beyond. This one, Wang. Thank you.
Hello, everyone. My name is Zhi Xuan from ByteDance. In case people don't know, ByteDance is a company who make TikTok. And my topic today is bringing Lynx to desktop and beyond. The first question is that, what is Lynx? Lynx is not, the Lynx here is not the terminal browser, but a cross-platform engine that wants you to write code once and build UI or applications running on any platform. It solves the same problem that the web, React Native, Flutter, and all many other things are trying to solve. And it is freshly open sourced earlier this year. So Lynx is widely used in TikTok. For example, that Lynx is used in the eShop, the search page, the advertisement, or the major event, such as Met Gala or the end-of-year event. So Lynx has three major features here. And the first is our platform support. We support Android, iOS, and web, and our performance and our web-inspired design. Let me introduce from the web-inspired design. It means that developers can get like web-like coding experience by using Lynx. So here is the demo that the front-end code is writing in React and using Lynx. And Lynx will run the React code into a native UI. And also the developers can write the real CSS here and to steal the native UIs. And then it's the performance. Lynx has a unique dual-thread solution to solve the performance problems of front-end. Like Lynx, instead of having only one single runtime, JavaScript runtime, Lynx actually have two different runtimes running on two different threads. The first one is the main thread runtime, which runs on the system UI thread. And the main thread runtime will provide a set of API, which we call it Lynx DOM API, which enables the front-end code to interact with the native UI. And the second runtime is a background runtime. And the background runtime provides native module which interact with the system utilities such as network or storage. So when the front-end code is compiled by Lynx, it will be compiled into two different scripts. And one script is for the user interaction high-priority task, which includes the first screen rendering and the user interaction handling. And it will be run on the main thread, the main thread runtime, as well as the system UI thread. And another part will be compiled into the background runtime, a script running on background runtime. It will execute some lower priority tasks, such as event set effects. For example, if I have to make a network call, it will be running here. So by drawing a clear line between those two kind of runtime, we can always have the high priority task, which handles the user interaction running on the main thread and throw away all the time-consuming tasks into the background. So by this kind of architecture, we can achieve such things. And all those pages is implemented using front-end techniques, but we still can get instant first screen rendering and instant event handling without latency. So as a conclusion, Lynx is a dual-thread UI renderer based on WebDX. So my topic today is about extend Lynx to desktops and beyond. And how did we achieve it is by mapping the Lynx DOM API into a component. We call it Clay. Clay is a library that we fork from Flutter and transform Flutter into a UI widget library, which render UIs into texture. As people may notice, we use native UI on mobile, but we use custom join UI on desktops. But why don't we use native UI also on desktops? There are some cross-platform engines do use the native UI, for example, Java SWT, the React Native. But still, there are some other cross-platform engines using custom join UI, for example, Qt, Electron, and Flutter. So in my personal opinion, the most favorite framework to code a desktop application is Qt and Electron. So they are both using the custom join UI. But why? So my reasoning to it is that desktop suffers a lot from the system UI fragmentation. Where desktops operating system has a longer history, so with more legacy, and we have diverse operating system here. So as a result, like user has less system fidelity on desktop's design. For example, like the Android coders will follow the material design and using the HIG on iOS, but like when developers are developing the desktop application, it seems like there is no clear design guideline for the UI. And for the developers, it also makes things get a lot more harder to make their native UI running on different version or different flavor of the operating system. And also for the cross-platform engine maintainer, it things get even harder because we want to let developer write once and run everywhere. So we have to make things consistent among different platforms. So with the UI fragmentation, it's just too hard to achieve that. So with custom join UI, we get a lot of like consistency over platforms. And it is also easy to adapt our techniques into another platform. So by using a cross-platform techniques with custom join UIs, the coders can get better developing experience as well, make their application work in more platforms. So that's two very important thing to developers. And I am going to show two cases by our company. The first case is the CapCut. The CapCut is a video cut software. It is popular among TikTokers. And it is written using Qt. Yeah, by using Qt, we actually coding natively, so we get a software with high performance, small application size, and short startup time. But there are costs. We cannot be very productive with Qt. Even Qt has its QML, but we have to write a lot of C++, which is not very productive comparing we are using JavaScript, coding always front ends using web, right? So the developers want the WebDX to make things more productive. The second case is the Douyin. It is the Chinese version of TikTok, and it uses Electron to build its PC client. So with, Yeah, by using Electron, it gets really high development productivity. And also the PC client can share large part of code between the desktop with the web version. But the cost here is that the Douyin application suffers from a very long application startup time and a very high memory consumption. But we don't settle down for that, right? So can we have the best of the both worlds, the best of web and native? So when we are using the native techniques, we want to have web developer experience. How should we do that? My answer to it would be to use Lynx. So Lynx do provide a set of like multi-platform APIs, which allow Lynx to be embedded into any frameworks or adapted to any operating system. So by embedding Lynx into the Qt, the CapCut can have their front end, their UIs written in front end techniques using Lynx. So there are a bunch of like actively working pages that is running on Lynx. What about the other way? When we are using front-end techniques, but we still want the native perf. All right, but I won't say that Electron's performance is really bad. Actually, I am a big fan of web technology, so I would say Electron is very fast in some cases, but there we do have some compliance about the Electron, right? So let me jump into what is Electron and say what's the trouble here. So Electron is a combination of Node.js and Chromium, where they use Node.js to let developers to write their main application logic, and use the Chromium to render the UI to let the developers write the web page to render the UI. So it would have two kind of process. One is the single main process, where the browser main and the Node.js or the system UI is running here. And within the Node.js environment, the developers can use a browser window where the UI will be rendered within the browser window. And the browser window is corresponding to a renderer process, usually in Chromium. And the renderer process will have the full web development environment provided for the developers. So can we see the problem here with the architecture of Electron? So the problem here is actually here, that the Electron will provide all the functionality for the full side of web application may needs, but when you like a native application don't need that functionality, you cannot strip it out from your binary. So that's my personal thinking, that browsers are operating system because they can run any random URL and run them as a web application. So it has to provide the full functionality and also maintain the standard and security. So as a result, it would suffer from a large binary and a lot of service to be initialized when starting. And also the native access have to be restricted to maintain the standard and security. But we are actually developing a native application using Electron, right? So what we want is we want the functionality we need bundled within our installer, but since we don't need, just removed away from our binary, right? So here that we can get back to the to this page. So we use Electron use Chromium to render UI, but Electron here is actually an operating system. It is just too heavy for Electron. So what is needed here is a UI renderer with web developer experience. So I would say Lynx would be a perfect fit into that part. So we get another product, we call it Lynxtron. So here is a demo of Lynxtron. The upper one is the Douyin running on Lynxtron. The startup time is halved by just migrating from Electron to Lynxtron. That would be the first feature I would introduce for Lynxtron. It is lightweight and fast. So the architecture of Lynxtron is very like to the Electron. The only difference here is that Electron would use a browser window, but Lynxtron would use a Lynx window. As I earlier mentioned, that Lynx is a UI renderer, so it does not have any other functionality other than the UI rendering, but still, like front-end coders have to have other utilities to code their front-end. So when it is needed, it can be extended by using native modules to extend the Lynx runtime. The native modules can be implemented directly using the system native API, or we can simply have a bridge back to the Node.js, where we can get the full capability of Node.js, and also we can get the full ecosystem from the Node.js. So we can get the things to work, just support as many things as Electron do in Lynxtron. And here is a code example here. Axios is a very famous front-end library running on Node.js and browser, which provide network functionality. And we can have Axios imported into Node.js and expose the APIs to the Lynx runtime, and everything get to work. But we can get even things more better with this kind of architecture. As I earlier mentioned, Lynx provides some like DOM API to interact with UI on the system UI thread. This still holds true in the architecture of Lynx. We can let the developers write code to handle the user's input immediately. And the second thing we can get from the architecture is that we can have the Node.js also running on our background runtime, where we can do some like native module, Node.js require file system, and we get a real JS object from Node.js. Yeah, but people may question that Electron do provide a flavor to have the Node.js running on the renderer process, but in practice, not a lot of people are doing this because like browsers can load an URL from an external source. So by having Node.js in the runtime environment, you are allowing like attackers to have a native system access, which is not really good. But Lynx is only a UI renderer, which means Lynx doesn't provide a standard capability of load an external URL or an external JavaScript resource. So it is perfectly fine for Lynx to do that. Then I will tell, after the introduction of the architecture of Lynxtron, I'm going to tell the migration story of the Douyin. Douyin is a very complex application. When they migrate from Electron to Lynxtron, it needs an incremental way to migrate it. So how do we do that? Is that by having the most important UI migrated to Lynx, but still we are leaving part of UI rendered using web. And how we suppose that is by having a web view as an extension to Lynxtron. Yes, Lynxtron itself does not have any support for web view, but we can have a web view as an extension. That would be the second feature I want to introduce for Lynxtron. That is natively extensible. Let me give you another example here. So if I want to write a really cool image editing software, then I need to have a very good canvas here. So I can, with the web techniques, I can implement the canvas using the web canvas component or the web GPU. Or I can implement the canvas natively by using Vulkan, Direct3D, Metal, and OpenGL. So in the case that we want to make a tools for Pro, the later one is always preferred because it gives us full native hardware access where we can do like deep optimization or implement some cool features. So if we abstract out the model, it would be like we have to have an external tester rendering with frontend, and all the interaction or users' logic have to be handled by the frontend because it is easier to run frontend code. And to have this kind of architecture in Electron, we do have some ways to do that. One is using the Chromium Pepper plugin API, but it is deprecated and recently already completely removed from Chromium. And the second way is that having a standalone window which covers upon the browser. But we will find some interaction cannot even be implemented in this way. For example, if I have a front-end component which is covered upon the front end and as well the external tester, it is completely not doable. And there is a third way that is to customize the browser. So there is simply no good way to do such things, right? But with Lynx, just as a native UI renderer, we are providing the extension C APIs, which we provide our life cycles, where the extension maker can register their extension or do some initialization here. And we are providing some like UI or testers extension API where the extension maker can have their tester embedded into Lynx. And the Lynx runtime is also exposing a subset of Node API, which the developers can write code in the open source standard to have their JavaScript function exposed to the front-end coder. And with those kind of APIs declared in C, so we can have the extension repo publishing its definition of JS and their binaries, compiled binaries to NPM. And for the front-end coder using Lynxtron, what they need to do is just to do an NPM install and import it in the front-end code. Without any touching of native code, the things get magically working for this for the project. So here is the demo here. So we require the binaries in front end. We have the UI declared in the front end code, and the front end methods are provided to interact with the interact between the external tester and front end. We can have a external tester running within our front-end code, and all those kind of interaction is implemented using front-end techniques, and all the interactions get smoothly. So that would be two things I have previously introduced. Lynx is lightweight and fast, and natively extensible. But we are still missing something. The Electron is using Chromium as renderer. It can share code between the web version. So can Lynx solve this problem? Yes, because Lynx actually supports the web platform. So that would be the third thing that I would introduce for Lynxtron, is that it is multi-platform. So here is a demo that we do provide like Lynx wheel on web, and it is implemented solely by using front-end techniques. And with the native module bridge on the web application, then we can get the MPC versions, renderer code working inside a browser. So you can see it is running in a browser here. And all the elements here are browser DOMs, HTMLs. Cool. So by combining two things together, we can get things really crazy, that Lynx can be embedded into a web view, and the web view can again be embedded into Lynx, which sounds mind-blowing, right? And for the multi-platform, actually, there are more platforms such as Android or iOS. And we have some other use case where the front-end page, like TikTok, Live, Gift, something like that, running inside the mobile. But we have a software called Live Studio that is provided for TikToker to stream their video. And the same part of front-end will be shown on their PC client. Yeah, so that's multi-platform. So today, I have introduced two production here. One is the Lynx multi-platform C API, and the second is Lynxtron, and we are open sourcing it by the end of year. But at the end of talking, I think I have missed something here, right? Yeah, where is the Linux? We do have some cool use case where the Lynx running on Linux. It's like we have Lynx running on Linux as a cloud service, where we render the front-end UI into video frames, and stream the video frames into the user's mobile phone. But still, we don't have really like implement the UI interaction, the real UI on Linux. So if my today's talking can convince you that Lynx is an exciting technology and it would be cool to have Lynx to write UI on Linux, then contribution or collaboration are super welcome to make Lynx on Linux even better. Thank you.
Thank you so much for the talk. I have a question online that is very related to what you were saying at the end. The question is, could Linkstron let TikTok run on Ubuntu?
Yes, as I previously introduced, we haven't bridged our UIs onto the GDK. So we don't have this thing implemented yet, but we do have some investigations about how can we support such things. So the answer is that we can support such things with not a lot of efforts, but we are still looking for the use case that, I'm in ByteDance working for TikTok, the manager have to let me have a clear purpose why I'm doing that, what's the value here. So we are open sourcing the Linkstron, and with the things open source to the open source, we will get plenty of needs and we can have the things done.
Awesome. I'm sure we can all support this use case. Any questions from team here? Yeah.
So Slack being written in Electron is the reason why most people need 33 or 64 gigs of RAM, right? You mentioned that you shave up performance and startup time radically. In terms of memory footprint and memory leaks and whatnot, what have you seen there?
Yes, actually, we do have a lot of optimization by using Linkstron compared to Electron. I'm not showing it is because, as I previously introduced, the Douyin application is still having a web view running inside it. So we don't have a real product that is solely built by Linkstron, but hopefully we can see it in the next year. So my today's product made by Linkstron also have a web view here, so we are not super optimized in the perspective of memory, so I'm not talking about it yet.
Fair enough.
Yeah, I think you're going to find quite a lot of enthusiasm in open source for Linkstron specifically, exactly as my colleague said. I think Electron is used by most of us and consumes a lot of our memory. I wanted to ask, how difficult is that, how to put it, how much do you have to patch the Electron version to work on Lynx? Because you've shown that, you call a different new Lynx window. Is that all? Is that just seamlessly patches itself in the backend, or is there more?
Yes, so the difference here is that when talking about the Node.js API, the APIs exposed in Node.js by Electron, they are almost the same, I would say. Although the Lynx window makes a huge difference because all the front-end logic there is running differently. And I would say other parts to migrate from Lynx to Electron is effortless because we do have what we do is just to have the fork the Electron code and modify the browser window there. So things get almost the same with the Electron.
All right. I'm sorry we're just out of time for now, but thank you so much for everything and for answering the questions.
Thank you.
As we prepare for our next session, we'll have 2 back-to-back sessions on AI, very exciting stuff. And after that, we'll have a break. So keep your energy in. It's only 40 minutes from now. We will have another break. And please join me in welcoming Hassan, Tasneem, and Hugo Huang. Or is it, I think it's Aaron today. Is Aaron here? Aaron Whitehouse? Okay. Okay, is Hassan here? Okay. Right, until we have some. Okay. Give us a couple of minutes and we'll be live again with the next session on AI. For now, again, I will have to say the reminders so it can get you started for the next session. You can see last questions you have scores. We have a few Easter eggs remaining within announcement mode. So we'll be in the next 1 or 2 hours to with us and have everyone ready now. So that's the hard bit has needs and that allows us to talk us through optimizing the workload with Ubuntu AI image.
Hey, hello everyone. Thank you for taking the time to our talk today about optimized AI images on Google Cloud provided by Ubuntu. You might be surprised that with this we have a little bit of technical difficulty or how challenges. So today, Aaron presenting with me. Just to introduce myself, my name is Hassan. I'm your product manager at Google Cloud.
I lead the public cloud and I've into Canonical, so we make our Ubuntu product work as well as the across public cloud.
Thank you. So this is that man never upset. Not the name right. So last year we did a presentation on CPX and how you can use CPX to power RDMA, which is remote memory access between GPUs without requiring a physical connection between the GPUs. So this year, we're going to go a bit further and talk about more latest data centers where there is a physical connection between the GPUs and how do you leverage that to improve performance. Because maybe next year we're going to have AI versions of us talking to you. So there's evolution happening. Without further ado, so as we know that the AI workloads are becoming more and more performance heavy. They demand a lot more performance. They require higher throughputs, particularly when you are talking about operating them in a cluster environment rather than in a single server environment. In the past, a lot of these data centers were running in some of the older GPUs where, or even in the older data centers where, a lot of cloud companies as well as on-prem data center did not really invest in creating a direct physical connection, sort of the RoCE connection, which is the RDMA over converged Ethernet connection between the GPUs. So the solution we came up back then is with TCPX, which essentially creates virtual channels to achieve the same result of RDMA. And just for context, I'm sure you are smarter than I am, but RDMA essentially offloads a lot of GPU to GPU communication from the memory and lets the memory and CPU focus on their own tasks. So that's what we talked about last year. Now, what is happening is obviously newer and newer GPUs are coming. NVIDIA is doing H100, B200s. And with the newer data centers now, we do have the ability to have GPUs talk to each other from on a physical connection. So that's what we are going to talk about today. First, we're going to talk a little bit about why do we need it? What are the challenges in terms of running these? Now, one of the biggest challenges that we're going to talk about today is exactly what the evolution is happening in the data centers and how do we make it easier for the actual end user or developer to still get the best experience and not have to go through all the entire setup of the software, kernel, operating system, and all of the technology stack that is required for AI workloads to operate properly. We are going to talk about how Canonical and Google partnered together to solve some of these challenges. And then we're going to go a little bit into the details of what Ubuntu AI images are that are available on Google Cloud, what exactly is packaged in there, and some of the details around that. So TCPX, as I was talking, is great, but with the evolution of data centers, customers now do want to use Mellanox networking, which is the NVIDIA networking cards. As these things are evolving, in the past we have an older GPU, some networking, probably Intel, but we move to newer data centers. We have servers that are particularly focused and built for AI workloads. A lot of them are full NVIDIA stacks for, from GPU to networking. Now the challenge becomes that how do you go from this point in the past to the newer point? And obviously one thing we could do is that give users the ability to like, hey, these are the softwares that you need to add to now your operating system image to also run it in the newer hardware. But then you're losing a lot of value of the cloud of management of the life cycle. So on our side, on the provider side from Google, as well as from Canonical, who builds Ubuntu, it's more work, but it makes users' life easier in the sense that now the onus is on us on how do we kind of make sure that you can move from an older hardware to a newer hardware. So the developers' focus really can remain on making on operating in the application layer, making sure that they can run their PyTorch, they can run their inference workloads, but they don't have to worry about the entire infrastructure stack, from hardware all the way to the operating system layer. So 2 years ago, me and Aaron and Hugo, we were like, hey, we have this problem coming. How do we kind of collaborate and partner with each other to kind of solve it? So that essentially brought us to the, okay, let's talk about what exactly we are trying to build here, right? So we have users who are in the past might be running older hardware with TCPX. Now they want to use newer hardware, with Mellanox, and they still want RDMA. They still want to run their AI inference workloads. They still want, all of the networking and GPUs in there, GPU drivers in there. So essentially, we are looking at a picture where like, okay, we need to have TCPX there, which is already there because it's the older, hardware that has Ubuntu still running and supported on. But then additionally, we also need MoFed, which is essentially the package, the NVIDIA package that includes Mellanox RDMA drivers, as well as NVIDIA networking drivers and GPU drivers. So we need both of them together, right? So that way, a user that is essentially might be using, in a cluster, might be using some old hardware, some new hardware. Or the user might be running this image with older hardware first, and then 6-7 months later, as newer and newer hardware becomes available, they can transition their operating system images to the newer one without having to go through all the rebuilding and all the repackaging effort. So ultimately, the main value of our work was that how do we make this, number one, transition easy? Number two, for any new user who's going to start with using the new hardware, how do we make their setup easy so that they don't have to bring up an Ubuntu image, worry about installing the right NVIDIA driver versions, right packages, and really worry about that whole compatibility list that's pretty complicated to manage. So going a little bit deeper into that, we really kind of broke down, okay, what exactly are we gonna, what does the system stack looks like, from the very base layer to the top. So we obviously have the system software, and then we have, our container runtimes with Docker. And then we have the application layer where we're talking about PyTorch, which are dependent on CUDA libraries, Nickel, MoFed, et cetera, et cetera. So what we decided is that, hey, we're going to focus one image to really worry about this system software layer. So for a user who's like, hey, I'm going to manage my own application layers, I'm going to build that. We have one offering, which is the accelerator images. And then we also have another one of images that is focusing on this entire chain where we publish deep learning VM images, where it includes the PyTorch, CUDA, and all of the other libraries. So I just wanted to introduce it a little bit, but I'm going to hand it over to Aaron to walk us a little bit in detail through this.
Aaron, who had lunch with the wrong person and got landed with this. So I think, when we've got these fancy new pieces of hardware, it really comes down to people wanting to use them for real workloads. And so it's great to have great instance types, but until you can use those for something in production, then you don't really have a product. And so in the traditional distribution world, we would solve that for you because we would package all of those pieces as a snapshot of open source that works well together and keep that maintained for very long periods of time, right? That's a huge part of the value that we offer as a distribution. The world of these sort of machine learning, deep learning images is in a bit of state of flux at the moment. And so while we're working on solving some of these problems in more comprehensive ways, in the meantime, people want to use these instances in the clouds now. And so in practice, there's a mix of different ways that is happening. And as Hassan mentions, at the moment on the Google ecosystem, what we've done is we've created an image that effectively enables the hardware with a more pure Ubuntu experience where people want to do things custom themselves. And then the Google team is building deep learning images that then stack on top of that the kinds of runtimes that you use. And the reason that we're doing that is because it's the ongoing problem that's the challenge. When things are coming from different places, you always have that risk that something's going to get updated in an inconsistent way, and then your very valuable instance is not going to work as you expected it because it won't boot, or it won't do what you expect because you've got an incompatible CUDA version with your driver version, or your PyTorch doesn't work with your CUDA, etc., etc. So that's why we've split things out as we have. So benchmarking is an interesting one. People always ask about benchmarks. Benchmarks can be problematic. I think the key point from the benchmarking piece, if you flick to the next slide, is, look, there's some numbers. More importantly than that is giving people the ability to actually run these things themselves. And one of the benchmarks you can use is PerfKit that's here. There's some instructions there on how you can use it. Works with Juju, if you want to use it with Juju. And that will let you run your own real-world tests on these instances, see how they're working in the sort of situations that you care most about. So that's the main reason for bringing this up, is to give you that access to those benchmarks you can run yourself. Next slide. Now, the sort of whole field of confidential computing in public cloud is massively interesting, and it tweaks the minds of people who are far more into this than me. And if you're interested in this space, there are some excellent pieces of content that have come out of Canonical's product manager on this, a lady named Ijlal, and that will give you how this stuff actually works. Now, I'm going to do a terrible job of summarizing it to those people who haven't got an intro to it. But in the cloud space particularly, confidential computing is interesting because it reduces your trust base in the public clouds. And that's powerful for customers because there are customers in regulated industries or where they don't, they have particular concerns about the confidentiality of their data, who previously weren't wanting to move to the clouds and are more comfortable doing so now that you're in a world where you can have confidential compute. What is confidential compute? Confidential compute is the idea that historically we had encryption at rest, we had encryption at transit, but there wasn't really such a thing as encryption in use. The memory and the CPU caches of the instances wouldn't be working on encrypted data except in specialized circumstances. With the advances in silicon around things like AMD SEV SNP and with Intel TDX, that's moved a little bit so that you can now have encrypted virtual machines where the other virtual machines or the cloud platform doesn't have access to that data as it's being used. And that's a very powerful technology for people who are wanting to use general in structure. So rather than coding specifically for a platform, just to be able to use a normal VM but have those kind of ideas of a reduced trust in your public cloud platform is a very powerful thing, both for the customers and for the public clouds who are trying to get some of those more resistant customers to come onto the platform. Now, historically, or in the first iterations, that was only at the CPU layer. What's interesting with some of the new technologies, like the H100 from NVIDIA, is that that trust boundary, or that secured boundary, has been extended into the GPU. And the idea is that your secret algorithms that you're wanting to run on your GPUs can also be protected by the same kinds of technology as the AMD SEV or Intel TX. So that's the general idea behind this work. And of course, it's one thing to use confidential computing, the other is to check that it is in fact secured. And so there is a whole piece around attestation that's not covered in these slides, but is a very important part of making sure that your flow is as secured as you think it is. Then the next piece is around creating secured operating system images. And as many of the people know in this room, it's not enough to create a secure operating system image. It's about delivering a continuous flow of security updates and making sure that on an ongoing basis, you have a secure operating system. And so the way that we do that is that we produce constantly refreshed images, where we're monitoring things like NECVEs in the critical boot chain of those virtual machines to decide when is the best time to republish new images. And the idea being that you can always go into the native mechanisms of the public clouds, and you can boot an Ubuntu image, and you're going to get one that is secured and ready to go. So that's one of the reasons why it's important to look at the origins of your operating system images when you're booting off the clouds, and why you might want to choose one of the ones that's from Ubuntu or built in partnership with Google, for example, rather than using one of the many Ubuntu images you might find on a cloud marketplace or something like that, because it's about that ongoing stream of security updates and the fact that when you boot a new image, it's got those up-to-date security fixes.
So, kind of zooming out from all the challenges we described and all the problems we described, if we can summarize it, there are two key things that we went on a mission to solve. One is that what is the best user experience when they're trying to run an AI workload? And essentially, it is that when you launch an image, it has all the necessary software that is going to make the underlying hardware work from the get-go without any additional steps. So that means that we have to package a lot of software that are, like Aaron mentioned, are coming from different sources. So that's the one, sort of the problem we were trying to solve. And then the second problem we are trying to solve is how do we maintain this over years and decades with the newer version of Ubuntu coming, with the newer version of all underlying software that is very dynamic, as well as the hardware that is changing. And the result of all of that, and then third one is obviously that we want to use these images in different type of workloads. So we're talking about confidential computing workloads, AI workloads, or HPC workloads. So we are obviously using them in different form or fashion. So the result of all of that work was that we launched the AI Accelerator Images, in partnership with Canonical for Ubuntu on Google Cloud. And essentially, this is the stuff that they include. They have the correct hardware drivers, both from GPU as well as networking perspective. We maintain the compatibility of those drivers. Whenever you go, and we're going to talk about it a little bit in the demo, whenever you go to select an image, it clearly shows like, hey, this is the driver version that you're going to be launching with. And then you can obviously enable it on confidential computing. We talked a little bit about how do we maintain the security as well as the compatibility with different container runtimes. So this is a quick snippet into how do you select these images. One of the goals that we have in partnership with Canonical is that we want to make it super easy and simple for the user to get the correct image. So we kind of want to remove the decision overhead from the user, like, I have these 100 images, which one should I use with this particular hardware? So what we do with the Canonical, with the Ubuntu images on Google Cloud is, once you select a hardware, it's only going to show you the correct image for that particular accelerated hardware. So here we're showing that you picked A5 or A4, I think. It doesn't say here, but I think this is from an A4 instance. And essentially, it is telling you that, hey, you have a Ubuntu 2404 LTS with the NVIDIA version 580. And we also talked about like NVIDIA CUDA stack, that in our accelerator images, we don't package the CUDA stack, but you do have the driver information to package it yourself, or we have the deep learning images, in which case we do package the CUDA. So essentially, a way to think about that is a lot of time our users, when they are just starting out, doing a proof of concept with an AI workload, they don't want to spend too much time setting up all the cluster stuff and all the infrastructure and all the applications. They just want to have a quick test environment, run it, see how it works, and once they're ready to kind of like, hey, okay, I know what we're doing, and then they're about to go production with that workload, then they really worry about the sort of the setup in detail. So the reason I'm explaining that is we have talked about two different types of images, and the deep learning image, where we do package CUDA as well as PyTorch, Jupyter Notebook, those kind of things, is for that proof of concept, because once you kind of run it, you do some proof of concept. After that, when a lot of our users are going to production, they become more sophisticated in the sense that they're like, oh, I know which version of PyTorch I'm going to run with which version of CUDA, and then a lot of times they end up managing those versions, because they obviously have their own application layer dependency on those versions too. So with that, I think I'm going to hand it over to Hugo. Hugo, are you there? We still got him on the video.
Hi everyone. Hopefully you may not think I'm AI here. So I will do a demo with you, and you will see how efficient and easily you can run a Ubuntu accelerator image on Google Cloud. So Hassan, can we just start demo? Yeah, here's a demo I did during the last weekend. We started accelerator image from the Google Cloud. We make sure that you choose the GPU and also selected the Ubuntu accelerator optimized OS here. And wait a couple seconds, you'll be able to SSH into this machine. Then you can easily check whether the CUDA version, the NVIDIA driver version is up to date. Now you see that it's 580. And now another important stuff we want to check is that whether it's affected by any vulnerabilities. With this easy command, we can see that this image that's not impacted by any of the specific CVEs we check. Well, let's do something more fun, and we will play with the two large language models, specifically DeepSeek. We will download it down Olama first, with a couple of seconds, and then we will download the smallest, 1.5 billion parameter DeepSeek version language model on this machine. And then we will ask the question about Ubuntu Summit, see if this machine know that, if this model know that. And then this is a more complicated task for this model. Basically ask what's the, please program the distance between to calculate the distance between the Earth and the Moon. And then we will do the same task with a larger model. we will see if the performance will be better. Well, it seems that the larger model knows a little bit more about the Ubuntu Summit. And then we can see whether it know better about the programming. By the way, if you look at the right side, you will see the performance, the real-time performance of this GPU card. You can see the memory usage and the power consumption. And we will do later on the Google console. You will see the difference between these two different models. It seems that this model have not really as fast as the smaller model. It's working so hard. Come on, can you tell me the final program? Okay, finally it's finished. So finally, we can go back to the Google console to actually see if there's any metrics or performance difference between these two models. This is in the Google console, you will see the monitor space, and we can directly go to the GPU to see the difference. You can see that there's two spikes here. There's smaller one and the bigger one in the later space, and so we expect the larger model will consume more resources. Okay, that's all the demo. Hope you enjoyed. Thank you.
Thank you, Hugo. It's the first time we have done it, as you can tell. All right, yeah, so we're ready to wrap up, but yeah, we have some time for any questions and answers, yeah?
All right, thank you, Aaron Hassan. Right, we have time, I think, for one question. Any questions for Aaron Hassan? Yeah.
One.
Hey, thank you for the talk. You started the talk about, quite interestingly, about clusters with different generations of things like networking cards. And I think you moved into kind of this deep learning framework container where you had, for example, MoFed as a way to solve that problem. Could you comment on whether having MoFed in the container is an example of how you deal with this multi-generation of hardware versus having those elements in the Ubuntu image itself? Wondering.
Do you want to take that, Aaron?
I'm just curious if there's a functional reason why having it in a container is better, or it could also be, is there a functional reason that it would be problematic or conflictual if it were in the Ubuntu image?
Yes, I don't remember the details of why it happened in this particular case, but I think you're right that the ideal is to have it as close to the operating system as possible. And it means that where we can keep things in sync. Historically, there have been, we just need to make sure that we're, keeping in compliance with all the required pieces of redistribution, etc., and trying to line those pieces up while still keeping things stable and secure over time. And those are always the balances, which gets more and more complicated as you're talking about external pieces rather than it all just being able to come through the distribution. So yeah, the ideal would be that you're able to get it all as part of the operating system underneath. but where you are trying to bring things in from a different place. That's where the containers have been.
Yeah,
used.
it's. I think the biggest reason for that is stability. So when you are doing MoFed container with PyTorch and all the other application, you do have to maintain a specific version tree, and that's the main reason you would containerize it. But yeah, it's not a static thing. We
ongoing collaboration.
Ongoing talking about like, okay, how do we package MoFed into the operating system, and yeah, there's a lot to come in the future.
All right. Thank you so much.
Thank you.
Thank you.
Thank you, everyone.
Right. If anyone has questions still online, please leave them on Discourse, and we'll make sure to answer them. Last question before the break, last session before the break, and one of my favorite, which is optimized AI inference in Ubuntu. Please welcome Eduardo and Farshid.
All right, we are very excited about today's presentation because we're actually doing an announcement. So today we will be giving you some details about a project that we've been working on over the past few months at Canonical. And before we go into the details of this announcement, it helps to paint a picture of the vision that we're going for. We want to explain the future we want to build. So we see Ubuntu as becoming the standard aggregation platform for AI models. We see AI models becoming a standard part of the compute experience, native to the compute. I can already hear some of you thinking, but wait a second, isn't that already the case? Don't we already all use AI models multiple times per day? Aren't AI models and LLMs already everywhere? That is correct, but the vision that we're going for is much more ambitious than that. In order to explain it, let me help by giving you an analogy. If you think about the early days of software development, starting in the early 90s, for instance, in order to get access to new software, you had to go look for it in a CD from your friend or from a floppy disk. That experience was very cumbersome, was very fragmented. Over the course of decades, that experience improved. It became much more smooth, much more streamlined. Thanks, for instance, to the likes of Slackware, the likes of Debian. They started by creating curated archives of software. But it was still quite a fragmented experience. You still had to go look for the specific repositories in order to get access to a certain package for your problem. We believe that by standing on the shoulders of these giants, with Ubuntu, we also helped improve that experience, so that today, Ubuntu is the de facto conduit of open source software. And think about how much has changed over the past few decades, from having to scout for the latest package and the latest repository, to simply treating packages and dependencies as a commodity as an application developer. Today, when you do development on Ubuntu, you don't have to worry about which repository is behind your package. You don't have to worry about pulling software from a certain OS vendor. You can just rely on the package system of Canonical and on the release cadence that we provide. What if we could do the same with AI models? The problem is that with AI models today, the problem is that it's very fragmented ecosystem. Instead, we want to treat AI models just like a commodity for application developers. The issue is that AI models today are everywhere, as I was mentioning. You have different models coming from different model vendors. For instance, in this example, you have Mistral AI, which is the vendor, providing a variety of models. They come with different shapes and sizes, with different size of parameters. And these are the base models that developers need to use for different use cases. If then you want a very tailored application, if you have a specific use case in mind, often you use an optimized model, what is called a fine-tuned model. In this example, you have the instruct model, which is fine-tuned, with 7 billion parameters. So already developers need to know, among this proliferation of models, which ones to pick for their specific use case. And this is just from one vendor. Of course, we are all aware of the proliferation of model vendors out there. And that is not enough, because a model on its own, at the end of the day, is just a collection of weights. You have billions of parameters that have been trained, but that is not enough to perform inference. To do inference, you need an inference engine. And what's the issue? The issue is that there are multiple inference engines per model, because they support different hardware features. LLM providers, silicon vendors themselves, they create different inference engines that work on different silicons. So now you have a matrix of complexity. You want to take advantage of the AI models, but as a developer, first of all, you need to pick the right model, whether it's a base model or a fine-tuned model. And then you need to match it to the right inference engine on your specific silicon in order to take advantage of the optimizations done at your hardware level. And it doesn't end here because the silicon vendors themselves provide silicon-optimized versions of the AI models. So what you end up in practice is developer leaving their hardware underutilized because they're not correctly picking the right inference engine. They're not using the right optimizations, which come in many forms, including quantization. And you have developers in this fragmented, cumbersome ecosystem, similar to the early days of software development. What if we could improve that experience? What if instead developers in a single click could simply get access to the right combination of model, inference engine, optimized for their hardware? What if they treat AI models just like a commodity as any other standard software artifact is on Ubuntu today? To give you more details, these are some of the examples of the inference engines that are available to this specific fine-tuned model by Mistral with 7 billion parameters. What if you could simplify that experience for developers and treat an AI model as a simple part of the compute experience that they can just access to start the development? Rashid.
Thank you. We work closely with various silicon vendors and try to make sure the best hardware that they create becomes available on Ubuntu to various users and developers. In practice, developers of embedded AI applications still have to deal with API keys, cloud subscriptions, and a lot of complexity, internet access. The reason for that is because it's very difficult to package and distribute and manage generative AI applications. Developers need to worry about tens of different silicons. They need to worry about various different combinations of the hardware. And even if they figure that out, they also need to deal with updates and newer generations of the hardware that come along. With inference snaps, we believe we have a solution that can tackle this problem. This solution is built around the Snap ecosystem, providing existing functionalities that have been developed over the decades for packaging, distribution, dependency management. And why not treat AI models the same way as typical software artifacts? We are trying to make it easier for hardware vendors to make their newest and best hardware available to developers that are trying to access and give their users the best experience. We have created an architecture, and we are open sourcing that architecture and the tooling today to make it possible for people to create generative AI snaps. We call them inference snaps. This architecture allows bundling various different combinations of runtimes and weights into a single snap, but deploy only what is needed and most optimal for the host machine. Let's jump into a demo, if it loads. This is OpenWebUI. This is my favorite client for dealing with LLMs. It's very feature complete. It gives me access to various endpoints that I have configured. Now, in practice, in many cases, this is not what I would need. I would need access to private and local APIs to deal with confidential and internal resources. I can quickly jump to a terminal and install an inference snap, in this case, QNVL. When I install it, it detects my hardware and it installs the right bits that are most optimized for my hardware. So as a user, I would get the best performance for my hardware, the performance that has been decided by the silicon vendors. You saw that OpenVINO was being installed because I have an Intel machine, and now you see that a model that has been compiled and optimized for my machine is being installed. If you do the same thing on another machine, it's going to give you something different. Now, this is fast forward. In practice, it takes a few more minutes to complete. But as soon as it's done, I can just grab a standard endpoint for this application, in this case, OpenAI. I can go and configure my client by easily pasting that URL. And as simple as that, I just install the snap, and my client is just ready to use that. Now I can access QN from this client directly. And then I can, this opens, different possibilities. I can save HR resources instead of, keeping them busy with trivial questions. I can just upload the policy and ask questions about it. The model ideally has the best performance available. So when I make queries, this makes the best use of my hardware. I can also hold a conversation. So this client actually suggests very good questions depending on the context. But I'm free to hold a rich conversation. And only if things don't work out, I go to the HR and ask questions from them directly. Or maybe I'm working on the next cool project that's still internal. I have a very difficult bug, an error in the terminal. I can just attach it. And then I can ask the AI for explanations on that. And this would give me an elaborate answer on that problem and possible ways of solving it. If I go back to the terminal, I can see that Intel GPU engine was automatically selected. This engine gives the best performance on my GPU. I can see that there were a bunch of other engines available. Not everything is compatible, but one was automatically selected. I can switch to something else and experiment. This slide wasn't updated, but the press release is available now. And please take a look. Please Google it. You will find it. And give us feedback. This is a beta testing. We want your feedback. We want to know whether this platform is the best for developers. We want to know whether this satisfies the requirements that you have. And we want to hear about everything. If you find bugs, file it. Thank you.
Thank you. So slides are like demos. They're not always ready. That's totally fine. London will have a short break until 4:30. Online, we will still have the stream going with music from the Creative Commons and especially curated for us for Ubuntu Summit. So please stay with us online. You will enjoy the music. For everyone else, I'll see you at 4:30. Thank you.
Christ was a handsome man. He had nothing to hide. He said, give bread to the hungry, bring the homeless inside. Jesus Christ was a dangerous man. That's the way that he died, saying, be good to the people you love. Love everybody you like. Be good to the people. Be good to the people. Be good to the people you love. Love everybody you like. Dr. King was a preacher. He had God on his side. He said, our God's children are brothers. Don't cast your brother aside. Dr. King was a dangerous man. That's the way that he died, saying, be good to the people you love. Love everybody you like. Be good to the people. Be good to
Living above the shelf, high on life itself. I got no serious qualms. These are the rosy days, feel it up in your face. All of the pigment, come on. We got a lot to lose, counting the ones and twos, but I don't try for no more. City gone with the flood, I'd rather fill my cup than try and swim for the shore. Oh, baby, say goodbye to living it down. Baby, say goodbye to living it down. I ate a frozen plum, running all down my thumb until my elbow go cold. William's a bastard son, but he knows when it comes that he ain't breaking no mold. Keeping the icebox clean when the weather get wet in Maine is easier said than done. Baby, I'm temper bound, bone dry and strung out, trying to keep my shirt on. Oh, baby, say goodbye to living it down. Baby, say goodbye to living it down. I hold the sermon down, it's more circus than clown, and I ain't laughing no more. We conjured up the game, made the kids come to play, so now it's more of a chore. Yeah, but still it's Papa's love, saving the now for blood, so yours had better run cold. Oh, integrity can wait. If you don't take the bait, then you'll be catching your own. Oh, baby, say goodbye to living it down. Baby, say goodbye to living it down. Oh, baby, say goodbye to living it down. Say goodbye to living it down.
Testing. Yes. Hello, everyone. Can I please have everyone seated? We're starting in a minute. Hello. It's very hard. Yeah, we are already late, right? So, guys, we are already late, so I would like to make a few announcements quickly. First, please, can we try to fill the first three rows? So anyone who's standing, can you please help us fill the rows in front? Thank you. Thank you. Okay. I have a few announcements before we go live for everyone here. At 5:30, after we finish the lightning talks, there will be an unconference from 5:30 to 6:30. You can attend any of the slots. It's open. On meeting rooms 3, we will have the design clinic. At the briefing room, we'll have the Qualcomm hardware demo. And after the unconference, after 6:30, we have a social event. We will have food, drinks, games, a lot of fun. So make sure you don't miss out that. It will happen at the Electric Shuffle London Tower. It's literally like 6 minutes from here, and it's very close to Hilton. So if you're staying in Hilton, it's a bonus, okay? All right. Welcome back, everyone. The next talk is all about education and qualifications. It's a very exciting talk, and we have another big announcement to make. So without further ado, let me welcome Ishani Ghoshal, who will speak to us about Canonical Academy.
So hi, everyone. I'm Ishani. I'm a product manager at Canonical. And today we are launching an exciting new platform, and we felt that the Ubuntu Summit would be the perfect place to make this announcement. So does this sentence sound familiar? Now, Ubuntu is an ancient African word, which means humanity to others, and I am what I am because of who we all are reflects that spirit. Now, we are because of our community. Ubuntu is all about collaboration. Every answer in a forum, every line of documentation, every code push, pull, every shared insight, it's what makes us who we are. Now, open source thrives on shared knowledge, and when you're trying to learn some things, it can often be very confusing. You don't know where to begin. So for example, if I'm trying to become a sysadmin, I don't know if I should study file management first or securing files first. And what is really important is that we have some guidance as to how we can piece all of these different sources of knowledge together. It might feel that you're trying to solve a jigsaw puzzle that has 1,000 pieces, and you need to figure out what fits where. Now, what if I told you that open source learning can be guided, accessible, and globally recognized? It is with Canonical Academy. Now, with Canonical Academy, we want to empower individuals and enterprises with comprehensive, industry-recognized qualifications to validate their professional skills. We are launching this new learning platform where you can gain qualifications with us, and we provide you study guides and exam guides so that you can prepare in this journey and get your first Canonical badges. Now, at the heart of Canonical Academy is a job-based qualification model. We specifically use the word qualifications, and it's similar to certifications, but the underlying meaning is the same. You take an exam, and then you get a badge. But we feel qualifications better capture our focus on real-world skills. With these exams, you actually take the tests in a real-world environment, and you'll be solving the problems you'll be solving in that particular job role. Now, you can also take the exams anywhere from the comfort of your home, schools, offices, or universities. And you can learn anytime, anywhere, in any order that you like based on the exam guides that we provide. And then, of course, you can gain recognized credentials. So with Canonical Academy, we want to help the test takers grow, and we are not just providing certifications. Like I said previously, if you take this exam and you pass, you'll feel confident that you can do a particular task and you can actually ace it. And I feel that's very powerful. The exams are updated with every LTS release. We have content that's created and vetted by the publishers of Ubuntu. And we have modular and real-world exams that follow a rigorous industry-recognized exam creation process. And I'll explain a bit more about the last 2 points in the following slides. So the exams are created by experts. There are 6 phases. The first phase is analysis. So what makes a qualified professional? We ask our SMEs that what tasks do you see fit for a particular job role? Then the second phase is design. We ask, how do we validate these job skills? So we form learning objectives in the first phase, and then we ask our SMEs, so do you agree with these objectives? The third is item dev. So this is where we are creating our item prototypes and questions. And we ask, how do we make them realistic? The SMEs give us a score, they give us feedback, and they help us do the error tolerance checks. The fourth phase is form dev. So now, if you were to take one exam twice, you would not get the same questions. And we need to ensure that all the variants are actually accurate and they're consistent. And we do these variants tests with the SMEs as well, so that we can make the exams reliable and secure. The fifth phase is implement, and this is where the beta testers come in. So how do we eliminate bias? If I feel that the passing score should be 70, but the beta testers feel that the average passing score should in fact be 75, then we adjust the score there, and this is where we get that kind of feedback. And also, should the exam be 90 minutes, or should it be 60 minutes or 75 minutes? The last one is when the exams are in general availability, evaluation. How do we make it credible? How do we know that once you've tested and launched everything, people are still liking the exam? So this is where we have item quality metrics, and we have exit surveys. You can fill our exit survey, let us know if you felt the exam was too hard, too difficult, or just right, too long, too short, just right, and then we take that feedback into account and we iterate. So this is what an exam looks like. You'll see that on the left, we have different sections that you can navigate through in whatever order you like. When I said it's real world, I meant it, because there are some questions where you actually need to run the commands in order to get the answer, and then you need to select the correct option. And we also have some Easter eggs. So we named 2 of our VMs as Warty and Artful after our LTS releases, and it's all running in an Ubuntu VM, as you can see. Then you can also go through specific sections. You can see what questions you flagged, if you viewed and didn't answer, if you saved something, if you have no responses, and then you can go back or you can complete your assessment. And you can see there's a timer as well, which tells you how much time you have to take the exam. So I also said that the exams are modular. And what I meant when I said that was that we have job-based tracks. So the sysadmin track here is a job-based qualification track. And each track has a set of exams. In this case, sysadmin has 4 exams. If you take all 4 of these exams and you pass them, then you get the overarching qualification badge. And you also get individual exam badges. The first exam that we have out right now is the using Linux terminal. We also have the Ubuntu desktop beta coming soon, and the Ubuntu server beta coming in November, followed by the server beta. And we have another exam planned for 2026. Now, I would like to remind you that the beta testing is absolutely free. And if you pass, you get a badge. So it's a great opportunity to earn a badge with us and help us improve the exams. So our vision for the future is to take the circle of friends one step further. We don't just see it as a learning platform. We see it as a movement for making open source mastery universal. We want every Ubuntu and Canonical user to have the skills and confidence to build the future of open infrastructure. So my team is not here with us in London, Adrian Mauricio, but I want to give them a huge shout out because they actually create the exams. But our team is not just limited to us 3. You can, in fact, join our team. You can be an SME. You can help shape the questions. You can be a tester. You can give us feedback on the exam content. And we also have a matrix channel, which is our learning forum. So in this channel, what we want to do is encourage test takers who have passed and who are striving to pass to share resources, tips, or ask questions, share guidance. And all our internal team members are also there. So in case you have any questions specifically for us, you can ask there, and we would be more than happy to answer. So these exams are actually built with the help of the community. We take your feedback, and and you are actually a very important part of how we take this forward. Take an exam with us. Now, everything that I said in the last 6-7 minutes, it's on our website as well. So if you go to canonical.com/academy or scan the QR, you'll find all of this information there, and you can try out your first exam, and when the desktop is out for beta, you can test it out for free as well. Lastly, we also have a giveaway for our online viewers who are watching the summit. So we really build these exams based on feedback, and we want your help in shaping Canonical Academy. If you go to this discourse post, you can tell us what technologies and tracks you would like to see next in the comments, and we'll be picking a few lucky winners who would get free exam keys as giveaways for the Using Linux Terminal exam. And yeah, and you can let us know how you like it. You can let us know in the Matrix channel or on Discourse. And yes, thank you.
Thank you, Nishani. I hope you're excited for this as all of us. I heard these exams are actually very hard, so try to test yourself. If you don't pass, maybe you buy the book and you pass at the end, so let's see how this goes. All right, so for our next session, and it will be the last official session of the day before we go to the lightning talks, we will have the Qualcomm team, and they will be presenting developer-ready Ubuntu on Qualcomm IoT platforms. We will have Amia Pandit, who's been with Qualcomm for 19 years. We'll have Adam Bickett, who's also been in Qualcomm for 19 years. And we'll have Pragya Patti as well, who's the director of product for IoT platforms at Qualcomm. For Ubuntu and Qualcomm goes way back, and there's a lot of interesting things happening. After you watch everything that they're showing today, there will be a hardware demo in the room, in the briefing room, after the lightning talks, so feel free to go there and check them out. A reminder to our folks online as well that you can always add questions to this course. You can ask any questions you have, and our teams will answer them. Even if they are not able to answer them now because of the time limit, they will make sure that they go back to you and answer all the questions you have, so keep them coming. As usual, you always have hiccups with demos. That's totally fine. We're used to that. We're almost there. Shani, I should have made people ask you more questions. That's my mistake. Yeah, but yeah. You still want to take a question? Putting on the line now. All right. Let's start.
Hey, thank you. Hey, thanks everybody. We are super excited to be here. Qualcomm and Canonical have been partnering now for quite some time, and we are here to show some of our work that we're doing on developer-ready platforms running integrated with Ubuntu. Oh. Sorry. Okay, I'll go to the next screen. So everybody knows Qualcomm has been an edge company for a very long time. And not to tout about our company, but we've been really good with communication and wireless connectivity, with increasing footprint on on-device AI and on the edge. We have increased our investments in this space, and we are essentially well positioned to basically cater all the way from smart home and networking to robotics to manufacturing to enterprise use cases and many more. And at the heart of all of this, we strongly believe that developers are key to our success. Now, all of this might seem to this audience as something like easy peasy, you do this every day, but in a Qualcomm machine, a developer first experience is something very, very new. The whole idea that we have to make sure that we prioritize developers. We are focused on open source software, participating in open source communities, both using and giving back to the communities is a new muscle we've grown over the last few years, especially in IoT, where we think this is 100% required. We've been trying to make sure we adhere to standards, to APIs, to processes, and such a way that our people are easily can swap between our competitors' hardware to ours. And to do so, we have been working to provide SDKs and tools, working to provide documentation, community forums, and an Ubuntu experience that people are used to. Recently, we increased our commitment to our developer community. We acquired Arduino. So Arduino has joined the Qualcomm family. This basically highlights our commitment for open source hardware with open source software. As part of this acquisition, we announced the Arduino Uno Q platform, which is based on Qualcomm Dragonwing QRB2210 processor. It runs with completely open source software with Debian Trixie, and this is the very first time, literally the very first time Qualcomm runs with complete open source software on our hardware. And we are already working with Canonical on our next gen Arduino platform, which will come preloaded with Ubuntu. So how did our journey start? We started in early 2024, and this year has been all about all the hard work we put last year for reaching the milestones and making releases. We now have on several platforms, both desktop and server versions supported and certified. These are some of the very few platforms we have been working on. So we have Ubuntu optimized images for QCS 5, QCS 6, and our IQ9 boxes. And if you're using one of those Snapdragon X Elite laptops, ARM laptops, they run out of the box Ubuntu image. Thank you to the Ubuntu community for all the assistance there. So please do, our roadmap is growing and we're adding more and more platforms in ready to use for any developer. So beyond providing open source hardware, open source software with Ubuntu, we also provide an end-to-end ML ops tool with Edge Impulse that allows you to take your own data, whether it is sensor, vision, audio, train it with a gamut of models that are available as a SaaS platform and go deploy it on the field. So this helps us complete our whole AI story from starting with hardware to software to deploying an AI ML apps. So how exactly did we get here? The journey was not simple. We are an embedded company, so we started with embedded systems, and now here we are with an experience with Ubuntu. So I have Adam, who was one of our principal engineers, and Amaya, who will join us later to talk about how they made it all possible.
Okay, so we'll start with what our overall Qualcomm Linux software stack looks like. It's not important too much on the details here. The key thing is coming historically from custom Yocto distribution means of giving our software. Most of what we had in place was focused on the image. It was focused on a full rootfs, same as open embedded build system using BitBake with layered recipes, We have these curated in MetaQCOM to comprise our BSP and our SDKs. Of course, with Yocto, you're generating this full image as your output, and we needed to start to look towards supporting Ubuntu, and we worked with our Canonical partners, but I just wanted to share some of the challenges, learnings, and things that even might seem trivial to many of you with the deep expertise, but it's just a way of thinking and a way of organizing your systems and infrastructure to be able to support the Ubuntu way. Having all of your software as discrete packages, enabling independent builds and updates, and the basics. And so these are some of the. Oh, looks like I got a little misaligned here. But first, it does take shifting the paradigm of how we saw our software and how we organized releasing that software. So from platform team, I was helping enable all of our software teams to work towards being able to think in terms of their deliverables as independent packages. So first, that just means enabling independent build. You can't rely on the recipe, all of the Yocto magic that is pulling in dependencies that you may or may not know completely or have not fully specified. Versioning is critical. Versioning becomes much more critical when you're working in independent packages. And so we had to build into our systems, taking that into account, work with our teams to properly version their shared libraries, have the concept of package versioning, and work in CI checks to ensure that this is upheld across those ABI and API boundaries. It's critical to manage your dependencies, understand your dependencies. So we had to break out from this nested recipes, true understanding of what your software depends on, and this gives a lot of insight into how you're intersecting with both the upstream projects that you're dependent on and the other modules within Qualcomm. And the final product does need to be a single build, but instead of focusing on the single image build as your custom output of your system, it needs to be assembled from the set of packages that all support all of our SoCs. And so this was a challenge, but it was a big success, I think, of all of our teams shaping how we deliver software to enable one common image and be able to install this functionality through packages. So after this, what we're working on now is open development. Start bringing these efforts onto GitHub, looking at implementing our packaging repositories, GitHub Actions and workflows to do the package building, and start to work directly with the community and open up the processes that are now shifted into supporting this new paradigm. Key part of that is focusing on upstream first development. It goes for both kernel and our user space stacks, and hoping the effort will excite people to be able to work on our platforms and maybe others who are looking at developing from a more embedded traditional framework of say, the Yocto builds. I think working with our canonical partners has been very beneficial, also in feeding back to our shared code base with Yocto, because these are all basic. The key items I went over are not, of course, novel here. It's just critical importance when you're dealing with the modular packages, and there isn't a large full build system to fall back on. So I'll hand off to Amaya now to go over some of the details of ours.
So, hello everyone. So thanks Pragya, thanks Adam. First, a big thanks to Cindy and her team, Qualcomm engineering teams who may be online, and the Canonical engineering teams as well. So what I'll touch upon is some of the details that Adam covered, but a little bit of a layout of what we have on Yocto, which is on the left side. I don't have a mouse, or no. Okay, what we have on the left side, which is essentially our technology stack, and how we have kind of managed to Debianize it in a way to move it to Ubuntu. So in a sense, as many of you know here, right, we will have certain Qualcomm or certain vendor-specific firmware artifacts which will remain proprietary. Those are boot and boot critical firmwares, the security firmware. There is an hypervisor EL2 layer that we have, which we run Gunya. That is something that we do it for our Yocto offerings as well as Ubuntu. And then essentially from the green and the blue boxes, right, are essentially all the OS level stuff, the HLOS or high level operating systems fit. So the common block between Yocto and Ubuntu is the red blocks. And of course the Linux managed firmwares, which are the DSP firmwares, video firmwares, GPU firmwares, those are all anyway contained as a part of rootfs. Now, what we have done is we have taken essentially the same QC firmware artifacts. On Qualcomm Linux, what Adam was pointing out too, we have 6.6 kernel. And then essentially since Yocto, it's custom, we build our own system image. But now with 2410, we had to realign our kernel base port and our SOC infra drivers to 6.8. And then also essentially the upstream technology, the technology stacks that we have, many of them have upstream components. I'll talk about base and custom quickly, but what we meant is all of this Debianization we had to do so that it gets accommodated or it gets assembled in the rootfs. Now, again, the key part here that I want to highlight and quickly touch upon is there are some technology stacks which are very SOC specific. So for example, like Pragya was showing, right? We have 4 reference platforms. Not all, like if I have to pick up, say, camera, for example, right? The camera kernel driver and the camera user space drivers, those are very SOC specific. That means we have a separate KO for one RB3 Gen 2 platform and one KO for RB8 platform. So we have to kind of come up with a way that it should accommodate or it should fit in that single system image concept. And many of you guys know this, so I won't cover it, but we worked with Canonical team. We had to come up with more like UDEV rules around it to make sure that the right KO is loaded based on some of the device attributes that we expose in our kernel drivers to make sure that, like say for RB3 Gen 2, RB3 Gen 2 KO is loaded, RB3 Gen 2 user space packages are loaded. Rightfully, it will happen for the future platforms as well, until we kind of have binary compatibility for all our kernel and user space drivers. Firmwares anyway will be different between different SoCs. Now, this is a little busy slide, so I'll talk later, but I want to kind of quickly again go over one workflow that you will see in the demo room with Edge Impulse. Jim is here, so he will also articulate a little bit more on the demo. But what here we want to highlight is we have our hardware blocks, the CPU, GPU, NPU, and the camera. NPUs are essentially the DSPs. And if you want to have a workflow, what are the packages that you need to kind of touch upon to make sure that you can realize an end-to-end use case? Say, for example, we have these three packages, CamX, G, and CamX libs. These are the packages that are there today in Qualcomm PPA. A developer can actually install them using the standard apt get package, the package mechanism. And then also these SDKs, which actually are an abstractions to these higher level plugins, the IM SDK plugins, which are again GStreamer based. So with a GStreamer front end hooked on to our camera and the graphics technology stack via the QNN SDK, we can actually delegate, or we can decide, a developer can decide what is the end payload they want to execute there, what they want to render it, which hardware they want to render it, whether it's on the GPU or on the NPU. So via configuration and these SDKs, you can actually create an end-to-end developer workflow. Now this picture which is shown here is the device we were trying to set up here. And what it shows is this is RB8. This is IQ9075 platform. Once you flash this with the boot firmwares, the Ubuntu root affairs, the Ubuntu device tree, once you do that, it becomes your workstation. That's in a way a developer's life, if I have to put it. You can actually use, it becomes a true SBC, which is going back to this slide. It's very verbose, so I won't go through it. But in essence, if you're patient enough, you can build the entire kernel on the device. So I have it built on my RB8. I can create multiple kernels. I can decide which kernel I want to load, depending on my grub configuration. And that allows developers to kind of tinker, to play, to kind of test the hardware and perhaps even break it. So this is one way where you can kind of really good for embedded developers coming from the Yocto background. There are other things, which is touchpoint 2, where Qualcomm PPA, which is what Adam was referring to, was that these all packages that was relayed out in that table, many of them can be downloaded. You can do on-device compilation on them. You can change the touch point, and then you can customize it. So in a sense, you have a way for a developer who buys the platform to take the source of the packages, to what extent they are allowed to. Like some of them are proprietary, but and essentially develop their own use cases around it. Of course, and with the apt Debian repository that we have through Ubuntu, right? It really makes life much easier for developers who are more accustomed to like a community Ubuntu environment. Whereas in the case of Yocto, where I come from, where we were dealing with very customer specific, it's a custom image, so it's very customer specific. So, but with Ubuntu, I think you will get a chance to experience the Qualcomm SoC and kind of work on these touch points that we have relayed out here. So with that, I think I can give it to Cindy, who can talk further. Yeah, thank you.
Yeah, so thank you to the Qualcomm team. I'm Cindy Goldberg. I'm here from Canonical. I'm actually speaking on behalf of our partners from Thundercom, Roger, Ali. We're thinking of you. I'll do my best to tell everybody about the amazing product that has now been launched thanks to the fruits of this work between Qualcomm and Canonical. And that is Rubik Pi 3. It's really nice, right? So let me tell you about it a little bit, and you'll be able to see more and play with them in the unconference room in just a little bit. So first of all, on the hardware side, we're starting with the 6490 chip that you heard about from Pragya, Adam, and Amaya. And so we start with this very high performance AI capability, as you saw, in a pretty small form factor, very much targeted to developers, so 12 TOPS, and high memory. So you have all this great hardware, looks like you're all probably very excited to go play with it. And then in terms of the software that we have on top, as we said, we have kind of an out-of-the-box, preloaded with Ubuntu. It just works, all of the features. We have Edge Impulse that Pragya spoke about, a recent acquisition from Qualcomm, bringing a lot of that AI software for the Edge applications directly as part of this experience with Rubik Pi, and a number of other applications kind of ready to get developers started. And so with this, Rubik Pi, this is where I do my game show host imitation. Anybody want to guess the retail price of this? There may be a prize waiting for you. Oh, Heinrich, you cheated. You looked at our other partner Arrow's website and saw that these Rubik Pis from Thundercom are indeed $99 as of today. So stop by our room. Thank you so much for all the teams who've worked on this. Thank you, Qualcomm, for giving us this opportunity to partner with Thundercom to bring 6490 directly to developers. This should be so much fun. Very excited to see what happens with it. So thank you.
Thank you, everyone. We have a question online, actually, and I would love to ask you before we go to lightning talks. There was a mention of choosing among different KOS to load for camera on different platforms. Would these different drivers also have their source available on these platforms?
Of course, there's a camera question.
Yeah, I thought it was that you picked the wrong component, but yeah, on an open source forum. But yeah, wrong question. But it's a good question, actually. So camera has two components, right? You know, KMD and the UMD, kernel mode driver, the user mode driver. The user mode drivers are proprietary as of this time. The kernel mode drivers, of course, you can get the kernel source from the Ubuntu source tree. So it's an out-of-tree kernel. So you can change the KMD, but user space is really tightly controlled. But having said that, right, like even though camera UMD is proprietary, what we allow for sensor makers is for them to create their own sensor binaries or sensor Debians, which then hook up directly on the Ubuntu platform. Like what Cindy was showing about Rubik Pi, in a sense, you have Raspberry Pi sensors that are attached to it. So our partner created those sensor Debians, and it works. So yes, today they are proprietary. The user space portion of it is completely proprietary. And the same goes for graphics. Okay. Just I'll relate.
Thank you very much. Yeah. Any last questions for the team? All right. Thank you.
Thank you.
All right. We're now moving to lightning talks. Can I first ask anyone who's doing a lightning talk to please come to the first seat? I have 5 of you, so we have 4 talks and 5 speakers, so please come in front. And let me explain a bit to everyone watching us online how this works. So lightning talks are 5-minute talks. When the speaker goes on, the timer starts. At exactly 5 minutes, you hear a very interesting sound. When you hear this sound, you have to give the clicker to the next presenter because they will take it from you. Okay? Are we ready? Yeah? All right. Starting our lightning talks is Cassidy James. Yeah.
Okay. Clicker. Here we go. Okay. Time started. I'm going to talk to you about Friends of Gnome. I'm Cassidy. I'm on the Gnome Foundation Board of Directors. And I'm going to talk to you about how Gnome is improving how we're funded for long-term sustainability. So how is Gnome funded? If you ask Reddit, you'll get some combination of these answers. I'm here to tell you unfortunately, or fortunately, I guess, those are not true. Gnome is actually funded with from a few different ways. First, there are grants that we get from either government programs or philanthropic donations for very specific initiatives. We also have an advisory board, which is where companies interested in the success of Gnome can come to the table and discuss things, discuss initiatives, and help advise the foundation. We do also have conferences, which are typically net neutral as far as like funding goes, but they can be a fundraising source. And then we also have end user donations, which all of that together actually brings in very little funding for the foundation, for broad initiatives that we want to do. So I do want to point out we are also very grateful, obviously, for contributions from people who work at companies like Canonical, contributing tons of code, because that is a huge part of sustaining Gnome as well. But as far as funding goes, there's not a whole lot here. So, happy face. Gnome has millions of users. That's really cool. There's millions of people out there using things like Ubuntu. Gnome has very little funding. How do we fix this? So we see our greatest opportunity for improvement in the near term is really through asking end users and talking to end users for donations. Historically, we've largely seen contributors being people who are actually donating as well, rather than end users who aren't also contributors. And if you ask an average Gnome user, they might not even know that they're using Gnome, let alone that Gnome needs funding to keep improving the software that they depend on their workstations. So in the past, we had this old donation website. If you see that little tiny square in the corner there, that was how you would donate to us. It was a janky iframe, and it was confusing and not a great design. So we started there. We designed a new Gnome donate website, donate.gnome.org, which if you scan that code, you can go there too. And it's a simple, clean mini site that's powered by Stripe. We also offer like really simple, small perks for donating, like you get your name on the website, which has been a pretty good success, actually. We are very close to hitting 500 recurring donors through Friends of Gnome, which is cool. You might see some tiny, tiny, tiny faces of people you recognize on there. And you can see this is a chart of the last 6 months, and that first big spike is June when we actually switched over to the new version of the site. So I would say it's been a success so far, but we can still do better, because this is people who land on the Gnome website, the donate.gnome.org. But how do we actually let more people know that they can go and donate? So first, we're being more vocal about it from the Gnome Foundation social media accounts and blogs. And if you are Gnome users or contributors, you can also be vocal about it as well and help us out. Let people know that they can actually go and help out Gnome. And then this is the most interesting part, I think, of the talk. In Gnome 49, we decided to try something new after talking with projects like Thunderbird, KDE, and Blender, who had seen a lot of success with things like this. So we actually, in Gnome 49 upstream, we have a little notification that shows up occasionally. It's once per release to inform users, hey, you're using Gnome, we could use your support. And we also have a persistent banner in the settings app as well that shows, that takes you to donate.gnome.org. And you'll notice this is not an Ubuntu screenshot, which we can talk about later. So what's next? First, I think there's a lot more we can do with those that messaging in those notifications. We can have more compelling messages there. We can also work with downstreams like Ubuntu and I think OpenSUSE who patch out some of those changes, and we can figure out a good middle ground and see what works best for both Gnome and downstreams. And I put question marks there on purpose. It's not just an unfinished slide. I would like to hear other people's thoughts after the talks about what else we could do. And you too can become a friend of Gnome. Thank you.
Hi, my name's Tim. I work in the Ubuntu release management team at Canonical. I'm here to talk about GUI testing using a new open source tool called YAF. What is Ubuntu GUI testing? This is a call to arms, that's why I'm here. this is Ubuntu GUI Testing. That's me. This is a new repository where we're storing all of our graphical test suites for various graphical applications that we ship, including, okay, what applications already have tests? Chromium, the Security Center, the firmware updater, various Gnome apps, the multipass front end, the prompting client, and most importantly, and what I've spent most of my time on, is the desktop installer. I've been doing this for about a year and a half now, and in that time we've automated all of these various desktop installer test cases, which basically covers all of the generic options that you would use in the desktop installer. There's some things that are a little bit harder to automate for various reasons, but I won't bother going into detail right now, but you can see we've covered basically the whole suite that we really, really, really care about, including TPM-FDE, which is important for the LTS because that's coming up and it's going to be officially supported instead of being in an experimental stage. So, tool flavors and community members, what can automating your GUI testing do for you? Here's what it did for me. When I joined Canonical a few years ago, this was me testing desktop ISOs on various laptops. For any flavors in the audience, you know what this is like. You sit around 4 or 5 laptops, some of them are running VMs, some of them are running on hardware. It's not fun, right? And we would submit and collate our test results on the ISO tracker, which may also be familiar to some of you and is also now dying. Thank God. And by the end of it, I would look like this, essentially. I would be completely exhausted from basically just clicking through a desktop installer, right? It just took so long. Now this is what my testing looks like. I just press a button. When it comes around to doing a release, this last release, don't tell my manager I did basically nothing. I just pressed this. I just pressed my test button. It was amazing. I had a great time. Thank you everyone else for doing the hard work. So what fun and exciting new framework are we using to do this graphical testing? YAF, which stands for Yet Another Robot Framework. This is YAF, like I said, open sourced in the last cycle. We've been developing it before that. What is it? It's a tool built on top of Robot Framework that allows developers to build graphical test suites to run against various different backends. It's written in Python. It's very, very simple and straightforward. I've been enjoying it a lot. How does it work? What is the TLDR of its usage? Basically, spawn a VM with a VNC server or spawn a MIR server. These are the 2 currently supported backends. Don't ask for testbed bootstrapping. I'm not having that conversation again. I've had it many times. It's a terrible idea. I'm not going to bother explaining it now. You will make an enemy of me. You then run YAF against your VNC or MIR server. And YAF has this built-in keyword called the template factory, which is where you take templates for your graphical test suite. You write your test by running through your manual steps from the YAF interactive shell. YAF saves the history of an interactive shell, and then you basically take that and you just put it into a graphical test suite. You don't have to do much more than that. It's very quick. What if you don't want to use VNC or MIR? Come and write your own backend. I wrote the VNC backend, and I don't know what I'm doing. So it's not difficult. It was about 250 lines of Python for the actual backend. Super straightforward. What if you want to use YAF to test GUI applications on hardware? Just spawn a VNC server or a MIR server on that hardware, point YAF to it, it will run. Straight, very easy. Why do I believe in it so much? Because like I've been emphasizing, it's so easy. Everyone that I've pushed this on, whilst they've been annoyed by me doing so, has found it very, very nice. And I've had great feedback from everyone in the desktop team. This is a brief example of what some YAF looks like. This is a function that selects LVM and encryption in the desktop installer. You can see we make sure we're on the disk setup page. We then move the pointer to some text that we know is on screen, or we assume is on screen. And then we also move the pointer to various PNGs, which, you know, this is old. This could actually just be text now. One of the main benefits of YAF is using OCR rather than template matching. This is what a template looks like. Super straightforward. So if you're a flavor or a community member, submit your tests to Ubuntu GUI Testing. We'll run them on our infrastructure. And this should help coordinate releases with the ISO tracker being dropped as well. Right now, the infrastructure Jenkins, I've got 7 seconds. We're working on a better infrastructure for the future that's kind of like auto package test, but for graphical testing. Thank you. Thank you to these people. Contact me, use YAF. Thanks.
All right. So we heard many good talks today about engineering, but today we're here to talk about design in open source. And I'm Nina, and joined by Leia, and we're both UX designers at Canonical. I don't think I have to convince anyone here about the importance of open software, how it accelerates innovation, and makes software more accessible. However, for a common person, it's still quite a niche concept. And it's quite generic perception that open source is hard to use. It can be quite overwhelming for new users, either because the learning curves are quite steep, or because the software itself caters to highly specialized audiences. So what should we do about it? Well, as designers, we think we could help. And it's not just us saying that. There has been a lot of research showing that UX can actually have a positive impact. So there has been a research that showed that companies focusing on user experience actually can achieve 200% increase in user adoption. But what do we really mean when we say design? We have a lot of different fields of design, and visual design is something that a lot of people think of when we say that. And usually it means branding, logo, illustrations. But when we talk about design, we actually talk about UX design. UX design looks at, well, user experience, which means looking at what the user is trying to achieve and how we can help them achieve with the least friction. We look at their entire journey, what problems are they trying to solve, and how we can help them with that. And then we have UI design. It can be sometimes the same people doing both things, but it can be also a bit more specialized. If UX design defines where the button should be, UI design will define how the button will look like and what the interaction with the button itself will feel like. And while we can talk more about it and how it can help, we thought, well, as UX designers and with a lot of maintainers being here, we can just help you become a little bit more UX savvy. So I'll hand it over to Leia, who will talk us through some actionable steps.
Yes. So first is your project description. This is very important because this is the entry point for new users and possible contributor. So you need to appeal to two different audiences with different needs. But overall, the main thing you need to do there is communicate why your project is important and why they should care. Then there is onboarding. So this is the first time a user will do anything with your project. So try to make it accessible and use that blank slate to communicate instruction to guide them through. Think about what they need to do to get value out of your project. So maybe they need to import some data, maybe they need to fill some forms. Try to think about how to make it easier for them to get started. Next is navigation, which is not just about menu. It's about how people find what they need and how to reach their goals. So to improve it, you need to understand who your users are, what they need, and what they're used to. Then you map the simplest path to help them get there without confusion. User testing and gut sorting are really helpful to understand how people really do these things. And then we also have feedback, which is really, really important, especially error messages. They make the difference between someone who's going to be a long-term user and someone who's just going to give up after the first problem. So when you build a tool, don't just think about the happy path. Think about what can go wrong and how you can guide the users through it, anticipate problems, and make things clear. And when you do send error messages, make sure that they don't disappear before someone can do anything about it. So these are just some of the ways you can make a project more accessible and attractive. If you want more design help with your projects, there are places where you can connect with designers, like contribute.design and opensourcedesign.com. Not .com, .net. You can also find some tips on canonical.design, but for today, you can also come talk to us. We will be in one of the rooms over there, and we will be very happy to help you out if you have any UX problems. So thank you.
Well, I have 21 extra seconds. No, okay, fine. So here is a landing slide. Here is a second landing slide. Hi, I'm Martin. I am working at Canonical at the Rocks team, and let me tell you a little bit about what Rocks are. A compulsory, although maybe not that compulsory slide about me, lightning talk, so lightning about me. I have an adorable cat, and I'm a chemist. I used to work with arsenic. It was fun. Okay, what are rocks? If you've never heard of rocks, this is the one thing I want you to take away, which is OCI compliant, Ubuntu-based container images. By the way, obviously, please take away more than just that. But this is the key bit. So when you do your Docker run blah, the blah could be a rock. What comes into what goes into a rock? So first of all, we have Rockcraft, which is one of the many family of craft tools, and we use Rockcraft to make rocks. You've got the kind of whole declarative power of craft applications with it, and you also get the pluggable isolated backend that we actually share with Spread. Spread is also Canonical's testing tool. Now, one of the things that we really care about with rocks is security and image size. And so to that extent, I said already that we are Ubuntu-based. We can also create so-called bare rocks. So there's an asterisk there because I guess if they're bare rocks, like if you know anything about images, there's nothing in them. Like, what do you mean Ubuntu-based? We can have the same layout, right? And we're also using Ubuntu as a build base, so we're kind of compliant with how Ubuntu likes to have its files organized. We also have a tool called Chisel, which is really cool. That's actually a tool I work with quite a lot. And Chisel is designed to take slices of depth packages. So, for example, imagine that you're, writing your Flask application, and you're like, well, I want to deploy it. I want to deploy it in a container, obviously, right? Because it would be nice. But you don't need core utils, shell. You don't need so many things in that container, right? So ideally, you just want Python, and in fact, maybe you don't even need all of Python. Maybe you just need like that little bit of standard library and that little bit of presumably Flask, right? So it's a way of making sure that your images are smaller and therefore more secure, because obviously somebody gets into your image and there's no shell. Oops. We also have Pebble, which is our PID1. This allows you to have services inside of a container, very useful for debugging and for monitoring. So a little bit about how rocks are actually built. So if you know any craft tools, then this is same idea. You've got a bunch of parts. Here they are in red, green, and blue. And there is 1, 2, 3, 4, 5, there's 6 steps. You pull in your sources. There's an overlay step, which is the only step where you can actually modify what's the base layer. So if you've got full base, like full Ubuntu file system, then that's where you can tinker with it. I actually usually don't interact with that step very much, because what we try to do is we try to have bare rocks. The kind of official canonical images try to be as as chiseled or as sliced as possible. So, then there's the build step. Build step is what you would imagine the build step is. This is your go build, cargo build, whatever. Stage is where it all comes together into one file system. And then there is also prime, which is like a pair step where you can also do like final adjustments. Sometimes some things depend on other parts, and this is usually where you want to put this. And of course, pack, you create your final artifact. Click it. Thank you. The final rock layout, we are compatible with OCI. So the stuff on the left is kind of generally, in fact, what it used to be, right? So we used to have our manifest, which points at oral blobs, including there's a bunch of config, there's a bunch of layers. What we actually do is we actually squash it all down into a single file system, and we drop in one more layer with a little bit of metadata, which is actually in the image itself. This is a very small, very small JSON file, right? Like it's very human readable. Yeah, that's lightning go through rocks. I will be here tomorrow at the unconference bit if you want to see some demos. If you have maybe you've built rocks, you want to ask me some questions, I will hopefully be able to help you. I don't know where the booth demo is going to be. Presumably in a booth. I don't know where the booth is. We shall find out tomorrow, I guess. Also, you can put QR codes into Stable Diffusion, and I've made a repo where I've put a bunch of examples. I'll put more examples. Yeah, I have 5 seconds left. This is the fastest I've ever done this.
QR codes are becoming more beautiful now. Right, thank you all. Can I please have a big round of applause for everyone who presented today? Yeah. The conference side of Ubuntu Summit is a wrap for day one. We are now going into unconference mode. There will be demos, brainstorming sessions, and for those watching us online, there is a Creative Commons music stream made by artists especially for Ubuntu Summit, so you cannot miss that, and it's a very good way to end your day. And you can always summon your inner Disco Dingo. For everyone in London, the unconference is from 5:30 to 6:30. You can attend any of the slots. It's completely open. Just walk around. You will see a nice tag in front of the meeting room. There will be a design clinic, as we mentioned, and there will be a Qualcomm hardware demo. After that conference, please don't forget, we will have a social event from 6:30. We will have food, drinks, and nice games. So don't forget to join us. It will be at the Electric Shuffle London Tower. People tell me it's 6 minutes away from here, so it's a very nice walk. And it's very close to the Hilton Hotel. So thank you all for being here. It's a wrap for day one. For tomorrow, we'll see you at 8:30 in the morning for coffee, and the day will start at 9:30. Thank you.